I think everything's working. I should be live now. Hello. I was trying to tweak the video settings so I can have like a higher resolution with like better compression so that my internet can keep up. But what I don't understand is my internet is apparently like more than fast enough to do this, but for whatever reason when I'm streaming I can only do like 1 kilo or 1 megabit. But like when I'm not streaming, like if I do a speed test, I get like way better. Like, so I don't know what the fuck's going on. So hopefully the stream doesn't look like shit because I broke something. I also still haven't restarted it, get rid of the close. I forgot to do that. Oops. What were we doing? We were doing speed tests. No, World Gan. World Gan. That's what we were doing. Okay. So I'm not entirely sure why, but rendering in the negative seems to give us bugs. It's just so dumb. It's just, how dare you show up where I am working, where you knew I would be. So rude. Yeah, I wanted to show you, after you left, I tried spawning in, like, basically a stress test where, you see I was going from, like, 0 to 32, because when I did negative 16 to positive 16, it breaks like shit in the negative, and I don't actually know why. Yeah, like, I have no idea why, but for some reason, in the negative space, it breaks. And it doesn't make sense. I think I also broke the shader, and I was supposed to go back and scrub through the thing and work out. I don't remember what we were doing with LOD, but this seems to be what's breaking it, is that because we're adding the LOD to the chunk's position, if the chunk's negative by more than like 1 chunk, it just doesn't work. I also need to fix whatever piece of code that I wrote that's supposed to be multi-threading. So like it just breaks. Apparently more than just one way, because they're all just like missing their top entirely. Maybe that's why it's broken. The fuck? Wait, why are they double chunked as well? I think I'm giving the wrong LOD chunk. That might also be not helping, because you can see that like, the chunks on the top don't line up with the chunks on the bottom. Which is weird. Do the positive chunks do that as well? No, it's something's broken entirely. I've broken something. Hello, welcome. I'm doing well today actually. I feel great. But I should probably stop playing Jurassic Park Evolution before the stream, because I keep like running right up like 10 minutes before the stream going, oh, can I get more done? Just like actually focus on doing the stream. So that's something to do with how I'm generating like LOD chunks, because I don't think it's broken. It's not broken near, but the LOD chunks are broken. So it's something about how I'm generating LOD chunks. Maybe that's what's breaking in the negative. I don't think it is, because I think even these normal chunks are broken in the negative. Also, wait, these are level 2 LOD chunks. The hell? Alright, what? The double hell? Why is there like a layer but... I think I fucked up some math there. Right. These chunks work? Okay, these chunks appear to be working, and then we get to the... Maybe they're not, it's really hard to tell. I think this might be the first LOD chunk, and it's causing... No? The fuck? It's offset by 1. Weird. Yeah, sure, I'll let... I don't think you need the top stuff. That's just what Bevy passes in, and the shade, like, it's just shader, like, pre-setting stuff. I don't think you need that, because it'll just clutter everything. I'll go to Discord. General. Right. So something I'm doing, maybe it's always been wrong and I just never noticed. Where is it? It's here. This is definitely the 0, 0, 0. Like, there's definitely a bug in the negatives because you can really see where, like, it's really obvious where it transitions from negative even when the LED should be 0. But there definitely appears to be an issue where we're rendering everything like one layer too high. Or like not rendering an edge. Does that mean we're not rendering the bottom? No. It's like rendering an extra. Now, my curiosity is, am I rendering an extra chunk or am I rendering just like an extra layer? Like, have we always had an extra layer on top or something? It's going to be here, I reckon. Right, I should probably not be using LOD. Right, that's probably what's going wrong, is I'm using LOD 0. Oh, I know we do need LOD 1. LOD. But we probably need to go into here and say, if LOD equals LOD, we'll return the baked mesh. So return the default mesh, only do the LED magic at the end. Sample modulo plus plus plus. Okay. Plus LED times a half. Something tells me we tried the times a half and that didn't work, but like I agree that it should probably be at the end. That makes more sense than anywhere else. I also need to like tone down the number of fucking chunks it's generating because it's still like horrendously slow. We'll go like plus or minus 8. Alright. So, is it my LOD generating thing? I think that might be what's causing it. Because I can't see a second layer now. Okay. And these are the negative ones, so the negative ones might be the one that's doing it. Whoop. Okay, yeah, so something in my LOD code is causing it to generate like one layer too high. It's probably that I'm passing in an LOD of 1. Like I'm passing in 1 when it should actually be... Yeah, it's probably getting the wrong number. Okay. Oh, good to know that's right. So you're saying if I swap the shader to being... it's hard to tell because I don't actually know where 0, 0 is. I'll have to put like some kind of marker to know which chunk is 0, 0, 0. But when we were fucking around with it yesterday, I did change something in the shader. Like I wanted to tweak something. I forgot to commit to Git before I did, so I don't actually know what I changed. The issue. But I suspect that it is one chunk works fine. So you can see there's something about this chunk is tessellating for some reason. And I think this is the 0 boundary. Is that something's happening here that makes it look really obvious that it's tessellating. And then this one's even more obvious. Like the more negative it gets, the more obvious it's happening. But that could also be that the LED's changing or something. But I think... so what have I got? So you're saying that it should be... not plus it. So you said it's positive modulo the chunk size plus the chunk size modulo the chunk size plus LOD times a half. Damn. Well, it's still tessellating, but it definitely looks better. There's something wrong because it seems to be like repeating, but maybe that's a bug with my implementation. It is actually cloning. I need to fix the LOD chunks so that they stop. Yeah, see, this is why you can't do the half, because the half causes the boundaries to be wrong. I think if we get rid of the half, the boundaries fix themselves. Yeah, you can't do the half. The half is part of what breaks it. Because we end up doing half steps. Alright, I need to work on what the LED, why the chunks are broken. So when I generate an LED chunk, I think what's happening is I'm doing this, which is Z times S, and on an LED of 2, the S is... Maybe it should be half. Is that LED? Like, I gotta reason what I'm doing. So the LED here. The LED 2 has a step of 2. So divide by 2. See, but I think it's supposed to be, or it should be 0 and then 2 and then 4 and 0. It's just not giving the same number back out, it's the issue. Why though? 2 plus Z? Wait. Ah, it's probably here. It's supposed to be S. S plus Z. LOD. Alright, this is like Z plus LOD step. Plus LOD step. It's already an FP2. So it's probably this. It's like we were just adding 2, but now it's like plus LOD. Yep. And then Y is also. Maybe that would make sense, but it doesn't know. We can check the single chunk, I guess, by making this like -1 and seeing if it still looks broken. We'll just close this quickly and go -1. We do -1. That should be one chunk into the negative, which should then, like, if it looks normal, then it's specifically that it's 2 chunks or more. Nah, there's something definitely wrong with. Also, that looks very repetitive. Maybe I'm fucking something up, because that looks like it's generating the same chunk, not that we're actually rendering. Like, definitely the LEDs are broken because they're returning tessellating patterns. Maybe, oh, maybe not. Okay, it might just be repeating because it's going across. Somehow it's like the random number generator is generating the same chunk multiple times. So it's actually just that the chunk is repeating itself in the negative, which is probably got something to do with me using negative numbers for seeds. So maybe it's not the LED that's breaking it. It's probably my random number generator being seeded from a. Okay. Yeah, that's probably what's doing. Okay. Yeah, I'll check that in a second. I think I've worked out why the World Gan's broken is that when I pass the generate, I'm using a random number generator, but I'm seeding the random number generator from the chunk ID, and I think I'm just clipping it, which means that if it's negative, then it's just the same. No, I'm not clipping it. I'm just shifting it, and just shifting it means that it's losing like the only point that holds any data. Where okay, when we say generate, we say seed. So yeah, the X as this. So this means that a -1 becomes like basically capped, and then you shift over. So maybe we should take like the absolute value, because I think it in my head it doesn't. Right, because it's negative Z, which is the only axis that we're actually going negative in. Negative Z suddenly makes everything else 1, and we're ORing. All right, yeah, that could do it. Does that fix it? Is it just that we were somehow... something still looks kind of funky about the negatives, but maybe that's because the negatives are a mirror of the positives, and therefore like that one line looks wrong. So yeah, it was just like I was ORing with -1 basically, or -2, or like basically any negative number meant that we were basically passing the same seed in because we were just sending 1. Where's my map? I'm gonna make the map like -8, +8, and then just make sure that it actually is still working properly. And then we'll swim inside some of the cubes and see if they're wrong. Okay, so it is mirroring it because we're obviously passing in the absolute, but that's fine for now because again, it's just about making it not. I don't think we're going far enough out to prop the big ones because there's a seam there. 1, 2. There's a seam there. There's 4 there. There should be a seam here, but there isn't. Interesting. No, I think they're cubes inside. Now, I do find it interesting that we see the top of that cube. Oh, no, because yeah, it's back faces. Yeah. Cool. Alright. I probably fixed the thing while you were reading the shader code, and that's why they don't look like they're cubes, but they actually were. They were just... I wasn't stepping by the LOD, I was stepping by 2. And so if the LOD was anything but 2, it meant that they were they're no longer lined up perfectly on the grid. Which causes it to sample weird shit because it starts sampling in weird places because the shader was sampling correctly. Alright. Oh, that's pretty cool. See, what I find really fun is if you fly up really, really high, you can really see the LOD changes. But I'm pretty sure the reason you can see the LOD changes is because I'm never updating these voxels to, or these chunks to update their LOD, which means that you can see the transition from one LOD to another. But if we were flying up, in theory, the ones directly below us would also be the same LOD as these ones because you can only see the transition, and the transition should be a sort of a minimum maximum distance away from you, like because you can't. I'm trying to get somewhere so I can see it and have the mouse on the screen. We'll fly over here. There we go. So like this is one LOD, and I think the other LOD starts like here, and then the next one starts here, and the next one starts there. It's like you can only really see it when you're moving because obviously these ones flicker a lot more than these ones do, which is cool. Oh yeah, that probably isn't helping either, is the YouTube compression from what amounts to the worst possible way of like this is like the worst case scenario for YouTube compression is that every single time the pixels change because there's just so much noise in the colors. So that's good transition on to let's do some World Gen stuff because World Gen will make it like significantly easier to not do that. So I think the mesh generator needs to hold wherever it went. Mesh generator. This needs to have like a noise thing, like a. I also need to fix whatever's causing it to stutter and not generate chunks like a bunch at a time. Honestly, it could literally be that I'm probably should be doing something like mesh generator world. So when we queue, we take queue, we run through queue. When do we put them back in the queue? Why do I need access to the queue still? Why do I swap that out? I think it's because I accessed self. Yeah, I access self. Yeah. What I'm saying is it's more like it's really obvious where the LOD transitions are, but I think because when you're actually near the ground, you can't see them at all. You can really obviously see where it goes from flickering noise to not flickering noise anymore, more than it is that you can see the transition. So like if it was an actual sphere around the player and not a really obvious line because I'm only doing the LED when I spawn the chunks in based from the distance to 0, 0, means that like you wouldn't actually be able to get far enough away to be able to see the transition because you would always be near chunks that are high LED or low LED, and then the chunks that are high LED are further away. So like you wouldn't theoretically be able to see them because of that. So what I should probably be doing is saying that this is take, not you. I want to say like Q is std. I know it's self dot q dot take. Like so, I can take specific values, but I can't like. Can I? I don't think I can like, okay, we can like iter take 10. Oh no, it's Bevy tasks max tasks and task thread note. Like max. Maybe the pool has it. There's a way you can get like Bevy to tell you how many thread them, maybe. So it's like returns a number of threads owned by the task pool. Sure. So we're gonna take that many things. Dot collect into a vector, please. Into a vector, yes. Into a vector. So collect. No, it must be like cloned. Yeah. So now we have that, and then we can say I guess we can just access up. So we can just say for q, right? And then we can say self.q.remove chunk, like that. So basically, we grab out the top. We grab out enough chunks to have one per thread per frame, and then we remove them from the queue. And that should mean that I don't need to do all this fancy mem swapping around. And it should hopefully also mean that it doesn't freeze up every single time, because it should only be queuing so many. Okay. Depending on your world gen, you could technically have full-size mountains looking down and see the banding a bit, but more. Yeah, but I'm saying I don't actually think that the issue is you would see the banding, because the banding's actually turning up because the chunks are keeping their LOD, but we're going away from the LOD. We should also probably not be doing like that. We definitely also need to sort based on distance from player. So what I'm saying is, like, if I came to here, the LOD would shift to being under me, and like these would be lower and these would be higher. Because when we're up here, there shouldn't be this banding, because over here, all of this is going to be basically the same LOD, because like we're further away from all these chunks. The thing that gives it away is that these are really low LOD, these are really high LOD, and these are even higher and even higher. But like the idea being, as we're further away, that they should all, like the higher ones should never be near the nearer ones while the near ones are small enough. Like when I come down here, you'll notice that like suddenly you can't really see the LOD anymore. It's not just that I'm so close to the ground, it's because the difference in the pixel sizes from here to here is unnoticeable. But when I come up here, these ones become basically pixels, but these don't. So I think it's the idea that we can only see it because we can actually get far enough away. Whereas if the LOD levels are always far enough away that the pixels transition properly, which maybe we need some more in-between LODs, which might be a bit difficult, because theoretically we could do half LODs, but it's more or less like if this LOD level is always this far away, then you can't see this LOD. Like this looks like this, which means that you wouldn't actually see the transition if we flipped it around, but that's because these ones are actually further away and it's a perspective view making them smaller. And I think that's why I reckon we can only see the banding so obviously because we can get far enough away with perspective view. If we weren't able to get far away from level 1 LODs, you wouldn't see the transition as harshly. Like by the time you got far enough away to see that harsh transition, there shouldn't be any ones. Right. So one thing we should probably set, I think actually Q might already be a hash set. And I'm using remove, yeah. Cool. So we probably actually need to say that we don't want to use a hash set. We want to go, and I'm going to say we're on World Gan even though we're still working on rendering, but technically this is World Gan because we're going to say index set, index map. We're making modifications so that World Gan looks better or works better. So the way that index map is going to work is we're going to say that you actually use an index set. And the difference between an index set and a hash set, what the fuck? It's an index set, please. What the fuck? Why are you reverting my changes? What? That's so strange. Okay, import index set. Let me make you an index set. So an index set is like a hash map, but it keeps the order at which things were inserted, which I mean technically for us is correct because we're inserting the chunks in the order that we want them generated. But what we're actually going to do is we're going to give you a the mesh gen here is going to get given a dirty flag, and we're going to say false. You can start false because there's nothing. We're going to say we're going to give you a then sort queue player position. We're going to say if self dot not dirty return, right, and then down here we're going to say the fuck, no, that is self dot dirty equals false. Right, we're going to say self dot queue dot sort sort by, and then it's a b, and we're going to say a dot distance squared b. Do reference b? Okay, so you need an ordering. Is it sort by key? No, because it's just because it's a thing. It's wait, sort. So sort by, what is it giving? It must be giving, so it must be sort by key. Sort by. The sort by takes in a function, compareF, that takes in t and t and returns an ordering. Oh, because we, yeah, okay, so it's a dot distance oh, Manhattan distance, Manhattan distance player maybe we'll go here and say let center equals player position sure, player position divided by chunk size dot to as IVEC 3. Right, so we say Manhattan distance to center compared to B Manhattan distance to center. That should work. So that we sort that and then we set dirty to false. And then when we queue something, we say self dot well if okay. So we could probably just OR this, just always set it and OR it. But basically what we're saying is if we queue something, we set the queue to dirty, if we queue, and then we sort the queue. I also feel like we can probably spawn a you know, let's say swap remove. We might have to actually like run it the other way. We may need to reverse this so that we like iter.reverse. We want to pop them off the end so that we're not rearranging the whole stack every time. I actually don't think that's necessarily true. The main reason that I think it has built-in Manhattan distance is because I'm using iVect. I think if you went into Unity and used iVectors, you would actually have Manhattan distance. Because it's one of those, it doesn't really apply to floats sort of thing. Like, I don't see anything. And annoyingly, I think I have to wait until everything's done because apparently I'm looking in the wrong direction. Like, it's here somewhere. It's just too far away. Yeah, okay. So we need to reorder it so that it starts closest to furthest because we're currently doing it furthest to closest, which is fun. So we need to say B comp A. The idea being that we want to take it off the end because if we're storing like a vector, we want to pop. We don't want to. So we're taking the endmost number of thread pools and we're going to change it by like, I don't know, 4. I don't know. It depends. Like, this is something that's pretty hard to know because it's depending on how many chunks you could generate in a frame. Basically, like you don't want to lag everything out by queuing up a million things, but you also don't want to like waste a whole lot of time because we're generating so many. Also, wait, did you still go the wrong way? Oh, because we're never actually ordering our queue. That's why. We need to say here. We need to say yeah. You do. Well, I guess technically it'd be before you do anything. So generating chunks. I'm gonna say. I mean, technically this should be the length of queue, the other queue. So this here. They're going to tell me how many chunks. Okay, so we're going to say self.thought queue. So we need to say single player is a single transform player entity with player entity. What do you mean fucking let bind? What the fuck is it? It's create player entity. Player entity is private. Fuck off. Okay. Pub player entity. Yeah, you're fucking the worst. All right, and then we say queue, and then we say player dot translation. Right. So we sort the queue with the current player's position. And then, well, I guess technically we should probably maybe do it every single time. Why are you saying you can't generate? Oh, because this is the wrong spot for this. You're just a vec3. You are the player's position. Like this, and then we go you get the player's player dot translation. Now technically this isn't going to work the best because if you move away from the player, if the player moves away, unknown field, what do you mean transform translation? Oh, it's because I forgot to fix this bit. Okay. Yeah, player position. Okay. Oops, spell that correctly. All right. So this should mean that when we add new chunks, we use the current player's position next time we go to spawn chunks to work out which ones are closest to the player and then use those. Which means that we should now be generating a nice little like Manhattan diamond away, which is good. We never actually update the chunks to use different things because we're going to work on that later. Oh no. That's also partly my thing, is it's YouTube saying, hey, I'm only giving them like half, not even, like it's like an eighth of the bandwidth they want. Oops. They're saying I'm giving them about 1.6 megabit and they want about 13 megabit, and I have no idea because when I do a speed test I can get those speeds, but like as soon as I start streaming, like fucking YouTube does not let me actually send that kind of like it's only sending 1 megabit, and it's like, so it drops a lot of frames. It's not dropping frames now because I've got it configured to settings. Where is it? Something about like balancing fucking bandwidth stream. No, output. Yeah, something in here was also causing it to lag because instead of we should turn off things that look ahead. I said like constant. What? It's running into issues where it's not dropping frames. Instead, it's just slowing down and trying to compress it better. Well, that's the thing, is it has my maximum bitrate, whatever I tell it, like whatever I send through. That it's only capping it at that because I've like I've explicitly told OBS to cap it at that. Like that's my scaled resolution if I go to video. So I'm taking in 4K and I'm scaling it down to 1440 and sending that to YouTube. If I sent the full 4K through, it tells me I can't do things like low latency mode, which is what I've got turned on so that you are not super far behind. But it's like you can't do 4K in low latency mode because YouTube doesn't have enough time to process the video. So it tells me that I'm not allowed to do that. Then I can drag this anyway and we can resume. Okay. So next is to add noise, I guess. And that's the fun thing. At the moment, because we're using a random number generator, we can generate these chunks at like the fucking speed of light. We can generate these chunks in like a few seconds. But next we're going to swap to using parallel noise. We're generating 16. Why does it not have like the full number of threads? That's annoying. Right, because it's changed here. It's so YouTube's Bevy's basically saying it only gets 4 async threads because I'm multiplying that number by 4. Which is kind of dumb. Why do you only get 4 in your task pool? Task pool, somewhere it pulls up like how many threads. Maybe I have to tell it somewhere. There's definitely a way you can like say, hey, async task pool, please track global task pool on main. I don't remember what it was. There was definitely a function you used to be able to call Bevy tasks. That was like maximum parallelization. Available parallelization.
Hello?
Hello?
Hi.
Hello. Welcome to the stream. I have to remind people that I'm actually streaming because I've had people come in like while I'm in the lounge and then they just say shit and go, "Oh man, I hope you're not streaming." I'm like,
So you're streaming?
Yep. That's why I'm in the lounges, because lets people join if they want to like talk instead of type.
Okay. Oh.
Yeah.
Oh, I mean, I haven't done Bevy stuff in a while. I need to get back on it.
Yeah, it's so good now. There's like I was fucking around. That's what like the stream was yesterday. I think it was the day before. I was adding a new like voxel implementation approach where instead of like generating a mesh, I just let Bevy do all of its like fancy optimization, culling and stuff like that, and just had one mesh that was every single possible voxel that could exist. And then in the shader, I discard if the voxel's empty using a 3D shade, three-dimensional texture to work out if the voxel's there or not. And it gets like 100 FPS with like 250,000 voxels. And it doesn't matter what the voxels look like. And then when you look away, you get like 700 FPS. So it's like Bevy's culling anything that you're not looking at. Like you don't need to do anything fancy. There's like the actual code that I wrote is about 15 lines. The shader is only like 5 lines.
Oh, dang.
Yeah, and it's purely about passing the data in the right way.
I haven't done anything that complicated. I was trying to make a color visualizer. I ended up using someone else's point cloud plugin they made. Has there been any good point clouds available that you've seen,
I haven't really
or how?
looked into point clouds. Not my thing.
Yeah, well, because at first I was doing the really stupid thing of just spawning a sphere. Well,
Yeah,
at
no,
least it was an icosphere, not like a full UV
it's
sphere.
fair enough. No, what you'd want to do is when you generate, I think it's your material, you can specify like the render mode somewhere, and you want to tell it to be points, not lines or triangles, and then you can just you can just spawn a mesh, and then every point, every vertex in the mesh is just it just renders a dot instead of a triangle.
Okay, yeah.
Yeah, it's basically a wireframe
Um,
but with no triangles, so there's no wires between the frame, and it just draws dots.
yeah. And then I don't know, I got caught up in I was making my own color library specifically because I'm kind of frustrated with computer color. I think a better approach would be to use. Are you familiar with how computer color works? I assume
Uh,
you have some.
but what do you, when you say computer color, do you mean like RGB or like the fact that every screen's slightly different? Like I understand color, but I don't know what you specifically mean with computer color.
Sorry, yeah. What I mean is that essentially it's a color cube, right? Because you get like
Yeah,
RGB values, you have 0 to 1 in all 3 dimensions.
yeah. Oh,
Yeah.
yeah, I see what you mean. Like cube, yeah. I'm thinking so. Whenever I've seen it, it's not a cube, but yeah, that's because we intentionally do things like green is more intense because green, so it ends up
Right,
being like a
yeah,
weird
because your eyes.
mud shape. Yeah,
Yeah, well, my issue is that like I always thought it was weird. So like you have red, green, and blue subpixels, right?
yep.
If you have a red subpixel on at the same time you have a green subpixel on, like at full power,
Yeah.
like is that how much brighter is those two subpixels on than a single subpixel? Because like you could
Uh,
say it's
I think that depends on the
is it
screen. From what I remember, it's the same brightness because what it does is it'll intentionally lower the brightness of the 2 pixels so that the total sum brightness is the same. But
well
maybe
like
that's not true because white screens are definitely
under
brighter
what
than
model?
red screens. Yeah, exactly. That's what I'm saying. Is it my
Yeah.
my mum had this thing for when she's doing photography called a color monkey, and it was like a device you would stick on your screen that had a camera in it that would basically like flash your screen different colors, and it would record what those colors were so that it could work out a calibration so that your screen looked the same as the other person's screen. So like it spat out like, hey, if you set your
Yeah.
screen settings to these, then now you know that what you see is. And the idea was that you could use it so that your image that printed was the same as the image that you could see. So it would like intentionally make your screen look like worse by lowering its saturation and everything so that it actually looked like a printed image when it was on screen.
Well, it's funny you say that. I was actually trying to make a similar device. The whole reason why I even got into Bevy was because I'm trying to build a device called a monochromator.
Oh, yeah.
Those already exist. They use a diffraction grating to separate light into the constituent
Yeah,
parts.
for doing spectrography. Yep.
Yeah. Apparently, modern they use a different technique now. But
They
what I
have
wanted to do was
4 pixels instead of 1. So they split the light and then they use 4, like an RGB and a UV LED or something to be able to pick up on not just how far it deflected, but what color it thinks it is.
Yeah. What I wanted to do though is I wanted to make an IRL HCl color picker. Because you can get hue basically from the wavelength going across the wavelength. You can get chroma by introducing back in white light, and then you can get you can use a neutral density filters on both those light sources to control the value or the luminance.
Okay, that's kind of cool.
Yeah. So I've been looking into. It's been a while. Frankly, my life has been kind of hectic.
No, that's mine.
Wanting to do this for a long time.
I haven't been doing Bevy for like basically like 6 months. I haven't touched Bevy, and then I was like, I couldn't take the stress at work, and I got my job, and I'm like, now I got to treat YouTube like a job. Like I don't have the subscribers to be able to support myself off YouTube, but I'm like, I'm gonna treat it like a job because I kind of quit my job, and I'm like, until I find something else, I kind of like need to treat it like work. So I've been doing like 6-hour live streams every day, kind of thing.
Yeah, I've been honestly, what's been taking up most of my time is I've got a server that I finally actually got working on the internet.
Ah, yes, that is a pain in the ass, isn't it?
Yeah, it's thankfully there was like a software called Pangolin that took out like 4 different applications I was gonna have to like hook
Oh yeah.
up together. But then I found out that it doesn't actually do one of those applications, so I had to pull that back in. The authentication, a single sign-on, I needed to use Authentic for because well, Pangolin does allow for single sign-on. It's only like it doesn't actually provide it doesn't actually hook into any of the other applications. So I had to. That was a whole thing, but
Yeah.
that's beside the point.
Well, my issue with
um,
servers is that I'm on Starlink, and Starlink's locked their router down, so you can't port forward shit.
well, no, so that's why so I was really frustrated because I kept moving, and then I was like some places everything's under carrier grade net, and then like a bunch of that. So I finally decided to I pay for a VPS
Okay.
as the egress point, and that's the whole reason why I'm using Well, that's part of the reason why I'm using Pangolin. I was gonna originally do it with Tailscale, but you can use Pangolin. You set it up on the VPS, and then they have a thing called Newt that you start run on your own server, and it creates it handles all the WireGuard secure tunnel for you.
Okay, it's like reverse VPN kind of thing.
Yeah. I mean, WireGuard is the VPN standard it uses to set up. It's kind of like Tailscale, but it also includes like a reverse proxy, and application kind of uh, you can handle applications like you can select a client device, and then you can select what port you're outputting, and then it handles all the TLS for you,
Goddamn.
which is pretty nice.
Yeah, my issue is that like I have this incessant need to know how things work. So like when everyone's like, "Oh, this program just does everything for you," I'm like, I end up like just trying to write my own like TCP server sort of thing, and it's like that's why I love Bevy, is because like I feel like I'm at that level of I am tinkering under the hood, even though Bevy gives me everything. Like I've written multiple voxel shaders where I've actually gone in and written the shader and got so angry at Bevy as I try to pull things in, and then this time I'm like, I have an idea that can do it, and to my head I was going, I'm doing the same level, I'm going really deep, but then when I was done I was like, it's only 15 lines of code. The hardest part was working out where to put the 15 lines of code so that they popped the things in the right places, and Bevy did the rest. But I understand how it works. Like, I know what it's doing on every level.
There's some stuff I love to do with that. Like I really like electronics and a lot of stuff.
Oh, you should check out my
I do not want to touch more web stuff, and I had to learn like Authentic. Like you have to set up flows to like log people in or like whatever you're doing. And like every single thing, I'm like, I want to reduce the technical debt.
Oh yeah, like I was trying to do something like I was making like a little like custom app that I was making for talking to YouTube's like APIs so that I could have stream integration where like people talking will do different things on stream, because I wanted to make it so people could play Snake in the chat, and it would like have snakes growing across my screen. And fuck me, is every crate on Rust that gives you auth is so bad, because they want to do it properly where like it's designed for like external parties to be able to interact with your auth, so you have to do all this signing and security and like you're giving like challenges and shit. I'm like, no, but it's me. Like, I'm the only person that's going to use this. I don't care if the auth is the worst fucking thing ever and I have to copy paste a text document. But they won't let you do it the easy way where auth's like, oh, if you just go to this website, like paste this into the URL, and then we'll do, we'll just ping you back. And it's like, oh, okay, I can do that manually, and I don't care, because once it's set up, and the token lasts like a year. But like, there's no way you'd make an actual application with that. So all the auths just don't expose that ability, because they're like, no, but that's bad. I'm like, I know, but it's easy. Fuck, I had to write my own auth, and then I had to write my own fucking thing to talk to the YouTube APIs, which are the worst fucking APIs in the world to talk to, because they're all we're free, but we're going to put fucking heavy usage on them. So like, if you want to access anything, you have to specify the fields that you want as well. It doesn't just give you all the information, because that's how they cut down on the bandwidth, is they're saying you request exactly what you want and we'll send you nothing more, nothing less.
You know, I can see why they do it, but that sounds terrible to have to do.
It is, but that's again like all the libraries are like, oh, we expose everything, and I'm like, I have no idea what I'm supposed to pass in because I don't know what it's giving me like a million
That's what I
things.
feel like. A lot of the time, I feel like they get like I want a tool, but they give me the whole machine shop, and then I have to figure out how to make the tool. It's like I just want the tool.
Yeah,
Um,
exactly. Like, it's like I don't mind having access to the machine shop, but please put a nice like you can request something be
yeah,
done
like some
for you,
sane
but also
defaults.
don't make it impossible to get to the unlike. That's like Bevy on in a nutshell to me is like where they're like, hey, we give you the default plugins if you don't want to set up a web thing. But I'm so if you do actual hardware stuff, you should look into my my Pico Bevy that I've got on my GitHub. It's like
Oh,
an abstraction layer so that you can run Bevy on a Pico RP Pico, and like I'm trying to make it so it's like a tiny OS that actually does like interrupt and shit, so that you can just like
so
not
like the
have to.
RTOS kind of thing.
I don't know. Say like I was using Embassy, and my annoyance with Embassy is it's async, so everything needs to be async. And I'm like, but I can't get Bevy to be async because it's not written async. So I just fucking went, all right, I'll take Embassy shit and I'll just use it as like an abstraction layer where like it has all the peripherals and everything, and then I make everything static and I make everything blocking, and then I just don't use async and I just let Bevy like schedule the tasks. And I'm like, well, they can't run at the same time because it's single threaded, which means that Bevy only queues one task at a time. I don't have to worry about like multiple things trying to access the same resource because it's not possible. It does mean that some things are really slow at the moment because you can't like queue up like DMA reads like and have something running in the background while you're doing something else because it's like you have to wait for it to finish. It's non-blocking.
Yeah, yeah. Are you familiar with what's the term for it? It's that was all of my microcontroller classes I did. You know, it's funny. I love Rust. I haven't ever sat down and actually written on a microcontroller with it, like spent the time to set that all up.
Oh,
I've
it's
wanted
so
to
nice.
for years.
When you get it going, it is great. It's like I think that people talk about it with C as
Yeah.
well, where it's such a pain to set up because you have to do everything. But then once you've got that base scaffolding done, you can just add something. It's like
Yeah.
it works. You don't have to worry about like what peripherals Rust because the way MBC set up is like each pin is its own type. And then those types implement what peripherals they're allowed to interact with. So if you try to make like an I2C that's using the wrong pins, it just says, no, I'm not compiling because you're using the wrong pins. Like it doesn't require you to go look up what the right pins were and make sure. It's like if you use the wrong pins, it just won't compile.
That's cool.
Yeah, and like, they're not just numbers, so you can do all sorts of other stuff with them. But like apparently it's all zero sized, which means that like when you compile it, the compiler rips all that out. It's only the compiler that needs to know these things before you start. It doesn't actually care once you're done.
Yeah, that makes sense. Yeah, I got some ESP32s because I had heard that they were really nice and like gave a bunch of like they have like a bunch of documentation, and they have like it's an official hardware abstraction there.
Yeah, that's why I
For
do
the
everything on
ESP32.
Raspberry Pis because that's actually true for them. The ESP32s, every time I've tried to use them, they're like, oh, yeah, we support it. And then it's just like a automatically generated wrapper around their C implementation. And it's so bad. I'm like, I can't work shit out because it's just like, oh, here's our example. And it's all fucking C. And I'm like, yeah, but like, how do I do it in Rust? And the answer is you just call them C shit.
I was trying to do some. I'd done some. I was using Arduino for a while with it, and there was like the U2F stuff. I was just really frustrated with a lot of the like, why is everything micro Python?
Because it's Python, but on like ESP32, so you just write Python. I'm gonna respond to someone in chat for a second, just so I don't talk over you. The memory bound controls. I think you mean like reading and writing to like peripherals that have fixed addresses. Is assume what you mean, or even just new set memory layers. Is that you can just make pointers in Rust and then turn them into types. So like I think I can just open the code. If I go to open folder YouTube projects, actually no, it's going to be crates, isn't it? Because mine's Pico Baby. So if we do something like so this is my actual example. I haven't got the quite compiling yet because I ripped it out of another project and it's not quite done. So I need to set up all the like critical section, spin locking and clock and stuff. But like to enable it, we just go like this interrupt, and then we just like enable, and enables down here. It like writes to a specific memory address. This is just a pointer, but like you can see it's holding phantom data, so it's 0 size. But when you actually call unmask, it internally gets the number out, and then it like gets the pointer, and the pointer is just a constant, and it just casts the pointer. Like it just does memory that way. Like I think that's what you're talking about. Like with C++, you can just do that, whereas like Rust, you have to like wrap everything in abstraction layers. But like it's not that bad once it's set up, and then it's all safe. Like the idea being that like in C, you still have to make sure you're pointing to the right pointer, whereas in Rust, once you've got the type, nobody else can ever change that pointer. Like it's locked into what you're doing. All right, anyway. I'm back to you. I was just explaining to someone, they were asking about how to do memory stuff.
Yeah. How was the... I just remember using like a going back to your point about like having to deal with like async with Bevy.
It's so bad.
What was I forget the term for it, but essentially where you have like a big switch statement for deciding what to do on each loop iteration through the loop.
Oh, the poll. When you poll something, you have am I done? Am I started yet? And am I still running? Switch case that you have to run through to be like
state machine. That's what it was.
Yeah, state machine. Yeah.
I remember doing a lot of that stuff in school, but yeah, for like low level microcontroller stuff. I ended up using some of that for when I was working for the power company, because we needed to set up a we basically needed to convert to a microgrid anytime the power was lost for this hotel. And so I went through every single step with a state machine on a real-time controller that would like open and close reclosers on the power line. It was a really cool project. I enjoyed. Did a lot of I've done a lot of PLC stuff.
I'm just going to respond to this person who said like elaborating that C's the C does it differently, and I think I understand what they're saying. With new in C++, the equivalent in Rust is just literally declaring a variable. Like if I just say something is something like when I call new on a function itself or call default, Rust uses it's got a fancy acronym. It's like DILL or something, and it just means that like declaration is initialization, and it's just basically when you say like colon default, you're doing the equivalent of C's new there. Like Rust does not let you have uninitialized memory without explicitly going out of your way of saying initialize this. When I talk about the pointer stuff, I'm saying like if you have a hardware peripheral at a specific address, you can just make a pointer to it in Rust, whereas because everyone goes, you can't do pointers in Rust. In C++, you do the same thing, and you might also wrap it in abstraction. The idea is that like if you write to this memory address, it does this hardware related thing, which I thought was what you were talking about, but you were saying like, how do you do memory declarations? And it's like with Rust, you can't not use new. Like there is no new. Every single function, unless you explicitly go out of your way, has when you declare it, you initialize it, and when it goes out of scope, it's deconstructed. Like the new and the delete of C++ is implicit in Rust. Like you can't not do it without like going out of your way. It's the default behavior. Anyway, you were saying you made a state machine for going through like the flow at a resort?
Well, yeah. So there was normally with a generator, you would just have a switchover. But we had an issue. There was like a solar cell setup. There's all sorts of things between the grid power and the power at the resort. So I had to set up it had to like close things in a specific sequence, verify a bunch of stuff, and then it would be on the grid. It would be off the grid power and onto the generation power. and close in on that side, and then to go backwards, you had to basically run through the entire state machine backwards. But I just made the same thing but backwards with some different
Fair enough. It's like
checks, but...
Unity's animation system where it's like you can flow from one state to another, but you can only go from certain states if there's actually a path that connects them. So you can't like just jump from one place to another. It has to actually have a valid way of getting there. And you put like intermediate steps where it's like, oh, if I'm going to do this, I have to make sure that I like turn the safety on and then like disconnect this. You can't just disconnect the thing. They're really great until you end up in like an invalid state that wasn't supposed to ever be accessible, and then you're fucked. That's why turning things on and off again works so well, is that like the programmer didn't consider that you may be able to somehow find a route that they didn't actually plan, and then now you're in somewhere where you're not supposed to be and there's no way out.
Well, isn't that part like isn't most of that just like leaking memory too?
Leaking memory is just more like it's really hard to do in Rust, funnily enough, but not necessarily, because you can just stick shit into a vector, and if you forget that it exists in that vector, then technically you're leaking memory. Leaking memory is just you as a programmer don't know that the memory exists, and most of the time it's that your program doesn't also know that it exists, but the operating system knows that it exists. That's why closing your program. It's like it's not actually lost. It's that the operating system gave it to you and you went cool and forgot the pointer and went, oh fuck, where'd that memory go? It's, you know, you leaked it because you didn't keep track of where it went. But the idea of like the state machine's more like you can't do things when you're in an invalid state, but sometimes you can end up in a position where it's like you have to turn the safety off before you can do this, and you thought you had turned the safety off, but now you're in a spot where you can't turn the safety back on because it tells you can't turn the safety on when it's off, but something else is telling you that you can't do that until you turn the safety off, because they're using two different switches for the safety, and you can't get to the other switch because you're on the wrong side of the door, kind of thing. It's like you've locked yourself in. You've locked the keys in the car, and you're like, fuck.
I deal with that all the. Oh man, I was dealing with that at work. I'm maintaining like some equipment and stuff there. Supposed to be moved to. I was supposed to be moved up to controls, but I guess they have too many controls guys right now. But there's this thing that you're supposed to be able to take a pallet out and then be able to send it back in. The send back in controls is just completely broken. And the programmer for it, or the controls guys, I can tell, if they just gave me PLC access, I would be able to make it, but it's just not functional.
You know, my favorite one with
that kind of same stuff.
My favorite thing with that kind of thing is when you have like some kind of binary interface because you need it to be fast, and then you like someone changes the versioning and you're like, oh fuck, now I gotta try and decipher what the fuck like binary it's actually sending out. So then you find these places where someone's converting it to a JSON file and then back again, because at least in the JSON file the ordering doesn't matter because you can read the fucking names and then put them in the right spots. It's great fun doing that. Like I did that with I was making like a sensor for my beehives, and it's like I didn't want to lose my data, so I was saving my data as strings onto my hard drive. Like whenever I got the sensor sent in the data, instead of saving the binary blob, I would just be like, all right, we're going to turn this into a file so that I can read it later when I forget what my fucking schema was for how the data was supposed to be sent.
Yeah.
So I don't like using databases. They scare me that you can't like turn off their compression and shit like that. So you're like, oops, there goes all my data because I forgot what I fucking set the compression to.
I'm definitely scared of databases too.
My favorite database is it's the best database in the world. It's called a file system DB, and it's literally where you just save everything in files and folders and let the operating system take care of the fucking.
You know what's better than that? Giant spreadsheet.
yeah, exactly. It's at least with a OS DB, is you can like put things into folders and stuff. I do like it's not a giant spreadsheet. Giant spreadsheets, like at least spreadsheet, files will actually have some kind of spreadsheet. No, what's the best one is just a singular CSV, just one big CSV.
Oh,
just like nothing.
Well, and then they try to load it into a spreadsheet software, and it
Yeah.
takes like 10 minutes to finally load up.
Well, it's even better because what happens when it's a giant CSV is that not every line is necessarily the same type. In that, like, the commas separating the CSV values may not actually represent the same. So you have a bunch of like, there's just like 6 commas that are empty because you didn't have those data fields, but you had to have them so that it kept the CSV in fucking the right shape.
Yeah.
Oh yeah, shit's
Then
done.
you realize that, oh no, I accidentally typed a comma in this
Yeah,
part.
there's one too many commas because you accidentally went and hand modified something, and you're like, oops.
Yeah. And then you should have done what is it, like tab comma separated?
Oh, was
Actually,
it,
like,
you know how Markiplier made his new movie recently? And it
oh
was
yeah, he stuck his whole server in a he built the whole server and put it in his bathroom.
There's that. The funny bit was the like relevant to what we're talking about is he's saying that when they first started, they had like 12 cinemas that were going to show it. So his I think his girlfriend or his wife or made a website that would show like a map with what cinema, and drop a little pin where like which cinemas were showing it. And then they were saying and then suddenly it started blowing up and every cinema was up, and we had to manually enter them into a spreadsheet.
Yeah.
So that spreadsheet would then render the website, and they were going, and there was no like, we had a script that automatically put that, no, but we had to open the spreadsheet and manually enter the like name of the place, the dates that it would be screening, and the GPS location so that the pin was in the right spot, manually into the spreadsheet. Like it wasn't like you go, oh, add a new add a new line, type in the value. No, they had to manually make sure they put it in the right spots. I was like, that's so bad. But they also weren't expecting it to go from we have like 10 cinemas to we have over 1,000 cinemas. So
Yeah. Yeah, people were joking around in some comments about like every company has that one spreadsheet that if it went away, the entire company would go under.
yeah, I saw a whole sequence of like YouTube shorts that were doing that, but it was the idea of that one employee that everyone thinks doesn't do anything, but when they try to fire him, they have to rehire him because everything stops working. Because he had like the one spreadsheet that he like every day, like he ticks yes to the box or whatever, that it says, "Do you want to extend this spreadsheet by 1?" That's like that's all he does, but he's the only person that knows it needs to be done. So it just like when he gets fired, like the whole fucking place goes down because it's like, oh no. I think Primogen had one where he was talking about that, where it was like they had that one spreadsheet that like every week they had to extend the spreadsheet manually by the 7 rows for the next day.
Jeez.
Well, yeah. So, and so then that was the intern's job, and it was like, but then like they forgot that was the intern's job, so eventually he became the full-time employee, that was his job, and then it's like everyone just kind of didn't know that he was doing it.
Yeah.
Oh my god.
Man, it's funny. A lot of the I was doing SCADA, where like SCADA is I forget what the acronym is, but basically anytime you have like an HMI for controlling some sort of equipment,
Okay.
it's all just like making a spreadsheet for like what the data is on every single level. You're just passing the data between all the components, so it's like spreadsheets all the way down.
Yeah, gotta love that. Spreadsheets all the way down. So dumb. Technology.
Yeah.
I mean, this is where vibe coding's like, it's one, a godsend because you can be that person that goes, oh, I'll just make something that actually fixes this problem because it's not going to take all day, because like a lot of this stuff it exists because it's not worth the engineer's time to fix it. But also that would have been worth the engineer's time if they'd fixed it 10 years ago. Like, was it the best time to have planted a tree is 10 years ago? The second best time to have planted a tree is right now. But it's that idea of like they're going, oh, but it's not worth it. And then it's like, yeah, and 10 years later when we're still doing it, it would have been worth it. But like vibe coding will make that great, but it'll also introduce so many more of those things where it's like nobody knew that the AI had added this one fucking line that was going to explode 10 years later.
This reminded me, do you know how airlines deal with like, oh, you missed, like we missed the flight deadline, so now we have to move everyone to the next airline.
I assume they copy paste it into an email and send it across. Seems like something
No,
fucking do.
there is a centralized database for like airplane listings and stuff.
Right.
But it was made in the 80s, and not a single company wants to be the one to actually spend the money to update the standard.
It's like they did that with like I want to say it's Visa and MasterCard did that horrible thing where they went, oh yeah, we're going to make a standard, and then they made it like nobody else is allowed to touch the standard, so they can't compete with them because like, every bank has to do its transfers through this so that Visa and MasterCard can fucking do their thing, and then it's like it's such a bad fucking standard. And nobody else can build the infrastructure to fucking replace it because it's a multi-billion-dollar infrastructure.
Did you hear about what happened? What was happening in Brazil? I watched a video about like apparently the Central Bank of Brazil offered like a payment service.
Oh yeah, they did what I'm talking about with Visa and that. All the banks around the world, when you do an international trade, all communicate on the same standard. And I think it's Brazil, China, Russia, like so it's BRICS is the acronym for it. Want to make a new one that is like, hey, like let's fucking go modern times. We will reinvent this thing to use the internet instead of like being designed to work with fucking Telegram. So they're going like, yeah. Someone says it's still the teletype. It probably is. Like I want to. Is it ASCII? That's like one of those things. It was like the reason that no ASCII character uses the first bit is because that bit was always 0. So because it was punch cards, and that was actually the thing that pulled the punch card through was that that's where the sprocket engaged. So that's why they're always got a 0 there, is because like you couldn't read that 8th bit because that was the bit that we used to pull the tape through the machine.
Probably.
And it wasn't like it wasn't ASCII this way. It was the ASCII was copying that one. Like ASCII went off that one, and that one had that. Like it was only 7 bits, and so they went, oh, we'll make it 8-bit because 8-bit computers da 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 da, and they went, oh, but all these are 0s because that bit didn't exist because it was just the roll thing. Like someone didn't realize that it was that. I guess I don't know. There's another one that was it's like why is hexadecimal like the shapes that it is or whatever, and it was like it boiled down to because when they did it there were like 10-bit computers, and so that's why they were that shape. Like I can't remember what it was. It was like why KJ was like something. It meant something. It was some kind of counting system. It was, and they're just saying that basically it boiled down to when computers were 16-bit or 10-bit going to 16-bit or something. They just sort of picked those letters because it was like legacy shit, and now it's standard everywhere.
Yeah. I'm still kind of frustrated though. Like, I was wanting to make a. I'm frustrated by the keyboard, like how keyboards work. I've been really wanting to make a software that you can have layers, like keyboard layers that you define. Mostly because I just want to be able to type in a degree symbol on my own keyboard. It just works.
Can't you do that?
Like what?
I think you could do that. You can customize the keys on the keyboard, like in like a software. You can go into Windows and you can tell it that you have a custom keyboard layer, and then you can say that when this key is pressed, because it doesn't actually send, oh, the K key was pressed. It sends that key something was pressed, and then you can do a custom Windows keyboard layout that lets you do that. And then you can then program one of your keys to basically be a macro that swaps to a different keyboard. I saw someone did it. They programmed a keyboard that was like clear keys on a like LCD screen, and then it used Hall effect sensors to detect which keys were being pressed. So they didn't have to run wires everywhere. It just used magnets. And then they could change what the screen displayed, so you could have infinite keyboards. And they made like an emoji keyboard and like a screen. It was awesome. I think they said it cost them like $2,000 though.
Yeah. Well, actually, I got it was like back in 2022, I think. There was the Nemio keyboard. It used e-paper.
Ooh, gross. Nice.
E-paper. And I think it was also using magnets, but a different style. I ended up they sent it out like last year. It took like forever.
I saw there was one that this person was inspired by that had tiny OLED displays on every single key.
Oh, I was looking into that. That's insanely expensive.
Yeah. Except what they're saying is that they could build their own that was even better for less than they could buy one. But it was also they didn't want individual screens. They wanted to be able to put things between the keys as well. So they went with one big screen.
Yeah, one big screen makes way more sense, especially because like if you have to move a screen, that means you have to have a display cable on every single key, and then you also have to have like
it did some fancy magic shit to do that. It was
But well, you can buy like OLED keys that have like it's weird. They're like $50 each. Like
Yeah, that's what they were
But
saying. Is like they went with a single keyboard because it meant that you could
This is the
So I'll paste it in the
yeah,
Discord for you. This is the best keyboard. I want to make one, but I'm like, man, they talked about how much shit it was to fucking make that I don't want to make one. It's one of the few videos where they've made something and I went, man, that would be cool, but fuck am I making that?
did you post it?
I'm just doing it now.
Okay, yeah.
I'm just tagging you so that you actually can find it easier. Yeah, so they've like put a screen over a bunch of Hall effect sensors. So when you push the key down, the magnetic field goes through the screen and triggers the like board underneath. So they don't actually need to have any cables to the keys. And it also uses the same magnets to lift the keys back up. That's how they set like where the keys float.
Yeah.
And then they're saying about having to write their own custom fucking thing. And apparently, if I remember correctly, Bluetooth doesn't fucking follow the standard. Like there's a universal standard for how fucking keyboards work. Like this is how when you plug a USB keyboard in, this is how it talks. And then Bluetooth says, "Fuck that, we're sending our own shit."
Bluetooth is so trash. I wish they would make a 6 gigahertz new standard. That's just like it's so bad. Bluetooth is just.
I think that was the same with this thing, that the hardest thing was finding a screen that was the right aspect ratio, because like screens apparently they're all 9:16, and then like actually what you'd want is about a 10:16 screen, because that was the old standard where it was like they went, well, we want a 9:16 display and also the taskbar, so they made them slightly taller. It's like old office computers were 10:16, and it was they're saying, oh, it's great size, and they had to find the screen, and I think they ended up buying like the old new stock thing of like a computer that got discontinued, so it's like they just had the screen modules for it. It's been a while since I watched the video. It's like the video I sent you is 3 months old. The original video is 2 years old.
Yeah. That I was thinking about that XKCD, like good new standard. Character encodings. I like that was in the original. AC chargers. Instant messaging. We were also talking about that one too. That's funny. Yeah. Well, I mean, I'm on Linux, so I don't really have some of the software that some people have made. Someone made like a Java, there's like an old Java one that you could make your own character mappings.
Damn.
But I want something like there's like QMK, like Vile, and I forget. There's a couple of ones where you can like edit your keyboard layout. I want like
so
just
I'm
in your
pretty
browser.
sure that's a standard thing for operating systems. Is there's a file like format that you can declare how the keyboard layout, because keyboards don't send letters, they send scan codes.
It's basically X and Y, and then it figures out, it does a lookup. The XKB standard is at least what Linux uses.
Yeah, and
the X keyboard.
XKB. Is that way fucking controllers work? Because my controller has a switch, like my fucking computer controller, it's like Logitech one. It has a switch that lets it switch from X to D, and like one makes it put out keyboard keys, as it's like each button is just a keyboard key, and then the other one like puts out actual controller, like a different controller standard. So I guess that's what the X and that is.
Yeah, and you can like make your own, but I just wanted a nice all-in-one software. I kind of wanted to make it, but
Headless Bevy, that's how you do it, because Bevy literally give you access to all the scan codes, and then you can just make it output a different key, and you just, I don't know how you do it with Linux, but you just need to send a instruction to the operating system. It's something like you can do what they call pass-through keys or something, where it's like the idea is that when someone clicks a key, you can say, actually, I don't want to capture this key, and pass it on to the operating system to say, actually, give it to the next application below me. And you could do that. And with Bevy, you could take it in, map it to something else, and then spit that key out saying, actually, I didn't want this key. And then Linux wouldn't know that you changed it.
Yeah, well, so that's IME, Input Manager Engine, I think.
Wouldn't know.
Any application you're typing characters into, often it's interpreting your keyboard anyways, which is kind of the issue. Like it's the reason why you can't just type in characters from your keyboard, like send the Unicode over. Although there's kind of support for that in QMK, it's weird. Like you can send anything within the ASCII range, which I tried using.
Yeah,
Because technically the degree symbol is within the ASCII range, I believe.
that does not sound right. I doubt it's there because the smiley face is the only non-letter.
Zero.
ASCII. What's the ASCII cat? No, chart. Why the fuck does the autocorrect sometimes? So I typed in chart and I went, no, that's spelt wrong. No, put cat.
00B0. Is that not within the ASCII range?
00B0. No, that's 4. That's 2 bytes. 00B0. ASCII has exclamation point, quotation mark, hash, $, percent, ampersand, dash, colon, open or close parentheses, asterisk, plus, comma, dash, full stop, slash, at sign, square brackets, slash, backslash, caret, underscore, tilde, and backtick are the only symbols. I think it has a smiley face, but I think the smiley face might be a Windows thing.
Well, because wasn't there extended ASCII?
Yeah, extended ASCII. Well? And extended ASCII had even more. And then it had like the
I think the degree symbol was.
Yeah, and then there. And then UTF-8 is then the extension on top of that, which uses ASCII up to the end of ASCII and then starts putting more characters after that. And I don't know if they said, "Oh, we'll continue extended," or if they said, "Fuck extended," and threw it in the bin.
Yeah. Because all the ASCII codes on Windows with the alt codes, I believe, use the extended ASCII.
No, they use UTF-8.
Well, yeah, but I mean, like the extended ASCII characters.
I'm pretty sure the number is you literally type in the UTF-8 number and it just does that.
Okay.
I think. I'm looking at the extended ASCII and I still don't see. Oh yeah, it is. It's 280. 248 is the degree symbol in extended ASCII.
Okay.
So it's right at the end there.
Yeah, but what I was just saying with it is I wanted a nice I want a visual editor where you can just edit the text, create your own layout, and then you can visually and then upload it to your computer as multiple key maps with a key map you can cycle the key maps a lot easier, but yeah. They're probably I found one application that was old that kind of does that, like an old Java Swing application, but I don't know.
Java Swing, okay.
Yeah. Do you know about Java Swing?
Does not ring a bell.
Oh, it was their old GUI library for making applications.
Oh, like applet ones.
Yeah.
I avoid Java like a fucking plague because Java is was one of those when I was growing up. Sort of everything was Java, but everyone bitched about Java. My SIM card runs Java. That's how old my SIM card is in my phone. But it was even I think actually modern SIM cards still run Java, but Java runs some stupid shit called applets that are applications, but not quite full applications. And it's you could load them onto your SIM card so that when you got a new phone, it would take things like your contacts with you. And it's but you could also load games like Snake onto the thing. It's your SIM card has 256K of memory on it.
This was back on old IKEA phones where they didn't, you couldn't also add a SD card, and SD cards were tiny back then too. So
I think even the earliest SD cards were still a gigabyte though. The smallest one I've ever remember getting was 512.
What
meg.
Did they have? They didn't have TF wasn't out yet. The micro SD cards. So you had to have a full size.
Yeah, but the smallest one of the full size that I've ever actually owned, I think, was 1 gig, and then the smallest one that I've ever seen was only 256 meg. Because the idea was the SD card was replacing the floppy disk, so nobody was going to buy it if it was smaller than a floppy disk, smaller
What I meant
in
is that
volume
you're
than a
not
floppy
going to be
disk.
sticking that in a phone, though.
Yeah, no,
Maybe a camera.
But that's what I'd say. Like, it's weird because that's what they call tech inertia, is the idea of like, even though the SD card would have been great improvement over a floppy disk because it's physically smaller and therefore you could just put multiple of them in the same space. So it was that idea of they didn't manufacture the SD card at any kind of scale until it was bigger than a floppy disk, like volume wise, like it could hold more, because they didn't think anyone was going to buy it just because it was physically smaller, because most people that were buying them were because they were after it. But like, oh, you remember the first iPhone had a fucking hard drive in it, like a HHD hard drive, like actual platter fucking spinning disc?
I didn't know iPhone had that.
No,
but I do
iPhone,
know a couple
iPad. First iPod. The very first iPod had one in it.
iPod. Okay.
It was the 1.6 inch hard drive that someone invented it, and they went, who the fuck's gonna do this? Like, where are you gonna put this? Because like it can hold I want to say half a gig of memory or something. And then, but like, who's gonna go over a half gig hard drive when you could just put a 3.5 inch and get like 30 gigs? Like what? And then Steve Jobs came along and went, oh, a hard drive that's small enough to fit in your pocket. Let me make a music device that can hold more music than they could fucking want in a lifetime. It could have like hundreds of hours of music, because they made a tiny hard drive. But it was the most insane thing ever. I remember being like, oh, I thought it was solid state. It's like, no, they just had a disc spinning at thousands of RPM in your pocket. You could listen to fucking music.
I love they have, well, with the laptops too, they all had an accelerometer in there, so if it was jostling too much, it would stop the read. So I think, I wonder how much with the buffer there, if you're like jostling it too much, what audio effects.
I guarantee you that they probably also had like a gyro that if you tilted it on, it stopped. Like you couldn't be doing it at 45 degrees. You had to be doing it like it would just stop if you were like at the wrong angle, because it would just not want to do it.
Isn't that a thing with the Xbox or something? There was like you had to be. You couldn't have it at a weird angle or something.
I think that was the red ringer disc. Is that it was the disk drive would fail, and they were saying that like if you had your like if it was flat or if it was on at 90 degrees, it was like it would last forever kind of thing. But if it was at like any kind of slight angle, then it was like the bearings were taking all the load, and it would red ring a disc, like red ring a death, like within like 6 months. There was also this thing about like the red ring of death came because they basically hot glued the fucking hard drive in. So if it got too hot, the glue would melt and the hard drive would then not be. So it's like if it was flat, it didn't matter because it was pressing itself back onto the glue. But when you had it at 90 degrees, the glue would melt and the hard drive would fall over, and then it would fuck the hard drive. Oh, dude. It was something like that. But yeah, it was fucking stupid. Because my favorite thing about the red ring of death is it was like a bunch of Xboxes went in the first like 3 months, and then like a bunch of Xboxes went 10 years later, because it was like they fixed the problem. So it stopped happening on new ones. But people that didn't know they had the ones susceptible to it also were unlikely to be moving their Xbox. And then it was like, so it wasn't until like years later that people started realizing that they had first editions, and then they just started red ringing a death, because it was like the glue also had like a life expectancy on it as well. Like it only lasted 10 years before it just sort of degraded to shit.
Man.
Fucking technology.
Yeah, I know, right? Going all the way back, I never explained my like I made what I was saying with the color model stuff.
Oh, yeah.
Normally you represent it using a cubic model, right? So you have 0 to 1 and red, green, and blue, or like HSV. You're also doing that. My idea was instead of going from like you go red to green, instead of it being like if you're trying to go between red to green, you either have to follow the edge of the cube or just cut straight across. And so that can create some weird issues, and they use like a gamma value to bring up the yellows. My idea was that instead of doing any of that, you used a vector, and then you just swung across on a circular path. And so instead of using a cubic model, you used a spherical model. So the luminance is the vector length.
If I remember, someone said actually posted the name of it in chat when we were talking earlier. Have you looked at OKLab? I think it's called. There's OKLCH,
okay lab.
which is supposed to be like corrected for human vision as well, and that fixes a lot of the issues that you were saying about like, because theoretically, and that's where your there's a HSV, HSI, or there's fucking hue saturation luminance or whatever it is. Fucking HSL. There we go. Fucking my brain is not working today. Letters. Fucking dyslexic shit. But that one's like the idea of being like you can't cut from red to green because the hue goes around a circle, and then like the saturation is how far into the middle you are, and the luminance is how bright you are, which I think technically means it must be a cylinder. Yeah. So because it's like so you can like.
Well, it's a cylinder representation.
And then
what I was doing.
It doesn't correct for the fact that we're more sensitive to greens, whereas OKLab does. It actually corrects for the fact that, like, if you increase the luminance by a little bit when you're green, you're going to make it way brighter than if you correct it by a little bit when it's actually red. So that corrects for all that kind of shit.
Well, so that's partially why I was building that device, the IRL HCL color picker, because I wanted to. I wanted to create the device so that in one eye you would be able to see a direct wavelength sweep, or points along a wavelength, the wavelength, and correct. Like you make sure that the you can adjust for. Essentially, you would see several points in one eye on the HSL or HCL IRL HCL crater, and then your left eye would be looking at a display. That way you're not seeing any background light or anything. You're just seeing two light inputs going into your eye, and you'd be able to adjust one to look identical to the other.
That does seem like a really good way of doing that, is to have the binocular vision effect, where it's like you basically put two binoculars on. One's got a screen that you've calibrated to be the right colors, and then the other one is just the screen that you're looking at, and then you just like click up and down until you go, I can't actually see that I'm looking at two different screens, because your brain's already blurring them together. And so it's like you just keep going until like the color didn't change, which means that I must be the right color, because both eyes are seeing the same color. So I don't see a rectangle. You have a shape maybe? So you can do it like in your calibrated screen, you render a shape, and on the main screen, you just render a solid color. And so as you click up and down, if you can still see the shape, it implies that your brain isn't deciding that these are the same colors.
Huh. Yeah, that'd be a cool way to do it.
Yeah, because you could run on the sensor vision, and then it's calibrated specifically to that person's eye, not just necessarily that the screens are outputting the same thing, but that you are literally unable to distinguish between the two screens.
Yeah, because there's several different, like, I'm just curious about, because you have component color, and then you have like wavelength-based color, and I want to know exactly, like, I don't know if there's like, if it adds exactly the same.
But see, the fun thing about that is that they definitely won't add the same, because especially for women, they have way more cones than we do, like different types of cones, because as men we have only one set of genes for encoding the cones, whereas women have two sets, which means that the women actually have 6 cones, but like 2 sets of them are red, 2 sets are green, and 2 sets are blue. But if they happen to have like a colorblind dad, they actually have 2 sets of like one, like in whichever the colorblind one is now actually 2 different colors that they can see. So they can actually, when they have a colorblind parent, can distinguish between like reds way better if their parent is colorblind to the point that they can't distinguish between reds, because they actually have a cone that like basically picks up like and puts like an extra data point for them for their brain to process. So they'd actually be able to distinguish more colors, and therefore what they would see versus the wavelength of light would be very different to what someone without the additional cones, like cones that are actually picking up the same wavelength, would see.
Well, I mean, I guess it depends on what type of colorblindness, because some are you just have way too many red cones and it overwhelms like the green cones. Well, red and green are you got the long, medium, and short.
Yeah.
I do know that there is 4 different or 3 different. You can have L plus and L minus, and then you can also have like S minus, I believe.
I think you can have all 3
which is
plus
close
and minus,
to like UV.
because the long is just is red, the medium is green and the short's blue. But
kind of, because like the actual peak, they're not quite on the you're differential. It's a differential pair. But someone I was seeing I was reading, someone said they basically could see yellow as a distinct color.
Yeah,
so like
which
an
means
RGB
that
screen,
they have
yellow.
they have the
So
red,
it was like
they
L
have,
minus.
They have red green color blindness. They can't distinguish between red green. So they actually have a cone that's in the middle. So whereas like when you have your red and your green have lots of overlap, if they have either their red cone is faulty so that it's slightly more picks up on slightly shorter wavelengths, or their green cone is faulty so it picks up on slightly longer wavelengths, it'll actually pick up in the middle, and therefore you can't actually tell which set of wavelengths it is. And then if it's a woman, then they can actually have that one and have the green and the red that are normal, which means that they'll be able to see yellow light without being colorblind. Whereas a man would just be colorblind. He wouldn't be able to distinguish between red and green because the cone can't tell them apart. Whereas they can, because they can have the two sets of working cones and a third set of cones that actually are in the middle. So they'd be able to see the in-between.
Yeah.
They actually have additional cones. So that's why it's so much rarer for women to be colorblind, is because colorblindness is one of the cones is not working properly. But if you just also have copies of the cones that work properly, then it doesn't matter that they're not working properly. It's like the idea of like, you're only blonde if your body doesn't make any pigment, which means that blonde should in theory be the rarest of the hair colors, because if any pigment gets made, your hair goes that color. It's that kind of thing. It's like it only doesn't work. It's where any gene that's recessive is like this. It implies an absence of something. So you actually can't have either of the genes working, or you have a presence of said thing, and therefore not an absence. Whereas dominant genes tend to be a presence of something, because it means it doesn't matter if you have only one copy, the thing is now there. And so it's that idea of like, because men only get one copy, then they are more susceptible to it. But also, there's no way for a man not to be colorblind with the gene. He can never have an additional receptor because he only has one copy, whereas women have two copies, so they can actually have the faulty and the working copies.
Well, it's funny. There's also a weird, like, from what I was reading in the, even like among the population though, like people's cones, especially like red and green, like for some people green, like for a lot of people green is brighter because you have more cones, and it's also kind of I think there's like a doubling effect to it.
It's not that I think there's more cones. We are more susceptible to green, but I think it's more to do with the fact that half of the red responds to green and half of the green responds to green, which means that you actually get twice as many cones responding to green light. That's why they call them short, medium, and long instead of red, blue, green when you start getting into science. It's because I'll see if I can find a picture. Are you watching the stream so I can like pull stuff up and show? Like
I'm not sure where you're streaming at. Is it YouTube
on
or Twitch?
On YouTube.
YouTube. I'm trying to look it up. But that's actually why the color bright lime, which is actually more of a citrus than a lime, but it is the brightest color to human vision. That's why the high vis vests are all that color, because that's the peak between the two. But what I was saying is that it's highly variant on the percentage of cones. Is what I was saying with the red and green. Like they were looking into multiple people's eyes.
Did you have to stream up just so I can show the diagram that I've found? It's trying to make me download it for some reason. I can drop you a link if you need.
Yeah, I mean, is it just the response chart?
Yeah, but it's like what I'm trying to talk about is the fact that the green and the red are basically fucking the same color, and then blue is fucking miles away. It's also missing a bit. It's supposed to have a tiny bit of blue right at the red
depending
end.
on which one. I was looking into the data they use for those response charts, trying to see if I could make my own chart based off of it, like find the actual data behind it. I think I was looking.
Yeah, but that's why we're more sensitive to green though, is because green is actually like the 500 nanometer, which means green is both red and both green and blue. Both green and red cones respond to green, so green will appear almost twice as bright as any other color because there's just twice as many colors. Like as long as even if you're in perfect third proportions, green would be twice as bright. It's that and that's why we also just struggle. Like, this is the most common color blindness, because it's really hard to distinguish between medium and long when the cones basically perfectly overlap. But the idea is that like women can have like a cone in the middle between like the short and the medium, and then they can distinguish all these colors so much more clearly. And they can also have one like in the long, like really far into the long, and they can see all the like infrared shit.
Yeah.
Or they can have one like really far into the ultraviolet and see all the ultraviolet shit. It's like men can't do that because they also wouldn't be able to see normal colors.
The ultraviolet one is kind of funny because it gets cut off by your own
by your own
cornea.
your ret does that. It's fun.
Yeah,
your
right
cornea.
there.
That's what cornea is.
Cornea.
Yeah.
But yeah. Oh man, I've really been wanting to make because like a lot. I've been wanting to make a YouTube video called "Light Blue is Not Cyan."
Yeah, it's what it is. It's like I'm trying to explain to someone that magenta doesn't exist, but magenta is still a color. Like my brother did that once, where he went, "Oh, magenta is not a color." I'm like, "Well, it is a color. It's not a wavelength of light. Like you can't have a magenta light bulb, but magenta is a color. Like we named it. We can distinguish between it. It's the same as orange isn't a wavelength of brown isn't a wavelength of light, but it's still a color. Like we've named it so it's a color, but it's not a wavelength. White, really brown is orange with contrast." Or orange in context. Maybe. I don't remember what the fuck
it's
saying
weird because like specularity is an aspect of color.
Fucking weird.
Like it's something golden reflective. Like it's just a interference with light, but you can also say that it is a color. It's a specific way of interference.
That's the thing. Is like what makes it not a color, I guess, is that you can't display gold on your monitor. Like you can't type in the RGB value for gold. So gold's not really a color. Gold is again, like it's sort of like how brown is orange, but in context. You need something else about the thing to make it look gold. Was it metallicity is the term when you do rendering.
Okay, I guess specularity is more how rough the surface is.
Specularity is the shiny point. Metallicity is, I guess, the reflectiveness. So a specular highlight means that like you can see where the sun is. The sun is making a shiny spot. Whereas metallicity is that you can actually see the sun and anyone standing around it. They're two different variables.
Yeah. But yeah, it's interesting because you can use like channels kind of in a similar way, like in a color channel. Like alpha transparency, like is that an aspect of color?
Yeah, I wouldn't say so because we used to use gels when I worked in a theater, and it's like you stick the gel in, and the gel's like weirdly, I think some of the gels were luminescent in that like they didn't just change the color; they actually like would absorb some of the higher wavelengths and reemit. So like blue gels were kind of shit because you had to really crank up the light to get the blue gel because you actually had to make blue light. Whereas the red gels, it's like fuck, just the tiniest bit of light behind them and everything went red because it would absorb all of the blue and reemit all fucking red.
Then that was fluorescent then.
Yeah, it's fluorescent is different again. I think it's luminescent.
I'm pretty sure. I thought fluorescent was when it reason why it looks brighter than surrounding light is because it absorbs and re-emits in that wavelength.
Luminescent and fluorescent. Fluorescent, I believe, means glows. Luminescent means absorbs and re-emits light. So like one is that like if you turn the light off, does it keep glowing? That's fluorescent. Whereas luminescent is if you shine a light on it, does it emit a different color of light? Like they're two very similar but slightly different things. One is like one absorbs it chemically and re-emits it, or like physically, like it does something that makes it re-emit the light later. Like you can turn the light off and it'll keep glowing. Is luminescent, and it's fluorescent, and then luminescent is that like if you shine a torch on it, it'll actually glow. It'll be brighter than the torch shining on it. I think. I maybe I've got that backwards, but I think that's what that.
So there's two different types of photoluminescence. You have fluorescence, which is where it absorbs, like when you shine UV and it glows a different color, or like. Yeah, but you were thinking of phosphorescence, which is where it emits its own light.
but that's from a phosphor on top, which is weird again.
Well, it's funny. It's called phosphorescence, but it's for anything that glows similar to like phosphorus.
but it's what I'm saying is we call that a phosphor because like that's what it's stupid. It's fucking stupid.
Yeah,
it's called a phosphor if it's a chemical that glows when exposed to it. I think the rule with a phosphor is it has to be able to emit light that's brighter than itself. Is what makes it different. So like there's a weird one that's like you can get green light by pumping in infrared, and it's like that should be possible. You shouldn't be able to get, but it's like as long as the light that it emits is exactly twice the wavelength of the light that you're putting in, it can absorb two at the same time and emit one at the higher. So it's like I think that's what makes it a phosphor, is that it can actually put out light that isn't going in. It can step up wavelengths. If it can only go down, it's one. If it can store it for later, it's another, and it's phosphorescent if it can go up. And it's insane because everything's got a fucking stupid name. I watch a lot of chemistry YouTube and they go on about like, oh, we're making this, we're making that. These fucking like super fucking pigments where it's like yttrium fucking something or other, where it's, you know, I shine fucking.
Oh, you're talking about like micro or quantum dots?
No, quantum dots are different again. Quantum dots use fucking their size
like
to do it.
A lot of them use the yttrium for stuff, or
it was a glow in the dark pigment that was we shine UV light on it and it glows for hours afterwards. And then they were like, oh, and there's another one that like if you shine infrared light on it, it glows in color, and they use it in infrared lasers for like knowing where the laser is. So you put this sheet down and the sheet glows green when the laser hits it, and it's like It's also uses yttrium because I think yttrium's got some fucked up electron pairs that make it do this kind of thing where it's like suddenly so that's why like the yttrium's used in the stuff that glows for a long time, because what it's actually doing is emitting the heat as visible light. So the idea is you need to mix it with some chemicals that for a very long time will slowly emit infrared light, and it'll turn that infrared light into visible light. And it's like, I guess, easier to store low energy photons that turn into infrared light for a long time compared to high energy photons or high energy electrons that would turn into blue light. It's like they really want to get the fuck out of there, so they drop down much quicker than the ones that would be turning into infrared. And also probably that you can do it over multiple steps, where if it's going to infrared, it's like it could emit 4 or 5 times as it jumps down, whereas like the blue is kind of like it has to jump really far, so it can only really do 2 or 3 jumps with the same amount of energy. So they don't tend to glow very long if it glows blue. Technology.
Yeah. It's funny, before I learned about the monochromator, I was trying to do it with, I was trying to use reference colors using LEDs. And I learned very quickly that LEDs suck for holding specific colors. And also there's like a gap in the green.
Yeah, I think that's because, again, the green's doing that weird... it's not actually green, it's a different chemical layered on top of something that's actually emitting infrared.
Well,
and
it's
infrared
the
is
red
green.
one, and then they use a phosphor, I believe.
Yeah, it turns it green. You can get pure green LEDs, but they're kind of bad. The thing is, every white LED is just blue or UV LED with a phosphor on top, because you can't make, like, every LED has to be monochromatic by the way that they work. So they just fucking add phosphors on top to get the other colors.
I think you can get some. You can get some weird variation, like, because it actually is not. I mean, it's not purely monochromatic.
There's a bleed, variant. But it's like they're monochromatic in that, like, they are emitting one peak wavelength.
Yeah.
And it's variations in crystal structure that make them emit either side. And technically, a perfect LED would be perfectly monochromatic. The only thing that's purely monochromatic is the sodium vapor. I think is the only light source that's purely monochromatic.
I know that's kind of the whole thing with quantum dots, is that they purely emit in the one wavelength.
No, they're just like LEDs. They are like, if you could make every dot perfectly the same size, then yes, they would all emit in exactly the same wavelength.
Yeah.
But we grow them, and it's the same thing with LEDs. It's like they would, if you had a perfect lattice of the crystal that they're made out of, would emit one wavelength. But if that one crystal is one atom over, then now it's one atom's wavelength wider, so it'll actually emit that wavelength, which, you know, at those kinds of things, is like, that's how you get that bleed, is that it's emitting. Basically, almost all of them are perfectly aligned, but any that are not are going to bleed away, basically an atom width wider or closer, depending. And you could have 2 or 3 missing. That means now it's 3 atom widths wider. Yeah.
Well, what kind of sucks with LEDs is that the color depends on the voltage.
Does it?
So
I didn't know.
Yeah,
The voltage. I thought it was only the temperature.
Well, the temperature. Well, it's weird because like, it's the. I mean, the voltage is the potential difference, so it's the electron. It's the.
I guess
power
the electron
jumping down.
jump. Yeah, it can jump more gaps if it's. I thought the
but-
temperature thing is it's like as the crystal expands, it also
It
shifts
is
the
the
fucking
temperature.
wavelength.
Because if you're supplying a constant amperage, the resistance, like it basically it changes because of the ambient temperature and voltage differences, because all that affects the like amperage and resistance along the system. Because you always need to put a resistor in line, and so the resistor, like all that is, so that's why like that's kind of the benefit of quantum dots over LEDs, because also like
Yeah, because
Make-
quantum
like,
dots
LED
won't change size, and also because you're not using re-emission, you're using some kind of weird fucking interference pattern. My favorite one is apparently green lasers are very, very dangerous because if they're too cold, they don't emit fucking green. They emit infrared, and they've all got filters in them that mean that you're they're not even on, and then you blind yourself because they're actually like emitting this fucking intensely. And ironically, because the efficiency is so bad, it's like a like 5 milliwatt green laser is probably putting out like 25 milliwatts of infrared when it's not being converted, and it's like that's so fucking dangerous that like that'll blind you.
That's why I'm always scared when people buy like cheap green lasers from like Wish. I'm like, please don't. They like point it around, like swing it around, like it's not like a complete health risk for people's eyes.
There's a YouTube channel I watch that does the whole like he analyzes them, and he basically says you can't fucking trust the sticker because he bought like a 5 milliwatt laser, like infrared, and it was putting out 25 UV. It was putting out 25 milliwatts, and then he bought a different one that was like a 5 watt laser or something, and it was putting out like 150 milliwatts. And I was like, well, that's a bit fucking shit. You can't trust the sticker. It's like incredibly dangerous. And he'd do other things, like he would test them when they were like, he put them in his freezer and then put them on his laser tester to see how much infrared they were bleeding and how good their filter was, because he's using a spectrogram so he could see the infrared. And he's like, look at this, as you watch the infrared decrease as the temperature raises inside, and it like starts actually putting out green light. This is a pretty cool channel, actually.
It's funny, we were talking about liquid crystals. Actually, I'm gonna share this link. I was working partially to work on this project. I was frustrated that there wasn't like there was. I found an open source project that supported like raycasting just in the browser. I was looking into there's some really expensive software you can find that like universities use, but this one had some color stuff. But I ended up adding what was it, color filters and dichromatic effects to it, which I thought was really cool to be able to do. I also I tried adding in diffraction gratings, but it turned out to be a lot harder than I thought, and the lead developer ended up helping me finish it.
That YouTube channel, so maybe I'll send you the link to that as well. He showed a really, really great way of measuring the wavelength of a laser using a diffraction grating, and he used to like a meter ruler. So he set up the laser on the desk and put the diffraction grating in, and then just like measured it with a ruler and calculated what the wavelength would have to be for the 3 dots to be the distance that they were.
Yeah.
Yeah,
That's what I learned in physics in college.
I think
there's a really good calculator online that gives you the just looking at one, that's what I was using for my project. I'm doing 1200 lines per millimeter, and it gives a decent, like too many more lines per millimeter, it becomes way too unwieldy.
What you probably also
not...
want to get is I think they're called micrometer stands or whatever. So like, do you know what a micrometer is? It's like a precision measuring instrument for you measure
Yeah.
Yeah, so you can get just
Oh,
the
really?
adjustment dial of those, but like on a block, so that you can adjust by. I think the accuracy of the actual readout is to the 10 microns, even though they're called micrometers. But anyway, but you can also get ones with a vernier scale on the side that lets you go down to the micron, and you can adjust them like super accurately to be able to like adjust your laser so that you can basically dial it in to exactly the right distance to get what you want to, like if you want to measure something exactly,
Oh.
and like
Well,
and make
so
fine adjustments and stuff like that.
the issue I was running into is I wanted to put I want to make this all motorized.
Or you can just stick a stepper motor onto it. But the idea is that
Yeah,
they're
yeah.
just a tiny thread. They're like a cheap way to get a 0.1 millimeter pitch thread with
Yeah.
the markings
Well,
marked
so
on
I
it.
found there is a project and they have a whole Discord for it too, but he was using a bunch of magnets in a row around a curve. And then I think I can't remember. It was some sort of magnetic sensor, and he used like the change in rotation on the magnetic flux.
Yeah,
You can get
Hall
like
effect sensors can do that. Yeah.
yeah, you can get like micrometer
Um,
measurements,
yeah,
which is
I've got one that's it's accurate to like 4,000 divisions per revolution or something. I don't know how accurate the actual chip is, but like that's its resolution is it can put out 4,000 steps per revolution. So if you attach that to a micrometer adjustment, it would give you a resolution of like I guess a 4,000, so 8,000th of a millimeter, which would be less than a micron. Then you just got to worry about backlash.
geez. Well, so I mean I was gonna do straight off the stepper, so you wouldn't have to worry about backlash. I was also looking into
Yeah, but the stepper
before
still
that I
has
was
backlash because it's actually the thread that it's engaging with. So if you went one way, you'd be fine, but then as soon as you go the other way, you might lose 4 or 5 microns before you actually start pushing the thread the other way. It's the backlash in the thread. If the backlash was 0, then the thread would bind and it wouldn't move. So you need to use ball screws for that, which basically do exactly the same thing, but instead they fill that gap with tiny ball bearings so that when you flip round, you never actually disconnect from the thread because it rolls, it doesn't slide.
huh. I was originally looking at like a worm gear setup, a worm drive setup,
Oh, yeah.
but
Same difference.
I
They all have issues with that kind of shit.
I'm not I can't, I'm really not great at mechanical design.
Yeah, I was doing machinist as a trade, so I've got a fairly good idea about this kind of stuff.
Oh yeah, you know that's pretty good. I ended up I went to open source last year and I ended up asking who did I ask? There's like a machinist on YouTube. I forgot his name. I'm really bad with names. I'm sorry. But he was thinking his first idea was like a goniometer, but that wouldn't quite work. What I was doing. Um, yeah, I needed about like I mean I only needed need about like 30 degrees. And the precision I only needed enough that I could do like zero point 0.1 nanometers. I mean, not even necessarily that. Maybe like
Point 1,
0.5
point 1
nanometers.
nanometer is pretty fucking tiny.
Well, no, I meant like in wavelength.
I don't know how that works in terms of because isn't the nanometer the
Yeah.
actual step of the wavelength? So like, I'm trying to think of like the resolution that you would move the thing to be able to detect that level of resolution.
It was like I forget. It wasn't that small. It's 30 degrees difference, and it's between it's like 300 to 700 nanometers. So whatever that division, I can do the math real quick.
Yeah, because I think it all depends on your fraction grading and that what those differences make.
Yeah, well, I had already calculated that I need about 30 degrees.
Yeah, that's what I'm saying. So the 30 degrees would imply you're turning some kind of thread, which means that the pitch of the thread, 30 degrees being 1/6 of a turn, and that would be 1/6 of a pitch. And so if you were using like a 1 mil pitch, then it's 1/6 of a millimeter. But if you were using a 10 mil pitch, then now it's 3 millimeters.
Oh, huh.
Actually, no, it'd be 1.6 millimeters because I was trying to work out a third in my head, a sixth in my head, which I think is 16% or something. That might be an eighth. I don't know. Fucking numbers are hard.
Yeah, I need to write this all down. I'm not great at mental math.
Mm.
Yeah, I need to do a lot more work on it though. But yeah, I one of the things I actually did add in my Bevy project was 'cause my issue is I wanted to adjust the green. Like I designed it so that it was spherical RGB. And then I also was adding in gamma. I wanted to add in the ability to create your own transfer functions.
Oh yeah, some like transform.
Well, no.
I'm trying to
So
what you mean
it's
by transfer.
do you know what like ETFs?
I'm terrible with acronyms because there's too many acronyms that all share the same thing. I don't have the context for what the fucking acronym is referring to.
Emission transfer functions is
Okay.
kind of the fancier form of gamma because
I honestly don't know what gamma is. I just know that in video games, if you turn the gamma up, everything turns grey. That's it. That's like my experience with gamma is cheating.
You know, like a normal number between 0 and 1, right?
Yeah.
And then you map that onto another value on like it's a function that defines how you're mapping one range to another.
Oh, okay. Yep.
So it's from 0 brightness to full brightness. Adjusting the gamma essentially just changes.
You smush the values together so that like 0 to 1 is a smaller range of physical colors, so they map closer to just being shades of white. Yeah, like.
Yeah, like the logarithmic brightness issue. You can adjust. You use gamma to adjust backwards.
And I'm assuming like it's the same thing for like converting between lux and lumens, where it's like one's adjusting for the actual physical amount of light and the other's adjusting for how sensitive the human eye is to that particular wavelength of light, that kind of thing.
Man, I could talk to you about lumens. It's the only SI unit that's like.
Wait, is it an SI unit?
It is an SI unit.
Okay, fair enough.
But it's based on a statistical person.
Yeah, so I thought it wasn't an SI unit because it's that dumb shit thing of like the SI unit is a candelabra, candelabra.
Yeah.
And something else.
Candela.
Yeah, candela. That's the one. Candela, which is one candle at 1 meter.
Well, it's weird.
Fuck's light game.
You have nits and lumens. One is both are like a candela over a square meter, but one's a spherical square meter and one's a flat square meter.
It's got a fancy name. It's a fancy name when it's not a square meter. It's an arc of a circle that has 1 square meter of
So that's the only difference between a lumen. Like that's a lumen, and a nit is a flat panel. Flat.
It's so fucked. One of them is first off, they call it a candle, but I assume it's actually like a light source of so many watts and not a fucking candle, actual burning candle.
It's a standard candle.
Yeah,
standard candle. Standard candles can also be different.
No, it's not a standard candle, then, is it?
Curves.
That's
well, it depends on because I think it can depend on your color temperature or whatever.
It uses a standardized black body emission, so it's like it's 10 watts at the emission spectrum of the of like if you lit a candle, what color temperature would a candle be? We use that well mathematically defined principle of this is the temperature of that like paraffin wax burns at basically, and then we work out the black body emission at that, and then we work out how many photons would be emitted at so many watts of energy, and then we work out that how many of those photons would have dissipated at 1 meter. So it is actually an exact value. It's just we talk about it like it's stupid. But that's what I'm saying. I didn't think whichever one is the human eye one. I didn't think that was an SI unit. I didn't think that one had like
lumens, nits, like candela. Those are all based off of a statistical observer and how much it is bright to their eye.
Right.
Because you don't get lumens or candela anywhere outside of human vision. it would just be watts of
No, yeah, but
power.
you know, because it's not measuring human vision; it's measuring photons. So it's not watts; it's photons, because that's why you need to know the color temperature, because that changes what photons you get. So what you're actually looking at is the number of photons that reach it. And then there's like when you convert to like between lumens and lux is the two that you convert back and forth with some kind of fucking statistical model that says that like the human eye is more sensitive to one color than the other. So you actually need to know the wavelength for conversion, and then there's just a number that you multiply by, which is your standard eye that you're talking about, whereas like it's just a statistically average person. So one is like saying how many like photons will actually be hitting you, and the other one is saying what color will it actually look like, because one needs to correct for the fact that we are more sensitive to certain photons than others. It's fucking stupid. And I'm pretty sure it's lumens and lux are the two that convert between. So like lux is actually the scientific number of photons, and then lumens is the fucking how bright you would think it felt when you looked at it, which is the idea of if you shone a infinite lux fucking flashlight in your eye, if it was infrared, you would go, that's not very bright, and then your fucking head would melt. But like
Luminous? Oh no, lux is just equal to 1 lumen per square meter.
Is it? Oh, which I think is the one that converts between the human eye and like
is a measure of irradiance as perceived spectrally unequally responding to the human eye. It is analogous to the radiometric unit watt per square meter, but the power at each wavelength weighted according to the luminosity function. A model of human visual brightness perception standardized by the CIE and ISO.
Yeah.
Yeah, but what's annoying is there's 2 luminosity functions. One for color. Actually, there might even be more. One for color and one for just like brightness. Like,
so fucking stupid.
but they're both brightness like values, just depending on whether you're considering the through mesiopic or scotopic underlying. Yeah, there's some crazy stuff there. But that's also part of
someone said in chat that horses can output 3.5 horsepower.
Yeah,
it's exactly.
It was literally like 2 horses on an inclined plane or something.
No, so the horsepower is like the amount of energy you can extract from a horse continuously. So the idea is that yes, if you grabbed a random horse, it can almost certainly put out 3.5 horsepower for an hour. But this was like, how much can you make a horse do all day, like 8 hours a day, every day for the rest of its life is a horsepower. And it's like, but most horses can put out 3.5 horsepower for a week or for a month, but they can't do it forever before they like collapse from exhaustion. It's like it's technically measuring something slightly different than the maximum energy you can get out of a horse, and it's the like continuous
way he
energy.
Actually measured it though was he literally put 2 horses on a treadmill that was at like I don't remember at an inclined plane, and had them walk for an hour.
Yeah, but what about this for a fucking stupid measurement of units? Is I don't know if other countries use the hectare and the fucking acre and that. It's like one of them is measured by like how much land a single oxen could plow in a day. I think it's a hectare. That's what the measurement for a hectare is how much one ox could plow in a day. It's like, what a fucking stupid measurement of fucking area.
Yeah. Well, did you know there used to be 2 different feet?
Oh yeah. Well, there used to be lots of different feet. There's still 3 different feet. That's the fun thing. There's still 3 feet in the fucking world.
Well, so the surveyor's foot back in like 2022, I believe, finally got removed.
But there's still 3 feet because what there is there's the imperial foot, there's the industrial foot, and then there's the metric foot. The way it works is America is metric in as much as they use the metric metric imperial.
It's part of the customary units.
That's the thing. The customary units is the metricized imperial units. But then there's also the imperial units, which still exist and are used by England. And then there is the industrial units. So I learned about this because I'm, again, doing a trade thing, and I went, that doesn't sound quite right. Is the British inch is 25.39 something like 999 something millimeters. The American customary inch is 25.400000 something inches, and the industrial inch is 25.4 exactly, because they went, fuck that, we're not going to have like ever so slightly, because like it doesn't matter until you get to like meters before you can even detect that they're fucking different. But the guy that did the first blocks, like what they call gauge blocks, which are like extremely precise blocks for measuring things, the guy that made those went 25.4. Because fuck trying to work out whether you're going to do British, like, because he didn't know if he's going to sell them to Britain or America at the time, so he just made them in the middle. He just went, gonna round it, call it good. I thought this was really funny, because everyone goes, oh no, there's only 1 inch. It's like, no, they're 3 inches, depending on where you're using the inch and who you're talking to, but they're so fucking close together that they don't matter. But then that means it's 3 feet, because a foot is defined as 12 inches. And they're going to vary by like a micron each.
Yeah, I could go all day about units.
It's so fucking stupid.
It'd be fun if we used what's your thoughts on dozenal?
Dozenal, that's 12 base, isn't it?
Yeah.
I'm more prone to using the one that dozenal's supposed to be like, oh, it dozenal's good, but it's actually not dozenal. It's something like sexadecimal.
Well, there's hexadecimal.
No, hexadecimal is a space 16. It's
and there's sexagesimal.
It might be hexadecimal. I'm trying to work out the Greek. It's 60. Base 60 is the answer, because that's time.
Yeah, I think
the
that's
time
sexagesimal.
It'd have to be hex, because hex means 6, or it'll be sex, because sex means 6. Depending on if you're Greek or Latin. And I don't remember how it's supposed to work, because it's like, I don't remember if it's the first or the second digit is supposed to be Greek or Latin. Sexagesimal.
Yeah. That's what the Sumerians used, which is why we have 360 degrees.
Yeah, because it's a multiple of... and 60
it's a highly composite number, which is what, 12, 60, and I think 360?
24 is supposed to be the best of the highly composite numbers, because then you get all of 12's factors. And then I think it's like, it's 6, 12, 24, 60, and then it's something like 3,843 or something. It's not going to be prime, but anyway, but it gets really big really quick, because I think the special thing about 12 as a number is it is the largest number in which all of its every number smaller than its square, smaller than its square root is its factor. Like it's 1, 2, 3, 4, and its square root's like 4.3. So it's like it's the last number that can happen to, because the squares grow faster than you can find a number that factors every number, like from 1 to that number. So it's like, and 24 can be counted on hands. 12 can also be counted on hands, and significantly easier.
You can count. When I heard about that, I was like, why don't we just use the pads and do 2 16-bit numbers?
The thing with 12 is it can be counted on one hand. So 12 can be done on one hand, 24 can be done on the other. So 24 can be done on 2 hands. And then you can also, decimal is another one that's really good, because you can use one hand to count to 6 and then the other hand to keep count of 6s, and that gives you, you can count to 36 with 2 hands.
What I was saying is you can count to 16 on one hand by adding in the base pads of your digits. So then you can count 16 on one hand, and then you can count to 256 with both hands.
That's actually a good point. By using your palm, you can count to 15, and then 16 goes to the next hand.
Well, no, like it's just a 4x4 matrix, just using the pads underneath each digit.
I don't mean by...
Yeah. Like right underneath each finger, you have the pad there. I just stick my thumb.
My hand is just my hand's kind of like quite flat. So, but no, so what I've seen is you count the knuckle. So it's 1, 2, 3, and you can like bend the different knuckles. It's a little bit hard because certain fingers don't like to bend just one knuckle, but it's the idea of being, you can do 1, 2, 3 on each finger, and then you can do your thumb as 2, and then you can, well, I think actually what you're supposed to do is point to it with each thumb, with your thumb, so you can count to 12.
Yeah, you use your thumb to point it. Yeah, I've actually been using the 16 one ever since I realized that. Like, you can count up pretty high.
Yeah, I guess because you can count to 12 by pointing with your thumb, and then you can bend your thumb, and then you can straighten your thumb, and then you can point to your palm. That gets you to 15, and then 16 goes to the next hand. That's your rollover. So you could get base 16.
I still like my using the pads.
Oh yeah, that's the same difference, I guess. I just think like it's easier
well,
to.
you're basically counting. Well, I guess you're counting the parts between the knuckles or segments rather than.
Oh yeah, that's a pretty good idea too. You could do that. You could
Yeah.
you could count each knuckle, and then you could count the gaps, and then there's your 15, and you could also just do your thumb as well. And then you like 18.
Well, yeah, I guess you could go really high with that.
You can just keep going. You can always just find something else. It's about how hard it is to explain to someone else.
16 because you've got four fours.
Now you can count hexadecimal, and then there you go. Now you're a
that's what I was
programmer.
Yeah, exactly.
They're nibbles at that point, or whatever. It's fucking. Oh no, it's a nibble's a half byte. Yeah. So it's a hexadecimal character is a nibble, which is just adorable that the programmers went, yeah, a byte. Well, what's a half a byte? Oh, it's a nibble.
Yeah. I find it funny that you got binary coded decimal, which is just hexadecimal, but they just cut off.
Yeah, they just ignore it.
Yeah.
So, I wonder.
Perfect.
So if a full byte, if 8's a byte, and then 4 is a nibble, would 2 be a nip, and then 1 being a bit? Just following the like naming scheme of it being smaller and smaller amounts of food that you put in your mouth.
You know, I honestly kind of want to look that up because I bet someone's already come up with it.
It's so fucking dumb.
No, it's a shave and a haircut, 2 bits.
Shave and a haircut, 2 bits. It's like, hey, it's a bite, it's a nibble, it's a shave and a haircut. Just make it way longer to say 2 bits, doesn't make people not say 2 bits. It's such a good fucking approach. So dumb.
All right. Well, it's been great talking to you. But I gotta head to bed. But yeah.
Okay. It's good talking to you. Yeah. If you have any questions, feel free to chuck them in the Discord.
Yeah, definitely will. Have a good night.
Hopefully, I'll actually get back to programming now that I don't have someone distracting me.
Someone shamed me for that joke. I will not be ashamed.
All right. All right, back to it. So what I've very slowly been doing while being quite distracted by that conversation is I've made a map descriptor, and the map descriptor is stored in a read-write lock inside of an atomic reference count so that I can give each chunk access to the map descriptor. Inside the map descriptor is a noise generator. It's a 3-dimensional noise so that we can do caves, I guess. And we're going to say impl. And then so we're going to say so. All right, I'm trying to work this out. So what I need to do is go something along the lines of if we need to say something like if pos. Also, apparently I need to like use super. All right. So if pos is dot y is less than ground level, okay, we're gonna say yeah. So if okay, so it's less than ground level, we're gonna say if v is less than 0. I don't actually know what it's going to be giving me. We're going to say 0, else 1. I don't actually know what this is going to do in terms of like, so 0 being air. So what we're saying is we should probably make a block struct, like a block enum, and actually be able to name this block. We're saying if we're below ground level, use this noise value to know if we are putting air or not air. So that should be like caves. Like basically we're going to have blobby caves because we're going to have like less than or greater than caves. And then else 0, which is implying that everything above ground level is going to be air. Sure, we can work with that. So we're going to go to chunk and we're going to say, hey, when we generate a chunk, we also want you to pass in a map descriptor. Map descriptor like this. You can take that map descriptor, that should be fine. Can't find map descriptor. Yeah, cool. Import the I'm using 3D noise. So I don't quite know how it works. Plus position, that seems correct. Except it's position times chunk size. So it'd be position times chunk size plus XYZ to get the block ID, block descriptor, get block is private. So yeah, I'm not entirely sure how simplex noise does its fancy thing, but as you see, I'm not declaring that simplex noise is 3-dimensional, but like it's a noise function that outputs 2-dimensional or 3-dimensional noise. Actually, let's go with the other cheeky one and be like, let's go with, I want to say it's super simplex. Wait, no. It's simplex. Open simplex. This one has 4 dimensions. But as I say, I don't know how it does the magic of getting the 4 dimensions, because as you see, I don't need to declare it, so it means it doesn't actually store extra data to have the extra dimensions. You can just request higher dimensional noise. I also want to use this as my way of doing my my different levels of sampling, is the idea being like the number of octaves in the FBM, the number of octaves in the FBM are what will control like the different noise levels, so that we can add an extra octave when we're rendering smaller voxels than when we're rendering bigger voxels, in terms of like the game being like you can swap up and down levels. So what we need to do is we need to go something like, let the descriptor equal self dot world dot clone, like that. So that should give us the reference count thing, and then we can go, because we're moving, we can go here and we can say give you a reference to descriptor, which should then take ownership of the descriptor. No, okay, so we need to do that like here. Let the descriptor equal, oh wait, no, yes, descriptor dot read, isn't it? Dot unwrap maybe. And then I think we just pass in the descriptor like that. No, must be like this. Okay, so that should then call our generate function, and that should do our generate function, and then I think everything should be right now. Actually, we just better run this. And so this should be that everything above layer 16 should just be air, because we don't check that in MapGen. So basically, if it's not below the ground, oh, it's all red. It's all very red. It's all very hard to see as well, because we have zero whatever it's called, like the mip-mappy thing, where we also need to definitely work out how to fix the fact that the borders have this issue. I think it's the same issue that we were having. Because it's obviously sampling quite a distance away. So there's just something wrong with how they're sampling that's giving them a color that they shouldn't have. They must be sampling like position 000 or something. Because I don't think every chunk has it. Alright. So we definitely need to do some level of like shading. So there's a very cheaty way you can do this, which is just to simply say we return C. And we return C times by vec. Wait, plus vec 3. It's a vec 4 with a vec 3, comma 1, which is then going to be mesh dot world normal dot b. BGAR, and I think it's this times by 0.001. So, did it recompile? Why is this? Oh, wait, it's kind of working. That got very pink. That got very orange. Right. First off, one needs to be a way smaller color, but also we apparently are not passing in negative numbers. If I fucked something up, maybe that's what's causing some of our issues. The top should definitely, because we're giving out 100% color gradients, right. I think we also need to make sure that every color is slightly different as well. Right, okay, so we're going to say, I forget what this is called, it's like, we're going to say let L equal, Oh. We're just gonna say L. It could possibly be that we are in fact adding a small amount of each. Oh, that's way too bright. So probably don't want the dot product then. Just do it the easy way. L, okay. So L is an F32, and then we're just gonna multiply color by. I guess technically it would be this, and then we'd say 3 L like so, because we don't want to drain the color. I don't know what having a problem with this. And say if mesh dot world normal dot x is greater than you can do the top first. If y is greater than 0, we'll go 0.5 because again that should make sure that we always catch everything. And then else if y mesh dot y is less than greater than 0.0. So then we can say L equals 1. So the idea is if it's the top, it's 1, and if it's the bottom, we're gonna make it 0.5, and then we're gonna say else if mesh dot world x is greater than 0.5. I guess the sun's going to be in the x direction. We could also multiply these together. There's no reason we can't, like, actually, yeah, sure, why not do that? So Z and then else Z. So you need to be like 9.5, maybe 9, and then no, you'd be 9. So 9.5, 9, and then you would be 8.5, 8.5, and then the opposite corner 8. 0. The idea is that we're trying to give everything just a can we just equal 0 then? If equal 1, I don't want to break. No, cannot. Ah, oh, that's fine. var I could. The issue with giving them colors in the generation is that well, we're not using Bevy's built-in rendery thing, which means that it's actually technically my responsibility to pull the color out. So if I give them a color, oh no, actually, yeah, you're right, because if I just give them a color, then the color will come through. So I could actually just multiply by the vertex. You're right. I'm just trying to go for the, okay. Babe, I just made it really, is it too intense? We adding? Oh, no, we're supposed to be multiplying by. Just multiply you by L, please. The idea is that you should be able to see. I think I've got that backwards as well. So apparently, we've actually got the vectors all pointing in the wrong directions, which is kind of funny, because if you're less than, you become 1. If you're greater than, you become 0.5. Does that make the brighter one on top? Alright, I think you might be right. 1, we appear to need like way more color contrast. Yeah. Alright, we'll do that. We'll just color the, how do we color the vertexes? Wait, no, I don't think we can color the vertexes, because if we give the vertexes colors, then we the vertex colors would be across the entire chunk. We need it to be a per block kind of thing. I also don't know why it's yelling at me about this. Anyway, so first off, we need to go vec for vec 3. Something like that. Because again, we don't want to introduce shading issues, like because we're introducing alpha channel. And then apparently we just need to like maybe scale down this to being like, maybe the AI was right that 75 is a good value. Or it's just not working properly because the 75 doesn't actually seem to be making it darker. So obviously the Y is working because the Y is Y, and we make Y 0 on top. Hey, apparently, oh, I've probably got that backwards. If Y is greater than 5, and then if Y is less than this, so if it's greater than, it needs to be, so you need to be 0. I think I had the logic backwards. So yeah, this is the top. So we're gonna like this. This is the top is gonna be 1. And then the underneath should be black. Yeah, okay, so this is bottom. Well, I passed the color in anyway, but so what I'm doing is, yeah, you're right, passing the color. What the issue is that as I told it to convert the color with a RGB thingy bob. So the reason they're red is because I'm setting everything to being the same block. Like I could go back to being random colors. Where did it go? I'm not trying to fix that they're all red. That would just be to go when I go here. Just say we're gonna give you like a. I don't think I can give you an RG because it won't be. Can I give you seed? Actually, we'll just take the noise at seed. I think we can just steal that. So we're gonna go like, ooh, set G equal self dot noise. No, we have to seed the noise from the position of the block. So probably like that. We're gonna say so we're gonna like rand RNG. We need to do the same weird seed thing. So p dot, is it magnitude maybe? RNG. Yeah, what I'm going for is there's a, I don't know what the concept's called, but it's the idea of like, we can't tell if we're looking at a corner if all 3 corners are the same. I believe in theory we could have fixed that if we'd given them like vectors that pointed in different directions and then made sure that they actually shared an edge. Then the Bevy shader, like, or the shader, would cause the vectors to like snap. Like, we're not doing lighting, I guess, is the problem. We could use the normal and the direction of the light to calculate what the lighting should be, which is probably the actual smarter thing to do. But I like the look of when you look at the normal and you basically say that the top of a block should be brighter, the left of a block should be darker. There's a thing, I think it's called ambient occlusion, which is the idea that we could sample nearby blocks and work out if we should be darker or lighter based on the nearby blocks and where we are on a block. So we're just going to say standard RNG, from seed from U32, and we're going to say p dot pos dot mag. Sure. I feel like this is going to give us the same thing in a bunch of different places. It's going to make it ring. I want it to be the same every time, so maybe we just pass in v dot pow 256. Wow, maybe it's like U32. Well, you want an I, don't you? I32 max. This is probably going to crash. No, actually, because a float can definitely represent more than that as U32, U64. So we generate our RNG and we seed our RNG like this. That's a 65 apparently. Okay, you're not found in scope, so to bring you in. So we're gonna go ground. We're gonna hey random rand, and then we say if it's below ground, you RNG dot gen range to equal UA max. Something like that. I think. So what this is going to do, I think I have to now pull random in. No, it's not gen random, it's random. Random range. And you're not mutable. Okay, so what we're doing now is we're basically using the noise function to work it if we're underground, and then picking a random block when we're underground, and saying you can't generate 0 because 0 would be air, so you can't just place air. But yeah, this is just about making sure that the tops of blocks look correct, I guess. So we're generating chunks, and we go, hey, look, they're all blue now. Okay, so I'm going to say that it's probably not working then if they're all blue, because that implies that, unless it's something I'm doing, them all being blue implies that they're all still the same fucking block. And also they're repeating, which means we're actually feeding the wrong fucking seed in, so maybe don't power by, like, the biggest number in the fucking universe. Okay, let's power by, like, 256. Oh, yeah, it's supposed to be 256. I'm trying to get it to, like, take V to the power of 256, just so that it gives us a number that's not near 0. I think the issue was that it seems to be rolling the same number over and over and over. Oh yeah, it's probably not sampling far enough apart on the gradient to actually get us nice different numbers. Right. The position is coming in here. P. Wait a second, are we sampling the same spot inside the chunk? No, we're dividing by the chunk size. So we're giving him position, and we're dividing by the chunk size. Times by 100. We need to make the chunk smaller so that we travel further, I think. I don't know, I'm probably fucking up the math somewhere. It feels like what it's doing is it's sampling something wrong. Well, now it's just very noisy, because we've effectively made our whole thing bigger. Okay. So don't divide by that, maybe times U by 0.01? I don't think that really helped, but maybe it didn't save. Am I in that fucking situation where it's not saving anymore? Somehow I feel like I'm passing the wrong number in. There we go. We've made everything a little bit more blocky. It's definitely not working at the edges. Some shit's just having some edge cases, so maybe we should just... Okay. I'm going to say you take in the block, and I'm going to say, fuck it, stop trying to convert it back to chunks. So you just do this, and then you type by 0.01. Well, because I was trying to get my blocks back inside the chunk, but you're probably right. I think I'm adding the chunk offset. I'm adding the chunk and then removing the chunk, because the chunks work in local space, and I was trying to make it so I could pass in an absolute block position, but it's still not working in that you can very clearly see the chunk boundaries. But I mean, it's better. They're still all blue, which is quite interesting. I needed to, like, maybe print out what the fuck it's doing. Anyway, so I also feel like maybe I'm just giving the wrong numbers. So if we said if pos equals I vec 20, don't return 0. I want you to print line. Right, so the idea here is that this should only print exactly once. If it gets this more than once, then we're passing in the same value multiple times. That we are. Alright. So we actually are only sampling each block only once, which is kind of fun. We should probably also maybe go down to, like, one chunk and then do that. But anyway, let's finish the lighting. Basically what I'm trying to do is, see, as you can see, you can actually see the corner here because the colors are different. But I don't think I finished it because I don't think I did the other side, which means that you won't be able to see. Oh no, okay. We maybe just need to tweak it just a tiny bit up, and then we'll call that fine. And so, let's call this 1. And we spawn facing this way. No, it's not 1, it's 0. Thank you. It'll be 0 so I can tell which one it is. Alright, so this, I'm pretty sure that's positive X. So that, positive X, this, positive X, positive X. Brain. So that is right, which makes this left, which makes front, back, maybe, I don't know. Let's come over here and go, which side do we just turn black? That way. Nope, apparently not. Alright, so let's make you, so you're the right. So we want the sun to be to the left and up, which means that you are going to be 0.985. That means you're 0.95. Right, you're supposed to be 0. Front. Which one's the front? So that's that one. When we spawn in, we want that one to be the brighter one. So you are 9, 0, and you're actually you're 8 still, yeah. Cool. So that should, ooh, did I put 90? Don't saturate the fucking color on that line. Right. So then we come down over here and we just have a quick look and go, okay. So as you can see, lovely. Also, we did some profiling after you left yesterday. I don't know if you saw if you watched the last 3 hours of the stream, but the profiling revealed that apparently limitation, I'm going to say 7, of our like this rendering approach, like what's actually capping our frame rate, is the fixed pipeline, which is basically saying the GPU is spending more time working out which pixels need to be rendered, which is our discarding, than it's spending deciding like what should actually render. So in theory, if we can do anything in our shader to make it look better, we should do it in our shader, because we're already capped on how quickly we can work out what to render. So our shader can be like really slow and not affect our frame rate at all, because we're actually doing all the computations elsewhere. I think that was the conclusion, is that like we need to make it not try and render so many pixels in the fixed part if we want it to be faster. So our shader is not the bottleneck. All right. Now, my confusion. Why is it always outputting the same fucking color? We're not breaking that, are we? No, it doesn't appear to be. Right. So this is doing our shading, and there's our texture sampling. And can we just like make you equal 0 so you shut the fuck up about like whatever this red line is? I actually don't think the red line's related. I think whatever this 50 something errors is actually more relevant. Anyway. Yeah, because that's what I was thinking. I was going, we could do ambient occlusion. I was going, oh, but do I need to sample textures? But it's like the person, because I don't actually know how this thing works, but the person that was here that told me to use this thing, I can't actually profile it while I'm streaming because it apparently kills OBS, because OBS is obviously touching the graphics card. And so it just crashes the rendering, and it took me like 20 minutes to realize the stream was down. But yeah, so they were saying that the bottleneck from what they could read of what I was showing is the fixed pipeline. So it's not that it can't transfer the memory. It's literally just like the shader can do more, but it can't render more pixels. It's the fixed pipeline is what is limiting our frame rate. So that's fun that we can do like ambient occlusion and stuff for basically free, because we're not actually using the shader for rendering. We're using the shader to work out like the color, which is kind of cool. It's a really interesting way of doing it, where we can basically spend a hell of a lot more frame budget doing other things, because in theory it won't affect our frame rate. All right, I got to work out why, because we're definitely only passing the same block in once. Maybe negative numbers are coming in more than once. Can we say, look, would be 1. I want to know what the hell is happening. Like, why is it doing this? I'm trying to work out if it's one repeating itself, because it does look kind of repeated, but that could just be that our noise is kind of repeated. So it's definitely only hitting each chunk once, or like each block position once. So maybe it's in here that I'm doing something wrong. So when I say generate, well, that probably isn't helping. That I'm doing some random noise. No, it shouldn't matter. It could be, there's like a rule with Perlin noise, or like with noise functions, that you're usually not supposed to sample like right on things. So maybe we can times by like f32 constants pi, like this. So the idea being that we're just trying to shift everything ever so slightly off of like an axis. Okay, pi baby. So let's go to pi and let's just copy the fractional part of pi and go. So we multiplied everything by pi. Maybe we just add pi, because the issue is multiplying by pi makes everything 3 times bigger. So if we just add pi, that might be smarter. So it's going to offset everything by 3 pixels, which is like completely not noticeable. But then it's also going to mean that everything isn't falling exactly on floating point boundaries. It's a good centered distance away. Okay. So again, somehow doing this has resulted in us having a very, very big, like noisy input. Now, the noisy input could possibly be that we are effectively... Again, also, why are they all still blue? That's another thing that's confusing me about this noise generation. So... Alright, so can we go here and make a print line v? So we use position for that. We use pos here. Pos, okay. Well, that's the thing, is too many octaves should just mean that the number fluctuates closer to 0. What's happening is we're not actually generating very far into the range of 0 to 1. Like, maybe I'm using the wrong noise and this noise is from 0 to 1, and that's why it's doing such chaotic noises. If it never goes negative, then we don't end up with a big chunk of shit. But it definitely looks like it's going negative. Also, apparently printing out stuff way too chaotic. So our range of values seems to be from like 0.2 to negative 0.2, maybe. Actually, I don't even know. Yes, maybe I don't know. The min and the max is too low, which I don't remember what does. I think maybe it's this that's doing that, like because we're multiplying by 3, maybe. All right, so we're going to times v by 5. And multiplying it by 5 should just give us more of a value between 0 to 1. So we're also going to say maybe v. We can debug only if pos is less than 1 times 16, and pos is greater than vec 3 0. So what this is doing is we're basically saying only print out the million or so blocks that are... Okay, apparently that's not going to work. Oh wait, no, you're an IVEC 3. Oh. Alright, so apparently we can't do that. So dot x is less than 16, and they're all less than 16, and pos dot x is greater than 0, and pos dot y is greater than 0, and pos dot z is greater than 0. Unless I've accidentally overwritten pos, that would be kind of funny. I gotta restart Visual Studio Code again. Skip. Right, it did save, cool. Let's restart code so that shuts up. Yeah, but the random value should make the colors random, not the blocks random. What I'm doing is I'm saying if you roll a random value below 0, the issue is that it's probably too close to 0, like it's flicking back and forth past 0. But the idea is that half of all blocks it is. That's what I'm saying. So the simplex is used here to work out whether if we're below 0 with the simplex, we render air. If we're above 0, we render a block. And if we're above the ground level, so if we're in the sky, we render 0 no matter what. So the simplex should choose what we render. Well, apparently we're getting yellow and green blocks now, so that's fun. I get an orange. Wait, am I passing in the wrong thing to the fucking random number generator? I'm just trying to seed the random number generator. So maybe we should stop seeding the random number generator and just say that the seed is so we know that it's negative, which means that we should probably flip this around and say, actually, if v is greater than 0, do this. Right. So now we know v is positive, so we can say that you are returning v times 255 dot clamp between 1 and 255 as you wait. Right. So now we're just going to be outputting what v was, which should mean that like the blocks should be colored. Okay. Oh, I'm an idiot. Yeah, you're right. Powering a negative number is just okay. Yeah, no. Yeah, you're right. I'm an idiot and forgot that but no, it's like I'm looking for repeated patterns, that's why I went quiet. The random number generator, yeah, you're right. I ended up seeding it from the same thing, which should make every chunk look the same. But as you can see, the actual blocks existing or not is from the noise function, like the simplex noise. And the simplex noise seems to just be generating like basically chaos, which is probably that we're passing in a number to our noise that is too small or too big, one or the other. We're sampling too bigger steps because we're passing in position. So we need to say we're plus pi, and then we need to multiply this whole thing by 0.1. 0.1. So we need to, now we're going to sample everything 100 times smaller. Basically, we were stepping by a whole block in the simplex. Ball pit is back. Yeah, so I think what was happening is that the reason it looks really noisy and chaotic is because we were sampling at 1 step increments, and 1 step increments in Perl and noise is effectively random. So we still have issues at seams, apparently. So that's fun. Stretch the range again, like, yeah. So, but you're right, the reason the random wasn't working is because I was... the fuck is going on? I was very much sampling the wrong... powering a number that's less than 1, which I forgot makes the number smaller, not bigger. I was trying to make it blow up to infinity, not shrink. Not shrink, definitely. Okay, so we have a few issues, which is, for one, why is this slice up here, which is this, I believe, is generating 1 chunk at a time. Like this is only 1 chunk thick, which means for some reason, at y equals 0, we are not only not generating air, we're generating color. Which, oh god, that vomited then, that was disgusting. Looking at that, that tells me that the bottom slice is wrapping to the top. This is what I was talking about in our shader, are sampling wrong. I guarantee that this is because we're actually sampling this block in this voxel position. We need to offset all the voxels down one, well, up one, up one. Every voxel needs to go up one in our shader. How do we do that? You are shader magic person. How do we make our shader go up one? I think we multiply this by -1/2. The answer is that was not right. It did something, but it's not correct. Okay. So not -1/2. Do we subtract, which is the same as multiplying by -1/2? Nope. So it's still broken. Okay. So it's specifically y. Y is broken. Plus LOD divided by 2, you reckon? So I'm almost certain this has always broken everything. But maybe that's why it's been breaking everything. Okay. You and your witchcraft. So why was it breaking the LOD before? And I feel like it might still be breaking the LOD now. But we have to fly out. So because we definitely need to fix whatever this fucking wireframe mesh is happening. It's got something to do with these pixels sampling, I assume, this side of the block. We need like a block that doesn't, yeah, okay. So we need to fix this rounding error that's happening, which is, it's literally only the pixels on the edge, which I assume have their UV set to something other than 0. So it's this piece here needs to be tweaked to make sure that every block is not an edge block. Like, because it's these blocks here are sampling the wrong UV somehow. Not the full LED that will always make the end wrap. The issue is I wasn't looking at chat, so I don't know when you said that, and also I don't know how far behind you are in terms of things. But like, our LOD is definitely broken as we get further and further away, because you can quite clearly see it. Like, as soon as the LOD kicks in, I need to maybe tweak the LOD so that we only load the different LODs more. Okay, the LOD seems to break when voxels are empty as well, which is kind of strange, if you ask me. So these look like they're only single-wide voxels. Hello.
Hi. Okay. I know why the LOD is broken, but I don't fully know how to fix it in math quite right now.
Well, it seems to just not be sampling the LOD correctly in the chunk. Like, it's rendering the small voxels even though they are big voxels. So it's just like not detecting the LOD correctly.
Yeah. So the problem is, if you go to the shader.
Yep. Into the shader. Yep.
The when we wrap the position to be the size of a chunk, we need to then divide.
Shouldn't we be putting the LED back inside that so that we also wrap it into the chunk? We just need to make sure we add the LED before we wrap the chunk like this.
Yeah, so that's the thing. Like if we were in integer space, right?
Well,
we would want to take
it helped. I don't know.
Yeah. Yeah. So basically, right. So the thing is that position, putting it back into chunk space correctly. Then we, like in integer space, we would want it knocked out the bottom bits, right? So we need to leave the LOD at the outside because that's what changes like where within the bigger cell
Right.
we go to get it. So what we need to do is divide by the chunk size. Like divide that. So leave the plus LED at the end.
Yeah, I'll put it back at the end. Just so like, because it'll make it somewhat easier in my head, especially for the math, is for whatever reason when we go to the LOD, the invisible chunks stop working entirely, and we seem to be stretching the half chunk data into the full chunk height. Like that's something we're doing wrong that's causing that.
Yeah, exactly. So yeah, so if you go back, so we want to take, after we finish all the modulo bullshit,
Yep.
you want to divide by the chunk size. So then we reduce that chunk size of 16 down to its proper LOD.
So we divide the sample position by the LOD then? Because if we go to double and triple and quadruple, right?
Yeah,
okay,
exactly. So divide by, LOD, not chunk size. Duh.
Yeah.
Then we knock out the fractional part. Then we re-multiply by
sample
the LOD.
position. So divide equals LOD. And we say sample position. It wants to plus equal half. No AI. Equals the floor of the sample. And then we want to multiply it by LOD again. Correct? To bring it like
So that way it'll like basically recontextualize that area within the chunk to that LOD size.
It's still drawing the whole thing though. It's still
and then we want to move that plus LOD times 0.5.
Oh, okay, the half. Okay,
end of all of this stuff.
So do all that. We multiply and then add half the LOD.
Yeah.
Oh, it looks correct. It's still filling the entire chunk, but it looks correct. Like they actually look like they're rendering the. It looks hideous, but it's still. Okay.
Yeah. So there's So the problem now is like the way the floor works is if we're exactly on the border of a thing, then it's gonna wrap weird.
Yeah,
that's kind of the problem we keep running into.
So I think we're still missing something because I don't understand why there should never be any voxels in the entire generated. Oh, that's just weird. There should be nowhere should we ever generate a voxel in the top half of a chunk with the current world generation. And the only reason we can see stuff on the top is because of weird floating point errors. But like as soon as you get to LOD2, you start rendering stuff up too high, and we're also still rendering everything at full resolution by the looks of it. Maybe I can't actually tell. No, it's rendering at half resolution, but it's filling the entire chunk, which doesn't make sense. It shouldn't be filling the whole chunk, which means it's stretching everything to fill the chunk, which is even more confusing because it's reading the right data. It's just still filling the whole chunk.
Yeah, that top half should definitely not be doing that.
So it seems like what we're doing is we're sampling like the bottom right corner. And when we adjust the LOD, because there's actually data, we're still sampling only the bottom half of the chunk, but we're now sampling it across the full height of the chunk. But we're not moving the LOD properly. Like we're not sampling the middle of 4 chunks. We're now sampling the middle of the chunk, which is not the right thing to do because it means that the top half of this chunk is sampling up to halfway rather than sampling the top half but at half the resolution. It's sampling the bottom half of the chunk data at full resolution.
Show me the code again.
So like we're not moving the LOD around. We're moving what part of the LOD we're sampling and then rescaling that back to the whole chunk being applied. So like that's the only thing I can think that can be happening is that basically we have the bottom half of the chunk and then we're saying, hey, render the whole chunk as if it was just the bottom half, which is why it's now reaching the top instead of being like we actually want to render every voxel as if it was the middle voxel. We're instead like compressing the whole thing into the bottom half. Well, I guess stretching the bottom half to fill the whole cube. Yeah, that's what we're doing. Somehow we're stretching the whole, the bottom half of the data to fill the entire cube instead of sampling the whole cube at twice the step distance, I guess. I don't know how to phrase it. This is when I open Blender and like model what we're actually doing.
sample position divided by LOD, floor that, so remove the fractional, perfect, and then we re-multiply to LOD, so that gives us more coarse chunks.
Yeah,
And then
but
we add
something
half
here is
the LOD
stretching it.
inside that chunk. Yeah, that should be correct.
I think maybe it's this sample divided by chunk LOD, right? Means that in two-step chunks we actually end up going back to sampling the full height again, because there is data at half LOD to render the full chunk. So it's something to do with that. So
yeah, yes, and sorry, another thing that you said is it's also doing the full resolution. So that's because of the LOD times 0.5, like it's being overly granular.
no, it does actually seem to be half resolution. It's like, if you know what I mean, like, so there are two of the smaller chunks in each of the bigger chunks. It's just that because it's done it, it's exactly double, like it's actually filled twice the height. The chunks look like they're rendering the same because they actually are rendering, it's just rendering twice the size. So it's not actually sampling the middle, it's rendering twice the size. The LOD is actually scaling the image up, and it's because like it worked when we were smaller, because when you scaled outside of the voxel, you disappeared. But now we're scaling into empty space, which means that it still has pixels that it can render on, whereas previously it was scaling into a place that it couldn't see. I thought we were sampling in the middle, but we don't appear to be. We just seem to be scaling the image that we're sampling. So we need to step by a bigger amount. So does that mean we need to maybe multiply by the LOD before we sample instead of adding half the LOD after? Because multiplying by the LOD seems to be scaling the image, but we actually need to step bigger, not just sample. Like if we scale the image to twice the size, we also need to step twice as far, because otherwise we end up not stepping outside of the range. So maybe if we go to
right now, right? So basically, sorry, I'm just gonna process through the math in my head.
Wait, I think I fixed it. I think I got it. I stopped multiplying our division in the sampling the texture. So we were sample point divided by chunk size, which actually kind of, so instead of dividing by the sample point divided by the chunk size, I just divide by the chunk size, and that seems to have fixed it. Because that's what I'm saying.
Oh, yes. Okay.
Yeah, because I was trying to work it in my head, going like, we're stretching. We're stretching, and then we're not increasing the sample step. But now we are stretching and increasing the sample step. And oh my God, it looks incredible. And this is what I mean by like, you can't really see the LOD anymore because it's no longer scrambled pixel noise becoming like less scrambled pixel noise, because as it gets further away, the blocks of color become smaller, and therefore you can't see them. All right.
So actually,
any ideas how to fix this wireframe stuff?
Yes.
It's some kind of floating point error. We need to make sure that et pixel sort of rounds itself in at least a little bit. The issue is that it appears that Bevy decides that, or like the shader, we actually have access to fragment shader. We wanted to add our own fragment shader to fix this if that's what's going on. But it seems like it's giving us a normal of 0 if we're on the edge of a block, like the line on the edge of a face is 0.
So, exactly. I have a weird way of fixing it that you should probably work, but it'll be a little bit wonky. So yes, go to where you generate the chunk mesh and make the normals ever slightly skewed outwards.
Ever so slightly skewed outwards? That's strange.
Because basically, right, the plus normal by half is so that when you get something on the edge, it gets pushed towards the center a little bit by being pushed back from the normal.
Question is, do I need to skew them so that they skew away from the block, or like can I just put anything but 0, or do I have to actually make sure that I'm trying to point away in a specific direction? Like in Z, do I put 0.1 on X and Y as well, or do I need to put negative X and positive Y or something? Like, do I have to actually try and work out which way I'm trying to point it? Or does it just, as long as it's not 0?
It needs to be the correct orientation, because the normal needs to point towards the center of the block, or well, technically away, but all the normals are reversed. But so pointing towards the center,
actually,
so that
the
corners get brought slightly in, so that they're never 0.
So what you're saying is we can't use the same 4 normals on all 4 corners. We need to have each normal needs to point to the center of the block.
Yeah, so basically, like
Ugh.
what you had showed in Blender with like the normals pointing
Yeah, I remember. Yeah.
like diagonals, we're basically doing that is kind of the best
So
way.
I'm gonna have to procedurally generate those because they'll be different for every slice because each slice is slightly. Or do we only have to do it for the first and second slice? I guess if we can just.
I think if you just extend this instead of replicating 001 like 4 times every time, you can just manually put 4 of them, and we just
Yeah,
play
work out
around
which
with
one.
X and
Yeah.
Y so that
Okay.
yeah.
So you're saying just have 4 copies of the same. Like technically just have 8 copies now because if we're not just replicating 4 times, we can just have the pluses and
Yeah.
the minuses. Okay.
Yes, they're not exact copies, but it's just enough so that the say
Okay.
when it's pointing up towards Z.
It's so
then,
annoying. I'm gonna have to keep relaunching
Yeah,
again.
it's
but
really annoying.
I just tweaked them just to 0.1 to see what would happen, and all it did was make the lines thicker.
Yeah, so that's because if it's pointing oblique, so then like one edge gets pushed into the next block.
Yeah,
instead of-
gotcha.
Yeah.
Question: would it actually be better just to modify the fragment, like just go copy whatever fragment shaders Bevy's using and just modify that so that we can correct the fragment? Because I'm assuming that's a fragment shader issue. I know fragment vertex shader issue, but it's when it's smoothing the normals, it's causing issues when it hits the 0 point. Or is it just worth just not fucking around with it?
Don't fuck around with it. Basically, just because of the way that you're generating the chunk mesh, you never actually know which block specifically pixel is on.
Well,
Which
you would,
internal cell.
but that's what I'm saying. The issue is it's like the internal
Until
cells.
afterwards.
The internal cells don't care. It's only the cells that are on the edge of a chunk. They're the only ones that seem to care. Oh, actually, yeah, you're right. The flickering would stop if I can. Gotcha. Okay, yeah. It's not as obvious when there's not a chunk missing, but it's actually doing it on every block. Okay. Yeah, I see.
Yeah, exactly. So it's just we're trying to tell the edges like, hey, you're ever slightly towards the inside of your chunk rather than actually being on the edge.
Yeah, well, it's not even the chunk; it's the block, isn't it? Because I'm trying to work out here in my head what we're actually doing that you wouldn't know at runtime. But yeah, I think I'm following along in that. Like, it's not that it's happening only at the edge of chunks. It's that we can only see it at the edge of chunks. So we're fixing it so that every block will be pushed slightly inward into its voxel.
Yeah, exactly. So it's just that right now, the way that it's happening is that it gets wrapped around to the other side, but only on the crossover of edges on the edge of a chunk.
Yeah, and it's just more like because that's the place we can see it than because that's not.
Yeah. Like the rest of them is like it's close enough that like if your block is 1 pixel.
Is this also what's causing it to cause that flicker? Like when like on the edge of blocks, like you can see that little flicker. That's the same thing, right? Like
Yes.
it's that we're sitting right at a 0 point. So that seam should be filled in by pushing everything slightly into a block. Okay, that's good.
Yep, exactly. So you're just gonna put basically like.
Oh god, it looks so much worse doing that.
At multiple places.
I've fucked up one of the numbers somewhere because everything is so much worse. Oops.
Let's see. 001 microphones. Yeah, that should be fine.
It should be exactly copy pasted, but it is not.
Oh god.
So fuck knows what happened there, but oh god, and it looks so much worse from above. Wait, one of these was supposed to be the other way. That's probably what's happened. I think the X is supposed to be opposite the Y, Z or something.
Oh right, yeah, there was one that was weird.
Well, we can just go like if I go to Git, because that's the fun thing about having a Git commit is I can look at this and go, which one of these is backwards? So the Z was plus minus, the Y was plus minus, oh the X, what the fuck? What is this? Yeah, the X is plus minus, and the Y was plus minus. So never mind. I thought that one of them was backwards, but apparently not. What the fuck? Why did it break when we do it individually? It should be identical. 4 ones, 4 negatives, 4 ones, 4. Oh no, never mind. I'm fucking idiot. I put them all in the Z. That's what's going on. That's what the difference is. Is that even X's are in Z.
That makes sense. Yes. Yep.
Multiple cursors can be really painful when they're not the same size.
Oh god.
0 dot, and then this is x, so these are x, and then these ones are, oh, and then the AI, well, AI, you need to stop. The AI picked up on what I was doing and then didn't do the last two, and then when it decided that it needed to do the last two, it just deleted one of them and fixed the other ones, and then it was 4-3, and I was like, why? Why, AI, why do you do this?
So the same issue as the first time.
Okay.
You trusted it to pick up on what you were doing, and then...
Well, no, I trusted it to pick up all the way, and then it decided that, fuck it, I'm gonna do it 90%, so when you glance, you go, yeah, that's right, and then it goes, ha, except I didn't. Like, it's the 90% of what fucking pisses me off with the AI is that I try to use the, like, autocomplete, like, comma thing, where it's like, you know, automatically fill in this table with, like, not IntelliSense, but the one where it's like, it knows what values go here because it's a match statement, and that's got a defined, and then the AI, so I'm like, oh yeah, use that tab, and then the AI, before I hit tab, like in that, I've gone to hit tab, has gone, actually, this is what it should look like, and then I tab the AI fucking response in. It's like, no, AI, it was right, why'd you fucking change it?
Oh my god.
And yeah, it annoys me because it's that idea of like, it takes me just long enough to decide that I'm about to hit tab that the AI kicks in and changes something. I'm like, you bastard. Yeah. Right, let's fuck with the whys first, because
like,
they're the easiest.
That's why AI is never going to fully replace programmers, because the thing is, the compiler cares about 100% correctness. If you have 1% issues,
well, that's the thing. I think the AI will cover that bit. It's the issue is that the AI cares about not upsetting the compiler. The programmer cares about it being right, and so the programmer will stop and fix it because the compiler is complaining. When the program is going, this is correct, and the compiler is saying, well, that won't compile, the AI will make it so it will compile, not so that it's correct, which is the issue. It's, yeah, AI, I think they will eventually replace the programmer, but they won't replace the creative side of the programmer. Like, the programmer will still have to do the programming.
From where I sit, like, with current tech, it hallucinates too often. Even, like, one in 1,000. But, like, if 1 in 1,000 lines of your like million line code base is a wrong function, good luck.
That's actually not the problem. It's that it's very much like Rust for AI, so much better than C, because in C, getting a pointer function wrong is terrible.
Yeah.
In Rust, it won't compile. So even if it hallucinates 1 in 1,000, in Rust, the compiler will catch 99.9% of those hallucinations. The issue is that one logic bug that skips through because it wasn't a compiler error, and the AI made it up. So, like, if it gets a function wrong, it won't compile. That's not a problem. It's when it gets the function almost right, and it's close enough, especially with something like Bevy, where there's hundreds of, like, versions of the same function, where it's like this or that, and like for example, like your it's a Newtonian, a Euclidean or Manhattan distance. It's like, imagine if the AI put Manhattan distance where it wasn't supposed to. It won't not compile. It just will be logically wrong. And it may take you years to track down that it's wrong, because it would be such a rare bug where technically the Manhattan distance was not actually a correct implementation, but the fucking Euclidean distance would have been right, because most of the time they're interchangeable in that, like, whichever's closer in Manhattan will probably also be closer in Euclidean. Like, not always, depending on how your player can move and that kind of thing. Like, but like the odds that you know what's causing this bug when it's that kind of difference is so low that you're going to spend ages fucking looking for it. Because it's not really an issue. It's a feels wrong, not an is wrong.
So one thing that I've seen AI do a lot that, like, makes me doubt that it's going to be able to take over as much as a lot of people seem to, like, want it to, is, like, when it gets something wrong, like, yeah, the compiler's going to get it, and, like, it's going to tell you, oh, hey, this is wrong, and it's going to try re-architecting the entire fucking file. And
see, they fixed that, though.
And then it's going to reinvent something else, and then it's going to get that wrong. So the compiler is like, oh, hey, wait, no, that doesn't work. Until you have something that compiles but isn't fully functional, because it's reiterated that same thing in a million different ways so many times that it's just
but so that's
completely incapable of reasoning at all about what it was trying to do.
That's what I was talking about in my first stream of this, where I'm like, I lost so many subscribers from putting vibe coding in my fucking title and thumbnail. Boy, was that... Like, I think it's more because, like, if I had done it and started streaming, it wouldn't have been a problem because people would have come in and seen what I was doing. But because I just did it like 24 hours before I streamed, a bunch of people just unsubscribed before I even started the stream. And I can see the analytics, because it's like most days I'll lose 1 or gain 4 subscribers. I lost like 6 subscribers that day, and then the stream itself itself gained more subscribers, which implies that there was at least 10 subscribers gone that day, and I got some of them, like some other subscribers back. But when I was talking about that stuff, is when you do it like with the actual like vibe coding software, like if I do it in VS Code, it doesn't do what you're talking about. It doesn't just make shit up and re-architect shit, because it sends a smarter model in that reads it, works it out, writes the correct prompt to ask the dumber model to refactor something, and actually does it. Like it'll actually read and check and like check the documentation and go, oh, does this function exist already? Do I need to actually implement myself? And we'll plan it, and it will go, oh, this function doesn't exist, but I'll need it to exist, so it'll request that gets made first. It won't just hallucinate a function into existing, but it requires you to actually, it's with I think the Theo talks about it and he calls it the harness. So it needs a good harness, which is just the piece of software that you write that makes it do what you want it to do properly. And yeah, I don't think it'll ever replace the programmer completely, more just because I don't think that AI will have that human experience to be able to know what feels good as like a UI, whereas when we as a human, I can like intuitively be like, that feels like shit, like please don't do that. And the AI, as soon as it runs out of training examples of actually code written by humans, it will stop being able to just make UI that feels good because it knew what it should feel like because a human made it at one point. So unless we
ironically
force AI to be fucking what? The opposite. You reckon that they'll be good at making a UI stuff, but terrible at...
I don't think it'll be good at making UI. I think it'll be good at iterating a million A/B tests at once, the same way the algorithms work today, and figure out what gets you to buy.
Oh yeah, that... So I'm saying like the juice of it, where it's like, I'm making a UI thing, and every time I get the AI to make a change to it, I keep telling it, no, don't do it this way, do it this way, because it's not intuitive. The AI never puts an intuitive new button. If I have already made intuitive buttons, it will keep that. Or if it's a very common like thing, like the right-click menu was just fucking phenomenal without me having to say anything. But like when I'm going, no, but like, can you stop making the fucking key bindings? It wants me to keyboard navigate, because originally it made it as a terminal app instead of like a keyboard mouse app, which meant that like the key bindings were really intuitive until it ran out of letters, and then it started just assigning shit to the F keys. And I'm like, stop, don't keybind shit. Like they decided that everything needed to be keybinds instead of being like, actually these keybinds make sense, or like let me rebind these keys when you're in this like different windows, and when you change windows, I'm like, make the keybinds change when I change windows maybe, like so that instead I can navigate and control the other windows while I wasn't in them because I had the key bindings for them.
Yeah, I do think like you said, it's not going to make good juicy UI.
Yeah, it won't make it doesn't have human experience.
But like for the things like say like I don't know, Facebook or whatever.
Oh yeah,
like,
yeah. Algorithms wise, yes,
give a fuck about changing everything all the time, and like, oh, we're just gonna change the entire UI and UX.
That I think that might be why.
I think that's where AI will shine, because then it's gonna be like, oh, okay, sure, let's redo a million fucking tests of this.
Yeah, the AI is actually really good at writing its fucking tests. But like, what I'm thinking more is the opposite. I view it more like this, is that at the moment, Facebook can change whether the fuck Facebook likes, because we have no alternative to Facebook, because you can't just spool up a competitor to Facebook, because they have hundreds of thousands of engineer hours building Facebook's infrastructure. But like AI will mean that you can spool that up, and you can be the person that goes, I'm going to add the bit that makes this feel good to use. I don't think the AI will ever have the human experience to be able to make things feel good to use, which actually will take it away from the big companies, because the big companies had the advantage of they could literally hire someone whose entire job was work out what makes this feel good to use. But yeah, you're right. Algorithmically speaking, the AI will be phenomenal at being like, how do we make someone buy something? Well, like, as long as it has a clear metric. But I don't think the AI will ever be able to feel human. And the thing at the moment is someone talked about like you develop antibodies to algorithms of at the moment, infinite scroll is such an addictive fucking thing to our minds that like it doesn't matter if they make a shit app. Infinite scroll makes us stay on it. But imagine if someone else could come in and say, hey, I made an infinite scroll app that's exactly the same as TikTok, except it feels good to use. And I don't think the AI will ever do that. The AI will be able to capture the most user time, but because of how humans are hardwired in our lives and like biologically, the most user retention will always be to make the user feel like shit when they're on the app, because for some reason that makes us stay on the app. And like, it's why we all see bad news, is because bad news keeps us on the app.
Yeah, I think the problem with like your theory is that people don't care enough about wanting to get off things. Like Facebook is trash right
I guess,
now.
yeah.
Facebook is still one of the biggest social medias because people are hardwired and they're just used to it and they don't care enough to get off it.
I think there's
like
a lot of tech
Twitter
inertia
and all
though.
these things, right? Like yeah, there's a lot of tech inertia, but there's also the side of like one of the things that like a lot of like AI forward people bring up is like, oh, but then people are going to be able to like just make their own version of the thing, and then like, or whatever. And it's like, okay, great, Mastodon exists. Why are people still on Twitter?
Yeah, but that is definitionally what the tech inertia is even though we have something better, why are we still using the bad thing? And it's like, because people just
so, like,
stay
I don't
there.
think exactly. So I don't think that like
Yeah.
something better existing or like AI
Well,
making and
Yeah, I don't know. Because my
you know, I think that's the
counter
problem
argument to
with
that would be eventually the harnesses will be good enough that you won't be on Twitter, you'll be on the microblogging AI thing that like you use something that builds you a personalized microblogging thing, and then Twitter will die as soon as it's actually so much easier and better to be on something else. The issue at the moment is that a lot of these places don't get better than Twitter and people are just stuck on Twitter, and it's that antibody thing I'm talking about. Eventually, people are already going off TikTok. I have told YouTube that I don't want to see shorts anymore, and they stopped showing me shorts because I started closing the app every time it showed me, like every time I accidentally ended watching shorts, I just stopped using the app for an hour, and then they just stopped showing me shorts. Like, but you're right. I had to consciously say, I don't want to do this anymore. I'm saying, like, I think AI enables us to be like, why don't we just make our own YouTube that doesn't ever show us shorts, instead of us having to trick the AI algorithm into not showing us shorts? We could just say, this YouTube never shows you shorts. And AI will eventually get good enough that it could actually do that just from scratch. Also, I keep tweaking this code generation and then not regenerating the code and then wondering why it's not changing.
So on that front, I think actually lobbying is too strong for that to work.
Well, that's what I mean. I think, like, it's not necessarily lobbying. I think it's because the AI companies know that that's the way it would go. They won't ever release a model that's that good. Like, I think this is like beyond the level of lobbying because the government's not going to be able to stop it once it happens. It's whether they
not like
ever
lobbying
actually.
in the sense of, not like lobbying in the sense of like the government, but like lobbying in the sense of
These corporations are not doing what's in the best interest of the people.
Exactly. Like YouTube is never going to let someone just randomly let an AI start making a new front end that say hides ads, because is user
I know,
friendly,
but like,
and that is what you would want.
ad
right?
block exists.
So
there's my point.
I mean, it does,
but
it's such a tiny % of the population that uses it
because
it's
and
a tiny bit of friction.
do you remember
and people don't care about.
do you remember when fucking YouTube Mandela affected themselves with that, where they Mandela, no, Streisand affected, where they banned ad blockers, which made everyone go, wait, ad blockers? And now they have fucking ad blocker problems. Like, they didn't have the problem until they went and fucking became a dick about it.
You want to laugh about that actually? I didn't actually I have ad block on pretty much everything, obviously. But I didn't even realize that they started blocking ad blockers, because everybody, you know how everybody says don't use Adblock Plus because it's shit now.
Honestly, I don't know, because I just have premium. But...
Okay, so that's what I use specifically because less people use it. So
so that's how it does it.
Google doesn't give a fuck about. So while every other ad blocker was getting blocked and getting borked and shit, I had 0 issues. So everybody's like, they're blocking the ad blockers, and I'm like, are they? I don't know.
Yeah. My favorite thing is I showed my dad ad blockers probably 15 years ago at this point, kind of thing. I'm just going to add. He goes, YouTube and its ads are getting fucking ridiculous. And I'm like, I've got an ad blocker. I don't see them. An ad blocker. I'm like, yeah, it just stops ads, it is. And he goes, what about this? And it's like, no, it just stops the ads. But the thing with that is, what I mean, with the AI stuff, is the ad blockers weren't, Google doesn't let the ad blockers happen. The ad blockers keep fucking finding a way around Google. My favorite one's there's a thing called a pie hole, which is basically an ad blocker, but instead of it being a piece of software that Google can detect, it's literally you just ban every single IP address to ad servers, so that anytime your computer
That's a big
requests
difference.
ads, it just never fucking returns and it just gets 404s. So unlike ad blocker, where you, like, it actually hides away the ads and you don't see that they existed, they just leave holes everywhere with the errors saying like, but you don't see the ads. And the only way that YouTube could stop that is to 100% guarantee their uptime of their servers and then not let a video play if it fails to get an ad. But if they decide that they're going to fail to play a video if it doesn't get an ad, people will be so pissy the second their ad servers go down for like a couple of minutes. Everyone can't watch YouTube anymore. So they can't do that, which means that will always be a solution, is just to tell YouTube, oops, the ad server's down, because they can't stop you from doing that, or they risk
They had started
everyone
trying to put it in the primary video feed.
Oh, yeah, they did talk
they
about doing
started
it.
trying that, but then, yeah, they had some issues with that.
I think they had some real bad pushback when they patented the technology, and everyone went, we know what you're planning, and they went, maybe we won't fucking stick it in because everyone's real angry right now.
Yep.
But that's a YouTube thing for you. Fuck me, they're annoying. Okay.
Gotta love patents. Like the reason we didn't have for 20 years like mini games on loading screens was because Konami had patented that.
Really, that's fucking stupid. My favorite one's the patent. I think it was Samsung owns the patent, and it's the patent to have interactive ads on TV. And everyone was going, "Why'd you patent that?" And they went, "Because if we didn't, someone might actually fucking use it. We know this is a bad idea and would kill TV sales, so we patented it so that nobody could actually do it on our TVs."
I love that. It's was it Ford that did the seatbelt, patented it, and then specifically did that as well, of just like, now we're patenting it. Now we are patenting it, and then releasing it into the wild.
But that's the opposite. That's the opposite of what they did. Is that they kept the patent so that they're going like, hey, if we released this, then there would be nothing stopping people from broadcasting over the air shit that would fuck with our TVs, and we would have to put some kind of thing in place. So we're basically saying, we don't want people fucking using this technology, so we're keeping the patent private so that people legally cannot fuck with our shit in a consumer-friendly way of, it's more like it's better for us if we don't have to implement it for other people. It's sort of like how Apple for a very long time kept claiming that it would be too hard to implement integration with Google and the green blue chat bubbles, and then Google said, hey, we made our own open standard that's perfectly compatible with yours, all you need to do is enable it. And they went, oh sure, we'll enable it, but their buttons are staying, their check boxes are staying green. It's like, what do you mean? Like, well, because it was never about, oh, they're not on our system. It was about being, they're not on an iPhone, shame them. So it's like, it's kind of funny that like they kept claiming that it was too hard. And then Google said, it's really easy now. And they went, fine, but they're staying green. And then I think they're being sued currently over it. That the fact that it's like, you claimed that it was about this reason, but you're still not letting us modify the color because it's like really anti-competitive, that you're basically saying that if you're not on an iPhone, you have to have a green message, where you claimed for years that it was actually a technical limitation, not a... Because I think the way that it originally started was if you used credit to send a message, it would be green, and if it was sent by internet, it would be blue. And then as they built up the Apple network thing, or like the iMessage and stuff, it's like, well, everyone else on an iPhone can talk over the internet, but if you're on an Android, we can't talk to them over the internet, so we're going to have to send a text. And so the idea was that you would have, in the conversation with one person, you might have blue and green messages, but then eventually it was like all iPhones will always be blue and all Android will always be green. And then it became they were saying it was a technical limitation, but it was quite clearly, when Google fixed it, a anti-competitive, like, we don't want people using not our product. I'm still completely unsure how to make this thing work. The issue is I have to keep regenerating all the chunks. Maybe I should turn down the number of chunks it's generating, for one thing.
I mean, in theory, right, the normals align with the vertices that you're defining. So if it's like in a specific corner, you need to point, like yeah, the vertices and the normals have a relation, so you should.
Well, I'm trying to just get it to show up, for one thing. I think I might be modifying the wrong direction. I might be yeah, that would help. Okay. I'm 100% modifying the wrong one. I was trying to modify the top because I'm like, I'll do it one at a time, because there's usually a symmetry to these kinds of things where it's like, if I modify one, then I'll see it in the others. So I was just like, I'll modify the top ones. And then I'm going, but they're not changing. And then I realized that maybe I'm changing the ones that are underneath the chunks. And that appears to be the problem.
I do have to say, though, I kind of love the look of the
With a heat map.
like wireframe.
Oh, the
that it
yeah,
does.
the wireframe does look fucking phenomenal. Okay, so apparently
It's awesome.
it's just
not
not
what you want, but also.
not Y apparently. Okay, that makes a little. What the fuck is that one? But there must be X and. I'm getting tired of this shit. I was modifying the Y because I was going, oh yeah, the top one, but it's not the Y. The Y doesn't have an issue because the plane that runs on the Y is apparently across the X. And this is the issue with having to regenerate every time, is that I don't actually know which fucking chunk I'm in. Alright, we'll start with the X, with the Z, because the Z should be the easiest peasiest one to, like, narrow down and go, like, hey, positive Z. I also have a feeling that it might need to be, like, every single vertex needs to be unique. But maybe not. Just because, like, as you're saying, they need to kind of point towards the center, and the issue is that the different rings are going to be, like, sort of sweeping past the center.
Yes, also like the issue that we're having, part of the issue is also that your normals are technically reversed.
Are they? Oops. I tried to make them the same,
like,
but like...
Yeah, so like, that's why in
is...
the shader, you're able to do plus the normal rather than minus the normal.
Well, the reason that threw me off is because Z in Bevy is the opposite. Like, it should be plus and minus. Like, that should be reversed because negative Z is forward. But... yeah, like I can understand that.
So like in terms of like the normal, right? So like imagine, say, like you make a fist with your thumb out.
Yeah. Oh, is it which hand, left or right hand? That's what
Pick a hand. It doesn't matter.
Okay. Yeah.
So like the surface at the top of your fingers, like right below your thumb.
Yeah, palm.
Like that's your surface, right? And then your thumb would be your normal in that case. So the way that we're like trying to readjust the position within a cell is that that's why it should be minus half normal, so that it goes like halfway into your hand against the direction.
But so like there's like a left and a right hand thing, which is like if you look at your left hand, it's like the Z is the thumb, X is your fingers, and Y is the direction that your hand, and it's out of the palm or whatever, like however it is. And the Bevy is the other way in that like the X is the Z is negative compared to other engines that run the same handedness. So the Z's the opposite. So when I stand like at 0, 0, 0 facing forward, positive Z is forward. And a negative Z is forward. When you call Bevy.forward, like the transform.forward, negative Z is forward. Whereas positive X is to the right and positive Y is up, negative Z is forward. Okay. And so that throws a lot of people off. And but I don't know what's happening with my code.
That's definitely good
fine.
to know. But for the like normal trick, that works no matter the basis. So it works it works in no matter how many dimensions, and it works in no matter how many.
Really?
And no matter the
I understand the multiplying by a half, but I would assume that still requires that your Z points forward, which means that depending on if forward is negative or positive.
That's why we're using the normal specifically, so that because that normal will always be within the basis space, whether like the Z is forward or backwards or the Y. Like I know Blender and there's also different. So because we're using the normal, that one will be in the correct basis space. So then that kind of like readjusts for that difference, basically. But yeah, so that's why like we're initially we're supposed to do minus half the normal, but you're doing plus, and it's working. So that tells me that the normals are probably like inverse direction of what they technically should have been originally.
I think I'm annoying thing is I can't tell which set of lines I'm supposed to be working with, but I think I may have like corrected enough for the Z. I should probably also stop like subtracting by a massive amount. I need to work out mathematically what makes these numbers special, like why, because I suspect it has something to do with like where there's zeros it should be negatives, and then in the other ones it should be other ways, so like negatives, negative, negative, and then 1 for where the Z is. But it's like it's really hard to tell. Okay. Those lines definitely have disappeared.
Okay. It should be negative.
But that's what I'm saying. Like when I flip it around, should they be positive at the other side? Like that's the real question. Is do I still need to flip it for the X for the like the first 4 and the second 4? Do they flip? Like are they inversions of each other, or are they actually going to be the same? Or like each little individual one? Like should it be? I suspect that it's going to be negative, negative, and there's going to be like negative, positive, 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 negative. because of the 0, positive 1, 0, negative 1 orientation of things, but I don't actually know because it just makes sense in my head about what I'm doing.
Yeah, it's definitely like a wonky trick. If
Oh, it's a very clever thing. I just think that technically it might be smarter to recalculate the normal for every single plane so that each plane points towards the center, but then that might just fuck up some of the voxels where voxels at the edge look funky compared to voxels in the
so
center.
it's going to do this. It's going to do the same thing as we have now if you recalculate, because it's going to be a perfectly straight normal. And what we're doing right now is that we're making the normal like slightly spherical, so that the edges will point towards the inside a little bit.
I've worked out that it's definitely we have to not invert them. What the fuck? That's even more confusing. Okay, I wonder if leaving these ones at 0. I'm so confused about like why some values need to be modified and others don't, because it definitely needs to be negative on both the front and back face, which makes some sense, but not really. Or maybe it's supposed to be positive. No, I don't get it. So the Y is fixed, and then
why is that? Yeah, why is it even?
Okay.
Like clearly that 0 is wrapping around to the other side, but
okay.
Why?
Okay. So that's working. So then we go down to the X and go, why are you not working? So I suspect that it's, if we modified the Y, it's probably going to be the Y again. So I should probably 0 these out and go, don't touch the X. And then these ones look like they're the wrong way. So it's probably that it's plus and then minus for these, maybe. But the one trick is that I can just like make the number 1 and then that stretches it really far, like it's really obviously wrong. The issue is also because
just for shits and giggles,
normals are supposed to be normalized, which is concerning. I think that will break things, is that they're not normalized.
Does Bevy not renormalize them?
It might, but that might be my responsibility. Like it may be my job to renormalize them.
That's possible. I know most, like I know Godot at least, when you manually make normals, it renormalizes them.
I suspect that that's maybe a shader will renormalize them, in that the shader will go like that's not normalized. But that's what I'm saying, is that will break things because we actually want the normal to point as much in the X as we can, and in Z as we can when it's the Z normal, which means that we would need to modify it.
Because you're using point, because you're always comparing against, like a positive is above 0.5.
Yeah, I guess technically it doesn't.
You could actually get all the way to 45 degrees and you'll be fine.
Yeah, I guess. I wonder if that would cause other issues, is that technically 45 degrees would imply something else, but...
Yeah. But like, so like just a tiny amount should be...
Wait a second.
Should be okay.
So I can view them from below, but not above? Okay. But I can view them from this side, but not... What the fuck?
Yeah, so that's a bit too much. Like try like 0.1 rather than like I think 0.01 is not enough.
No, 0.1 is definitely not enough. I've already concluded that 0.1 is that's why I went to 0.2. 100%. I got it to 0.1 and you could just see them blinking in and out, which might be that they needed a little bit more Y or something. But like X or like the other axes. But like they are starting to disappear. But like it's really hard to know like what does tweaking the other number do? Because I can clearly still see them, but only when I'm looking at a very specific angle.
Yeah.
Also,
so
you can clearly see them when they're further away as well. That's another thing that's confusing me. As in, like, I can't see them on the chunk that I'm currently at, but I can see them on the other chunks.
Yeah, so I'm thinking that's because of the like compounding errors. It gets closer and closer and closer to 0 again. So that's why I'm thinking like 0.1 is probably what we want.
Oh, okay, right. You're saying in order. Well, the issue is if you go too much, you start reaching out of the block again.
No, because it's always like
If I set them to 1, they are really obvious. If I set them to 1,
yeah, so a full 1 like that is too much, but like a 0.1 should be skewed enough that it's gonna always point back towards the center.
Good. Okay. All right. I fixed the X's and we'll see if the X's.
Here, open Blender.
Okay. I suspect that
just to help you visualize.
Yeah, the point one I was going like, but the 0.01 worked and then 0.02 was. But yeah, you're right. Like 0.1 should never be able to reach outside of a block. I'm just going to bring back a mesh cube. Okay, and I'm going to turn normals on so I can see them. because that'll probably help with whatever you're going to explain. Okay, apparently I don't remember how to do that. In here. Okay.
So if you open Blender,
Yeah, I've got Blender open.
I have an idea of how to like help you visualize it.
I don't know how far behind the stream is, but I do have Blender open with the normal tool turned on.
Yeah, so we'll have just a basic cube. Okay.
Yeah.
So essentially, right, what happens is like right now the normals are pointing kind of like at 45 degrees. So in real life, they wouldn't, like in what you're doing, they're not going to be fully.
Well, technically, there's a multiple of centers.
Okay.
Yeah. So the blue one is the face.
Okay, that's what you have.
Okay, right. So the pink lines is what I was doing, and then the blue lines is what I want.
Yeah. So the pink lines are what you have right now. So now, if you shrink that, if you copy that cube and shrink it about 10%.
Copy. Okay, quick. Copy the cube. So, and then S. Apparently, it's not working. S. Okay, and then 0.9, and then I'm assuming I need to go to wireframe so I can see both cubes. Okay.
Yeah. Like you can put the internal one like as a full solid and the outside.
I don't think I can do that. Oh, not with my Blender skills. I know that's possible, but like it would take actually like rendering materials to be able to do transparency like that.
Super fair.
Alright, so I've got the what the fuck happened to the corner? What the? Alright, something broke when I scaled the cube down, but we're just gonna ignore that because.
Yeah. Okay, so basically, right, what we're doing is we're taking those little pink ones and we're bringing them ever slightly outside so that, like, if we were to bring them to full 45 degrees, what it would effectively do to remove the normal is to basically shrink along that line. So the surface shrinks a tiny bit, but always towards the center of the cube.
Right.
So that's basically the normal trick that we're doing right now.
Okay, so we're like leaning the pink line so that when we go from one to the other, we point to the other cube. Yeah.
Yeah, exactly. So it's just like right now because it's two forwards, like it would still only shrink on one axis, but by shifting them, by rotating them,
so making them more
slightly
like the blue.
outward.
So we're trying to make the pink like the blue, but not so far, just a little bit like the blue.
Exactly. So what we're like technically doing is we're making a what is it? It's an obloid cube, I think it's called. So like the surfaces are ever slightly curved, but so that it goes towards the center a little bit, and like right in the middle of the face, it goes like deeper in, but like that's fine because we're just trying to figure out
that's slightly
where within that cube, but it's always
so we're slightly rounding the cube.
Yeah, we're ever slightly rounding the cube. But when we remove the normal, we're always removing less than one cell unit so that it's only ever rounding, but staying within its own cell.
Yeah.
Hopefully that visual helps you. Like.
Yeah. Now, apparently making it 0.1 has really fucked up the faces, though. But we're going to just try and get rid of the lines first, and then we can, like, tweak it down, because, like, it looks a bit scuffed, but I don't know if that's because I've broken something else.
They're all negatives right now, yeah.
Yeah, but that's the issue, is I don't know which ones are supposed to be positives and which one's supposed to be negatives.
Yeah, so I think it's, where it's a 0 should be,
well, the trick here is that these need to be...
chunk size will be positive.
So these are both moving in the Y, like, both the X and the... So maybe I should actually, let's go... Okay, let's not fuck with the Y, because apparently half of our problem is that I fucked up the Ys and I'm moving them by like 1. So let's remove that and like let's make sure that the Ys aren't what we're seeing. But what's happening is they're both moving in the X, which means that they should not, they're like no matter what I change the value to, it should never be visible on the top face because we're actually moving the normals in the Y direction, which shouldn't affect the top face. Because none of the top ones should have a Y component. Okay. Nope, I can still see some kind of weird fuckery when I'm looking like...
Okay, so that's a 1, that's a full 1, yeah. So we'll want like 0.1.
Yeah, I don't know if how behind the stream is. I'm just like, I'm waiting on the thing to wait for you to catch up so you can see what I'm talking about. It looks pretty fucked, where it's scuffed. So, I don't know, maybe it didn't save before it ran, because I've had that happen before where it's like I controlled S and it didn't save.
Right again.
Okay. So like, yeah, it's really scuffed. Because I'm moving, okay, 0.1's too much, because 0.1's like an entire, a 0.1 of a cube.
Yeah, okay, so
That's why I was only moving 0, 0,
Okay,
1.
it's because we're using a surface is a full chunk.
Yeah.
So 0.1 is good for a single cell. So then by 16, so we'll want
So
around about like a 0
So-
to 5 probably.
so if I divide each of these by chunk size.
Right?
Also, chunk size at the moment
Yeah.
is 32, not 16. That's
Okay, so that definitely would like worsen a fair bit, yeah.
should I make the chunk size smaller and see if that fixes a little bit of our like.
So if we want to get like a little like cheeky weeky with it,
I think we
you
get it
can
working
do,
before we start
like-
getting cheeky weeky with it, because fuck me, it's not. Okay, so
Yeah,
I'm moving a tenth of a block now instead of
Yeah, so
They still
I
seem
think
to have
actually
moved
if you
quite a
make it
lot.
just one
Oh,
divided by chunk size, then that'll be like it
isn't
will
that just a whole block?
it will end like like it will
I'm gonna
make
also
it
do it
just
as
enough
a-
that it stays.
I'm gonna say like const. I'm gonna say like move.
Yeah, so because we're in 32,
Oh,
that means
offset.
yeah, so that's why like we were trending towards 0.033 roundabout. Seemed to be where it was going to go.
So chunk
So yeah,
size.
one divided by chunk size is probably
Okay, so
what's gonna end up being.
instead one divided by chunk size. I'm modifying it so that I can just put the constant in there because
Yeah,
it should
I was gonna say.
be the constant, and it's also just really annoying to have to keep tweaking all of them. AI seems to think that removing an entire normal is the correct answer. So the AI sometimes just baffles me. It's like, oh yeah, just remove the don't do 8 of them, just do 7. That'll fix it. It's made it smaller, but it's still really, really obvious.
Yeah, so that's if you have all of them offset in the same way, then it's definitely going to do that. So I think it's negative at 0 or positive when the vertice is at chunk size, or possibly the other way. Like it's going to be one or the other essentially, but like 0 will.
I think
correspond
each
to
of
1.
these needs to be different, is what's happening. So it's like each one of the 4 normals needs to be offset according to whether it's the top or the bottom of the face. So
Yes.
so when we say
So what I mean,
chunk
yeah.
size,
Yeah. So what I mean is like when you go in the code, right? So you have the 8 vertices that you're setting up, and then you have the 8 normals that you're setting up afterwards. Like the first vertice and the first normal should correspond. So like where the vertice has a 0, it should be the minus offset, and then where. Does that make sense?
I think you mean a positive. So you want to move it in when it's positive and then back when it's. So we want to add 1/10 of a chunk when we're at 0 and minus 1/10 of a chunk when we're at chunk size. Yep.
Yeah.
Yeah. Okay. I think I can do that like this, because
Whatever our offset and
Yeah. So, and that should also mean that makes a little bit sense in my head of why they would be symmetrical. Is that we're actually offsetting by the same thing both times. The annoying thing is I don't want to do it to both sides. There's actually a good way to test if we're doing the right thing is to leave one of the back faces all at 0s so that I can actually without rebooting see what our change is actually done. So I'm doing offset, 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 minus offset, minus, minus positive for the 4 different faces. And then we go. Okay, so at the very least, so from one side I can see it, from the other side I can still see it. The fuck is very weird. Right, so annoyingly, I kind of wish I could just make it so I could know which of these lines I'm supposed to be seeing and which I'm not, because the Y ones are still working. But anyway, that seems possibly correct.
Debugging GPU issues is the most annoying thing.
I'm just going to quickly modify the X ones to be times 10 so that it's really obvious when I'm looking at the X normals and not the not the Z normals, because it's annoying when I'm I don't know which of the lines are coming from X and which are coming from Z to know which ones to fix and which ones not to. So this should break the fuck out of the X ones so that it's really obvious which ones are the X ones, and then I can from there work out whether I need to tweak. I think it's going to need to be way smaller. So, well, these ones are gone entirely. Maybe. I don't fucking know. Okay, these ones are gone. The fuck? Well, apparently setting it to 10 did, like, nothing. What the fuck? Oh, okay. They're really obvious down here. So it doesn't fix the lines, but it does break the blocks, which is an interesting. So that's there. So this means that's the Z direction. Right. So it looks like the Zs might actually be correct. But that means that this way is the Zs, which is bizarrely saying that I can still see the Zs really obviously. But only... Oh, but not in this axis. This axis, they're much harder to see, which means that... And that means that's the axis that's not fixed. So the offset's not quite right. But the offset math is correct. In that, like, it makes them disappear, but not entirely. Like, they're still there with, like, floating point noise. Which is somewhat concerning, because it implies that they're going to be somewhat impossible to get rid of entirely.
Yeah, so I think that's like the curse of doing chunk size.
Well, in theory, we could just like maybe like chunk size 0.1, like, or 2 divided by chunk size. It just needs to be slightly more. The issue is that, yeah, if we go too much, then we start rolling the whole chunk over.
Yeah, like I think it's just like this is like a weird bug related to the fact that like because of the technique you're using of like a surface represents a full chunk size, then like the math gets a little fucky wucky.
Yeah, I don't think it likes
So
the
try, but like
it's like it's like the GPU doesn't like that triangles can stretch beyond 0 to 1 sort of thing. Like it kind of wants everything to be in a 0 to 1 range.
Yeah, like the math is a little hard to work because of like flooring and trying to find a cell and all of that shit. Like whenever the idea is we could on one edge,
we could theoretically like crush it all into a 1 by 1 square, like so all the values are between 0 and 1, and then expand it out only when we actually render it. That's one thing. I think maybe what we need to do is go into the vertex shader level and tweak the mesh there so that we can pass in a 1 by 1 square and scale that up to chunk size, which might fix a bunch of our normal calculations and stuff like that. Anyway, it needs to be working. It just needs to be slightly larger. And so since I know what the math is now and how to calculate the math is the more important thing, we can go fix all the others and then we can tweak the offset size until it works. So now I knew there'd be some kind of symmetry, which means that I can now go in and copy paste and like get the symmetry right. Without needing to necessarily fucking redo everything. So then you go I'm navigating around like a lunatic because it's like one of the only ways I know how to do the multi-cursor and like get it into like if you have lines that aren't the same length, it's really hard to use the multi-cursor because it moves by exactly the same amount. Is it Control Shift? Yeah. So I'm like using tricks to try and get it to. No,
that's why that's why Sosin always aligns with commas and like all those things.
Yeah, I know, but like I try to a spacebar align things, and then when Rust format comes in, it says actually no. It fucking removes all the excess white space. I'm like, but white space is used to fucking keep them in a line.
Yeah, that's why like in Vim, like I would do macros instead. So going by like count commas from the start of the line.
Yeah, see, I would have to learn all that shit. I've tried it.
Yeah, no, absolutely. It's a different mental model. Like you get used to it when you start thinking that way, but until you start thinking that way, it's really hard to reason about.
Yeah, and I also just made that annoying mistake that I always do where I had Control C instead of Control V, and then so I like lost the thing that I had copied to move. Okay, so that should fix those ones to the same region, which in theory should then fix those, right? Because it is 0, 0, 0, 1, 0, 0, 0, negative, 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 positive. Yeah, okay. So, in theory, we should have got rid of more lines. Okay, so, interestingly, looking from below, the lines are more obvious than looking from above, but actually, I think the lines are pretty... Okay, so it is kind of funny that from far away they don't work, but maybe now the only issue is that the Y ones are really obvious, and it's actually the Y lines that I'm seeing. No, it's they only seem to disappear when you're quite close to them, which makes it very much a rounding point issue. As soon as you get far enough away. Okay, so I guess I'll fix up the Y, because again, it's the same logic of just modifying it to be, so your offset the other thing is also about this is I can just flip and see if maybe it is the positive, negative, positive, negative. We'll see if the AI got that right.
What
So
is showing?
positive, positive, positive. What? Well, that's interesting because it did positive, 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 negative is the far side one, which is maybe correct. Oh, no, zeros. Yeah, so zeros become what?
Yeah.
No, zeros become positive. What are you doing, AI? It's flipped them. So then it's negative. It should be negative, negative, and then it should be positive, negative. I think it just copied what the other pattern was, which is different for the Y because the Y is not the same orientation. And then it's going to be so much easier just to copy this and paste it down because it's the same pattern, but then these become.
Yeah, and then if we need to flip like offset to try to see if we're just doing it in reverse.
Yeah, we can just flip the
we can
offset.
just indicate offset, yeah.
Yeah, it should be pretty easy.
Yeah, all right.
I think it's going to result in we're going to need to make the offset so large that it defeats the whole point of doing it.
Possible.
Because also for some reason we seem to be like, oh, because we use. Okay, maybe we should be calculating the normal and then not offsetting by the normal. I think that might be part of our problem is because we're just offsetting by the normal multiplied, but instead of working out what block we are and then offsetting by an amount, means that if I make the Y too big, we start offsetting into the next block down because we're multiplying by the normal.
But because the normal is always unit size.
Yeah, but what I'm saying is that
it
like
should stay within a cell because
it should, but
because the voxels are.
but we're updating the position that we're sampling by the normal, which means that we are saying within the cell, except that the position is moving by the normal. So if we make the normal 10 times the size, we actually sample over a block. If that makes sense, like it's because we're actually moving by the normal, we're not using the normal to work out which block, whether we should nudge up and nudge down. We're actually like sampling by that. If we change the normal to be 45, we are now sampling 45 degrees off, which means that the pixels at the edge go outside of a block. That's, I think, what's happening. Maybe we should be negating the thing. Maybe that's our problem as well. Maybe we should be negative the normal instead of positive the normal.
Yeah. It should be negative to normal. It's just I think yesterday your normals were pointing inwards rather
Well,
than
now I
outwards.
have a solid block on top instead of below. But also, interestingly, only on the top, but the underneath is staying lines, which implies that something in our math is not mathing properly. Because it should be solid, like we should just be sampling the entire line correctly, but now it's only the top of a block that's wrong. And it's also only the top
So hard.
layer that's wrong. The bottom layer is still right, which means that maybe none of our normal should be negative.
Okay,
What the
wait.
fuck?
So you have flat. Yes. Okay. So this is what I mean. So I think it's because the actual like plus one minus ones are reversed.
Okay. How do I actually fix that then? But it still doesn't make sense why when I shift that, these bottom ones should be sampling the correct block now, not just getting darker. If I swap it to a plus.
Yeah, because I think what's happening basically is like in like right, like your normals are pointing outwards, but I think the way that you had set them up like yesterday was just like you had inadvertently made them point inwards. So like the top face is pointing down.
Range. So how do I fix that though? Because like also apparently just adding the normal also fixes it, which is confusing to me.
Yeah, exactly. So that's why it's yeah. So it's because if your normal is the opposite of what it is, like then adding becomes subtracting, and subtracting becomes.
I know, but like I just mean like
right.
literally any amount of normal changes it. Like in that they appear, and it's just basically like how easy it is to make them disappear. Means that adding and subtracting normal is not the right thing to do. We need to be like working out what block it is based on its normal of whether we should add or subtract, which you would think is just using the normal, but apparently not, which is very confusing to me. Maybe you're right. Maybe we've got like the faces have got the wrong normal relatives and we should flip the negatives and positives and then flip it in the shader again. But it's weird because it's almost like the top face is pointing at the bottom face and the bottom face pointing at the top face. And no matter what we do, they're shifting in the wrong direction because we're not moving into the middle of the block. We're moving into the middle of the block outside of itself, which is not correct. I don't know. It's very
Yeah,
confusing.
so the thing is, like, we are using the normal to figure out the cell because, like, the way you have to imagine, right? Like,
It's
because
the normal's pointing towards the. But technically, the normal should be pointing away from the middle of the cell. So we should be subtracting to
Yes.
move towards the middle of the cell. But what's confusing me is that for some reason, we can break the top without breaking the bottom, but you would think that both of them would be moving out of the cell. Which implies that one of these is wound backwards because it's not moving in the right direction.
I think the reason that the top breaks but not the bottom is because you're not, like, I think it's because the bottom is full, but not the top. So the bottom, when it's reaching to the other side accidentally, then it just sees air. So your voxel is actually one pixel thinner.
It's still rendering it. Like if you so when I do this, if I set it to 0, was it, or was it? How did I get it to? Okay, so if I do minus, and then it should appear to render the tops. Yeah, okay, so render the tops. But the thing is it starts also rendering the bottom lines, which means it is actually trying to render the voxels. Like, it's actually these lines are sampling the wrong voxel. But I guess they are the sides, aren't they? They're the ones coming down that are sampling the voxel. But this entire like 0.1 of a block is sampling the wrong block.
Yeah.
That's what's confusing me. Because you're right, the bottom face isn't right. How do we get the normals pointing in the right direction? Because I think that's kind of what's fucking us up the most, is that I think one of them is wound backwards and that the normalist should be pointing the other way, is what's happening. Is that, like, the top face is one way and the bottom face is the other way. So the top face needs to point up and the bottom face needs to point down. But at the moment, I think the top face is pointing up and the bottom face is also pointing up. So it doesn't matter what we do, both of them are moving, and therefore we can never get them both to move in the right direction because one's pointing out of itself and the other one's pointing into itself. So one of these normals needs to be flipped.
Yeah, the face... Yeah, the top face of the cube needs its normal to point upwards, and the bottom one needs to point down. Yeah.
Which
exactly,
I thought is what we're doing with the plus and the minus of the y, but apparently that's not what we're doing, because if we shift the normals at all, we get one face rendering on top, which...
Yeah, so here I think it's just the ones, like the ones and minus ones. I think those are opposite what they should be. Yes.
Yeah, but this one, we're saying they should be opposite each other, which is, I think, what we require to get them to work. But it's the way the bug is presenting itself makes me think that they should actually be the same as each other, because one triangle's wound forward and one triangle's wound backwards, and we want one triangle to point away from the cube and we want the other triangle to point away from the cube, which means that they can't just point up. That's what's confusing me. Is I always thought normals pointed relative to the face, as in a back face normal was pointing away, but like if you said pointing up on a normal and pointing up on a backwards normal, they were both pointing opposite each other because the backwards normal is flipped. But apparently that's not how it works, and that's what's throwing me off in terms of trying to work out how this thing should be sampled.
So basically it's just so you have so the winding direction decides what's a back face and what's a forward face.
And I thought that flipped the normal, but it doesn't.
The normal basically is just additional information you pass in, the same way that you pass in a color.
Yeah, and so I thought that flipping like a front face and a back face of the same exact vertices would have a different normal passed in as their thing, because the back face needs to somehow be different to the front face and not just have the same normals. Also, apparently this whole thing's missing. That's a bit weird.
Yeah, so that's the confusing part. But like basically, right, like you can't think of normals as like something special. Basically, a normal is just a RGB that you're passing in. It just happens to represent a vector, essentially.
Is there an easy way to render the normal though? Like, what's what we need to do is if we can.
Kind of lines.
Well, but I want to render the normal while that we actually see. Oh wait, I can do that with the thingamabob, the mango. Can I just fucking be like normal? So it's like if mesh. Annoyingly in shaders, everything has to be an F7. You can't you can't just return, because if there's any code left at the bottom, it just says no. I won't compile that. So I'm gonna say if world normal doesn't dot x not equal 0, which means we're not going to get all of them, but we can just return. We just return.
One thing we could do is if you just return the color as the normal.
Yeah, so I'm returning the normal as the color. So we're going to return mesh.
Yeah, and then
Dot world normal dot and then comma on 1, so the opacity is correct, and then apparently me is not found in scope, which is very confusing because there's no me in the fucking document. Hey, okay. So very confusingly, the top has very wrong colors, which is interesting because it shouldn't have a black side. Doesn't that mean we're getting negative? Are we passing in negative fucking normals and then it doesn't like negative normals as colors? Okay, yeah, no. I need to multiply by a half and add a half so that we end up with 0 to 1 normals, not because you can't pass a negative color in, so it's just rendering black on most of the faces.
Yeah, so +1 divided by 2.
+1 divided by 2. Okay. +1. And then times by a half. It's shader language times 0. Always faster than to multiply than divide. Okay, so it's making a very pink looking fucking monstrosity of a.
Yep.
Alright, so I need to fix the rest of the shaders because the other ones are all wrapped the wrong way too, which means they weren't rendering correctly. So I need to go tweak the. I assume that the top and the bottom is correct, but I don't actually know. So I'm just going to flip.
So the top should be pure up, or almost pure up.
Actually, what I might do is if I just say do 0, we can turn it into a single voxel, get a single voxel rendering the normals correctly. Oh no, it seems like a lot of work actually. Alright, we'll leave it like this. I'm gonna say. I was gonna try and make it just a single plane, but then the x's are the wrong and the y's are the wrong. Alright, I flipped the x, and I think I've left y the way it is. Okay, so I have magenta on top. Also, we ignore the LOD stuff because that's being rendered differently. But that's because once I fix this mesh, I'll copy it down to the LOD stuff and modify the LOD chunk generation. They're generated in a different function.
Yeah, so in theory, we should have 3 sides that are like this.
We have a yellow side, a magenta side, and a cyan side, and then we have a white, a darker yellow, and another. Is it another white? What the fuck is this? It's like pink.
Whoa. Okay, that's a weird effect.
Yeah, I'm flying through things.
Further out.
I made it go a little bit fast. Yeah, that weird effect is because these aren't being generated properly. They've got the wrong normals, which is even more confusing because they shouldn't be pink like that. And they shouldn't. Maybe cyan. I don't know. Maybe. Right. So should we just go back to old normals? Maybe. Very confusing. I also don't understand why when we go further away from the start, the normals they seem to change color, which seems incorrect. But anyway. Like, shouldn't they just be a solid color on top? They shouldn't gradient like that.
This should be full color. Well, there should be a slight gradient because of the slight adjusting that we do.
Yeah, but that's what I mean, is that the slight adjustment should be on... This top face should be 100% made out of one square, so that the square shouldn't have a gradient across it, because all 4 corners of the square... Oh, no, yeah, right, because we're tweaking each corner slightly different. Right, okay, never mind.
Yeah, like it should be like subtle enough that it basically doesn't show very much, but it will have a bit of a gradient.
Because it's so much easier to see
Like,
things in the shader, I'm just going to multiply the shaders by, like, 0.1 and, like...
Yeah, like... Yes, but I've seen that back, like, pillow texture. So that is what you want. But the color doesn't seem pure enough. Is the problem. I'm
trying to darken it to the point that I can actually see if it's doing anything, but it doesn't actually. It's just making it darker. It's not actually. I was hoping it would make it more contrast, like specific. Like, I guess can I like maybe clamp it? Maybe that's let's say let C equal out equal.
If you square it, it should make the values more value-ish.
So you reckon if I wear the color?
Yeah, because then like the ones that are like super small are gonna get very, very small, and then the ones that are more pure will stay pure longer.
Okay. Apparently power of 2 is not enough. Power of 10. It doesn't like that I used power. Okay. Okay. Apparently a power 10 makes everything black, so it's too much apparently. Power 3? What the fuck color is gonna work? Okay, power 5. I guess it's exponential, isn't it? So
Yeah.
Power 6. Okay. So what I don't like is as I move around, I can quite clearly see the voxels, which implies that something's leaking through and that like it shouldn't be doing voxel level stuff. This should be a perfectly smooth gradient from this corner to this corner. So I don't get why I can see voxel lines. It could just be like that there's certain, like you can see the plates underneath, but like it doesn't make sense.
You can see per chunk.
Yeah, no, but I'm saying like I can clearly see the chunks. I'm saying, but I can also within a chunk see the voxels. Like it's hard to see, and it's probably getting killed by compression. But there is like a quite distinct. I can see. It's probably just where the other lines are poking through ever so slightly, but there is a very faint line where the voxels would be. So like there is actually like a banding happening, like a color banding. Really obvious.
Oh,
yeah.
when you were inside the cube,
Yeah,
those were the correct normals actually. Yeah, so.
See, but they're correct. But that's the it's one of two faces. So that's the negative y face and the positive x face, I believe. Yeah, positive x. So the positive x face is correct, and the negative y face is correct, being pure red and pure green. But the other is dark, dark, dark,
a little
magenta.
behind. So yeah,
Yeah.
like when you were inside the cube for me, like probably a minute behind for you.
Yeah, but that's what I'm saying.
Yeah,
The
like
reason
red,
that looked right is because but the only reason you can only see them inside is because the other chunks blocking them from being visible. Which maybe we should just go down to like one chunk because that might make it a little bit easier.
Yeah, that might be a good idea. Just
so we go
make sure that.
Well, I was going to try and cut it down to 1 pixel, but one voxel. One voxel is really hard to do because it's not just as straightforward as modifying.
Yeah, like essentially, we're treating one chunk as one cube, so it should be fine.
I gotta find where I actually spawn the world in. There it spawned as well. So we're gonna say like 1, and then we'll go from like 1 plus 1. Actually, I should probably do 3. I'm gonna do 3 by 1 by 2 so that we can actually tell which axis is which.
There.
Because otherwise it becomes really annoying because you go, which way the fuck is X? Which one's Z? Y is really easy to spot because it's up and down. But... Alright. So. Oh, fuck me. I made it 3 by 3. Fucking idiot. Because I made one of them 2 by equals and then I made the other one's -1 to 1. It's like, that's just 3 by 3. Anyway. If I hadn't changed anything, it would have been fine because I would have actually put the right number in. Anyway. All right. So. Wait, it's still with 3 by 3. What the fuck did it not? Oh, it didn't save, I bet. What? Why are you not different? Oh, because it's 0, 1, 2. Fucking 1 to 1.
0, 1, minus 1, 1.
Well, I don't get how it was 3 by 3. I made it smaller and then it was still 3 by 3. So that's even more confusing to me, honestly. Okay.
You might want to make it like 1 by 3, just so it like shows even a lot.
So now it's 2 by 3. So the negative is not actually correct because the negative y is positive y. And by a lot too, for some reason. So the y needs to be flipped, is what I've concluded.
Yeah, wherever you are on the positive x, when you're looking at it, should be red. When you're more y, yeah.
So I'm just usually responding to the the other thing, but like so far behind that I'm modifying code, and you're like, yeah, I can see what I'm looking at on there. No, that's not. I can see in my preview thing where approximately you are, and I can also tell I'm about right because you're actually responding to what I can see on my preview, but like you're
cool.
not responding to what I'm doing. If you want, we can maybe make it easier because I think I can stream on Discord as well. I don't know if I have bandwidth for it. But I screen share. Which fucking entire screen? This screen. So screen share the same screen that I have. So that like that should be less behind because it doesn't just do all the like ingesting on YouTube's end.
Not a bad idea.
Right. So
Yeah.
positive Y is correct because positive Y is positive Y.
Okay, perfect.
And then positive X is correct because positive X is positive X. But Z is
Yes.
100% wrong because there is no Z. Ew.
Wait, both sides are wrong. What if you go inside? Then does it
No,
show
because
specific?
the reason inside works is because the inside lets us see the other back faces, but that's what I'm saying.
Oh,
The
yeah,
reason
no,
that they
that's
look
true.
correct before is because we were just looking at a face that was hidden previously. So those two faces are 100% correct because of the orientation of the cube. I happen to know that it's correct.
Yeah.
Now,
So
why
now
is
there's just
why is
that that's not working at all.
okay? So part of the reason that Z's not working is because they're all fucking negative. So they would all be the
holy
same thing.
Discord compression. This is in 480p. Wow, that's
Well,
hard to read. Okay.
It probably has a little bit to do with me streaming, and like I don't have the bandwidth to stream, let alone stream twice. That's why you're supposed to dual stream because then you send it out and then that like it's sent to two places. Right. I think the no, that's positive. Well, that's the hard thing, isn't it? I don't know which end is the positive X end and positive Z end. So I need to somehow mark the positive Z. We're gonna go.
You really should have a like debug that shows you your position in the world, just so that we can keep track of it.
That's too smart. All we need to do is go to our world generation and say if Z equals 1 ampersand X equals 1 continue. So we just won't render on the positive X, positive Z side because I know which side's X easy because it's like we spawn in a certain way and it's like I know which way I'm pointing. So okay. So positive Z, positive X is that one, which means that's negative Z. That means I've got that backwards. It's pointing in the wrong direction. No, wait. No, that's correct, isn't it? Wait, the normal's supposed to be pointing. The normal's pointing out, yes, which means that that's the wrong end because that's pointing negative. So that's backwards. Okay, I'll modify that. So we're gonna flip you. Ironically, I think it's back to how we started.
Yes, I think so.
But only for the Z. X and Y have been flipped, but Z was correct. Z was correct the whole time. It's only, as I'm saying, it's because Bevy points the Z in the opposite direction. Positive Z is the opposite of positive X in terms of like which way you would think is forward. Okay, so if we go positive X, positive Z, positive Y. So we're in positive, 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 and they are all green, they're all full color. Right. So,
perfect. Okay. So now those are pointing in the right way. Okay. So now in the shader, that is removing the normal, right? Are we at negative or
we're
positive?
adding normal. We're adding normal to
So it should
position,
be-
but that's
Yeah, so it needs to be negative.
subtract normal times 0.5. Okay, subtract half the normal.
Yeah.
Now, my concern here is I don't think we're actually having negative normals in the right spot. But like, maybe we are. I mean, the real trick here is just if we just comment this out, does it work now? Did we fix it? No. Okay. So the lines are still there.
Yeah, so lines are still there. So that's because like the 0 is, but it's only when it hits a perfect 0, 0.
No, it's anytime it hits anything, because look, like even on the chunk, you can see that there's like the top of the chunk doesn't actually line up with the bottom of the chunk. That's why you can see. So because we're tweaking the normals ever so slightly down, we're we're like rendering slightly lower. We're like pushing the face down somehow. I don't quite understand that bit.
Yeah, so basically it's because it's hitting the side plane first, and then that one is like at 0 on the edge of that first slice. It goes to the other side.
Hmm.
God, how the fuck do I explain that?
Yeah, like I kind of get what you're saying is it's not actually below, it's that we can see through it into the other side when it's like that and it looks like it's below. But it definitely feels like I can see into the other
it's
side.
Just that because it's not air, it's just that like this is the border between a chunk.
Well, because you can do it,
So
you can see it in the middle too. You could, if not so obvious now, but when I like made it really, really big, you could actually see it. It's on every single plane it does it. But yeah, I think it's because it's checking like outside of a chunk or something, because they were air, like the top half is air, is that it wasn't rendering the top half if it was near enough to the bottom. That makes sense. Yeah, it's like wrapping through.
Yeah, so that it's hitting because it's getting at the zeros that are like the flooring makes it like it thinks it's on the other side.
Well, it's wrapping on the corners, which doesn't make sense. Why are the corners and all the corners, edges? The edges are wrapping. The faces is fine as long as it's in the face. But why do the edges wrap?
No, so what I think is happening is that the grid that we're seeing right now is actually the top face. I
just realized something. They're too thick. They're too thick, which implies if I come back to our mesh generation, they're too thick, which means it is -1. They're too thick. They should only be a pixel thick, but they've got a thickness to them, which means it's sampling the wrong direction. We're actually making them bigger. So if I subtract the offsets with adding the offset, they are significantly smaller, and now they are rounding errors.
Perfect. Okay, so now just for shits and giggles, right? What if you change that 1 to a 2? What happens?
Well, I want to see, because I'm pretty sure last time I was doing it, like when you like looked across, like really obliquely across the surface, you could actually see the errors, but they're not there now, which makes me think, wait, like what if we, again for shits and giggles, what if we turned it up to like way higher than 2 and said like, what happens if it is too big? Like, what if it's 10?
Yeah.
Like, is this going to cause half of a block to disappear, or is this going to like do absolutely nothing? I suspect it's going to shift all the blocks over by 10, which is kind of funny, but
because it's normalized, it shouldn't shift by much. Like that's the thing, right? So that's why like normals being normalized or like Okay, wait. So that tells me that it's remove the negative.
Remove what negative? Well, they will just expand out now.
Positive.
They will expand outside now. They'll pass through that block and into the next block. So the reason that this
right now it's expanding outside the block.
Now it's expanding outside the block.
But right now it's being
now it's expanding outside the block. That's why we can see it. As I say, the reason you could see that before is because when it's really negative, we're actually going like we're not even rendering the edges of the blocks. So we're actually seeing through the block because the edges were cut off. So if I make it positive, so it's saying the lines were too thick, which meant we were going the wrong way. We need to go subtraction so that we clip more of the line.
At the top here is actually the bottom of the chunk, I think.
Yeah, that's what's happening. Is it's wrapping around and rendering the bottom of the chunk. So as it expands down into the bottom of the chunk, it's actually got stuff to render again. Or technically it's expanding up into the top bottom of the chunk. It's going too far up, which wraps it around to the bottom and it pulls information from the bottom of the chunk.
Yeah. So then we gotta so we need to find something. So like instead of 10, what if it's 0.1?
Well, my only issue with that is it implies, because first off, the 1 wasn't enough, which means that doing 2 might work, but eventually we'll get to the point where you'll be able to see into the block because it's cutting it. Because so at 2 we can quite clearly see through the block. Now my interesting question is, am I actually seeing the other side of the block, and therefore it's only because we're in a void world that this is a problem? Wait a second, that might be fine then. Wait, that should be fine. I mean, it's going to make our rendering costs a bit harder to optimize later, but we can only it only causes an issue on a block that doesn't have an opposite face. Because in theory, you can never see through a block because you'll see its other side from the inside. It looks a little bit wonky. But like, yeah, like the blocks look fine as long as they're not blocks that you can see the void through. Ooh, no, actually, if you can see another different colored block, they're a little bit wonky too. Like internally.
Well, that's because it's so big, right? Like
No.
4 is a lot.
But as I'm saying, at 2, you can still see these. Even now, you can still see these lines. So it's not the best approach because all it's doing is trimming it. But if we're axis aligned, we can see them, but only on the axes. Only the one directly centered to us.
Yeah. So like
And
this trick
even
was,
more
like,
confusingly, directly centered with the position of the camera, not in front of the camera. It's axes aligned to the camera.
Oh my god, yeah. Okay, that's weird. Yeah, so like this trick like works perfectly on a like cell by cell. So yeah, it's really just it's because of the fact that the mesh is entirely
Yeah, it's
like
because
we're representing a chunk in one, like a slice of a chunk.
I think it's
in
also
one
because
space.
we're not correct. We're actually not pointing to the center of the chunk. Yeah, I think it's part of what the problem, because we're using the same set of normals for every single block. You know what I mean? Like, I think if we went in and modified it, so instead of using the offset, we did the offset multiplied by X or Z. Well, we can just do that actually because we have access to Z. We can just say Z. I think what would end up happening is that like as we move through the middle of a block, like as we move into the middle ones, we will start to offset. Why?
Yes. Okay. Yeah. Okay. Yeah. So it's because we're rounding each slice to be circular, but we're not sphericalizing the cube right now. Yes. Okay. Yeah. I see what you're saying.
Yeah. So like the ones at the edges are the ones that are the worst case scenario. Okay. Also, maybe Z might have been a bit too aggressive.
Yeah, so it would not be Z. It would probably be like yeah, okay. So it's because we need to do the same.
Well, also we need to work out exactly what we're supposed to be multiplying by, because at the moment we're making it too big. As you'll notice, they're all basically gone except 2 of them are permanent now, which means we're doing the right thing, just in the wrong order. That the number is getting too big.
Yeah, so I think it's because this number is getting too big, because like the way that the normal trick works is that like right now the center gets pushed more, like you saw the pillow effect, right? Like it you had the edges are slightly higher, but right now you're just kind of curving one edge rather than evenly.
Yeah, but I shouldn't be able to see any of them is more what I'm confused about.
So
anyway, stop trying to stick as F32 everywhere. Oh, because it's wait, what? No, the offset. Oh,
so
okay,
we're gonna need
right.
to like do a lerp, I think, to get like if we want to get this proper, like we're gonna need to lerp this thing in a weird way. That'll be fun.
So you're saying that the middle ones can't just be a multiple of, they need to be a, well, no, actually, wouldn't it be up, down, down sort of thing of like, as we go to Z, we need to start at negative the offset, and then
so
go to
Z
positive,
minus.
Okay. Right. So we need to say like,
Z minus half the chunk size.
Offset equals.
And then divide that by chunk size. I think.
So it's so we need to be like Z minus chunk size times a half.
Chunk size.
Yeah, chunk size. Z minus chunk size times a half times offset, and then
divided by chunk size.
Divided by chunk size. Okay, well that's the same thing as the offset. Anyway,
yeah, so that way we should have the that same pillowy.
So we say Z as F32, and then we say that you are now offset, and then the AI should pick up on that I'm replacing the word capitalized offset with lowercase offset. Then we need to take this down here. Why are you just randomly trying to insert a new line, AI? Get down there.
So we need to leave the capital offset in one direction, and we're changing just the other.
Got this. So I think what we need to do is because it doesn't make sense to use the capital offset anywhere if we're doing this. So what we need to do is offset by positive and negative our new offset values. So we're basically pushing one side in and pulling the other side out. Like, so both sides actually move towards the center or away from whatever, like whichever direction we're moving by a different amount. So we're going to make like basically we're curving it. We're bowing out the middle, I guess, is what we're doing. Or bowing in the middle, whatever it needs to. Ooh, we went the wrong way. We definitely went the wrong way, but that's easy to fix, and that was why I did it as a constant, is because it's easy to fix. So does that mean it's x plus and z plus? It could also theoretically, wait, we should check that, because it could just be that, ooh, that's a promising sign. You'll notice that it's missing on one of the axes, which implies that it's only like x and y that is wrong, right? Like, maybe? No, it is on all three. It's just look weirdly different. Like, for some reason, this one, it's almost perfectly gone, but then also it's like really, really thick. Oh, wait, we're just not going by enough. Like, look, as we get into more and more positive, it gets worse and worse. But like, here it's almost completely gone. But then okay, so we're doing too aggressively, apparently.
Yeah.
I guess.
Yeah, because so the math we're doing right now,
like it's almost entirely gone at one end, but really bad, and we need to invert the front back faces. Look, so you can see these ones are really bad and these ones are really bad, but at like a diagonal. What the fuck? Like the diagonal's almost perfect, and then I flip around and the diagonal changes, which means it's the diagonal that's wrong. What the?
math,
Okay.
why are you so hard?
It's
Jesus Christ.
almost all of the problem is that we can't actually visualize what, like, if I could see the fucking normals, I'd be like able to know exactly what we need to change. But because I can't see the normals very easily, I can't be like, oh, these ones are pointing in the wrong direction. I'm going to just visualize the normals back on. We'll wait for this to change it first. Okay, that made it even worse. So
yeah, okay, so I really do think that like part of the problem is because we're going to need capital offset for one axis, and then we need small offset for the other.
Okay, here's the problem.
Because like we have
So just like, I don't know how far behind. See how we've got a red corner, a green corner, and now we've got a black and a yellow corner? We need the yellow to be in the middle and the outside ring to be black, I guess. That's what we need. We need the most offset in the middle and the least offset at the edges, I believe. Because if I turn this off, it should be that the black, actually this will tell us almost exactly what we need to shift the is the black, yes, the black side's missing. So we need the outside to be black and the inside to be yellow. Maybe? No, other way. The inside to be yellow, green's really bad, this one's almost gone entirely. Maybe that's because that chunk's missing. We need one that has like a full thing. We need to look at the top maybe. So this one's basically completely filled in. Apparently I broke it. So this is definitely the wrong way. Okay. No, so I flipped all the signs and then I regenerated it and I thought it was still working. But we know it worked with negative. So if we minus half the chunk size, minus half the chunk size, minus half the chunk size. Because once we've worked out exactly what we're doing, we can just do that to all of them. So what we need to do is have the center be the brightest and the edges be the dimmest, so that we're basically sphericalizing it. Projection makes sense.
So you might want to try putting the like negating the entire thing, not on the inside.
If I look at it from this side, right, whatever color is over here is the color we want. Whatever that color is, we want at all the edges. And so I'm just going to go to the shader. I'm going to modify the shader to tell us what the normals look like. So annoyingly, that's just like a really pale green. It's not a very obvious color. Okay,
yeah, no,
so
it's
what that's telling us though is that we don't want no color. We want whatever this color is to be here as well. How do we emphasize whether that's brighter or darker? Like which one's closer to 0? I think this is closer to 0, this corner here. The closer to 0 is worse. So we need that to be the...
Yeah, so try adding, try negating the entire offset now.
Well, like the issue is I have to recompile to negate the offset.
Yeah.
What if we just negate?
So not change. So not change the plus to a minus. Like negate the entire thing. Like.
Oh, okay. Yeah, gotcha. Yeah. I'm just curious if just doing one or the other, because there's also the other thing is we are in fact fucking with the. Ooh, it changed where though. That's interesting because I haven't rotated it by 90 degrees. Just give me a second to turn the shader off and have a look what that actually looks like. Because I've rotated it by 90 degrees, which implies that
Yeah, but also
that's so much
we're
worse.
definitely going to need like because the thing is, right, like when we were doing capital offset, we were like doing the pillow shading. We were doing the pillow shading. We were like collapsing
but
the
we
center.
were doing it everywhere. Like
and-
that was.
So
The X and the Y
I
probably
really
shouldn't
think
be the
that-
same. That's actually also another thing that I've just realized is
exactly
we're actually
right. So
offsetting
I
the
think,
X and the Y by. So we should one of these should be probably zeroed the whole time. It's only that.
So one of these needs to be small offset, and one needs to be like capitalized.
Ah,
offset.
okay. Yes, I see. I see.
Because
I see.
they both need the curve, but in different ways depending on where you are in that like 2D.
Okay. So here's a cheeky thing that we can do is we can say fuck off all the others and only do Z. Is we can go, hey, don't fucking render any side but the Z offset of the voxels.
That's a good idea.
Because that should make it
simplify this.
That should make it much easier to be like, okay, we can just tweak it until the Z doesn't fucking do it. Okay. I'm also going to turn off one of the whole faces. I'm going to say the back faces. I want to turn off the rendering of the back faces, but not the generation of the back faces, and that should fix them so that they don't. It's really hard to work out like what we're actually doing wrong, and because we keep tweaking two things and not knowing which one's getting better, which one's getting worse.
Yeah.
Okay. So, conclusion. This is the positive face. Okay. So what I
So
can
it's
definitely say is if I do this, I'm fixing it back to like, I've obviously made it way worse. So I'm just going back to what I knew was slightly better at least. Technically that's still negated, but that should be fine. Alright, fuck you. This works.
What the heck?
So what that means is we probably, yeah, I have no idea. I think they need two different offsets. So what I'm going to do is I'm going to flip which set of triangles we're rendering, because it could be that these offsets need to be flipped, like the second set of offsets are the wrong way around, so we actually need the inverse of the wrapping direction. And that's why it was doing that weird banding, is that for technically half of the time it was correct, but the other half it was wrong. So it was like the front faces it's correct and the back faces it's wrong, and therefore we couldn't see it when we were looking at one. It's really hard to find this. No, apparently that it's just fixed.
Okay.
So is it maybe it's a conflict in that, like maybe the other triangles, like other plane, no, because it was still there. The other planes were rendering. Fuck knows what I did. But the only difference is that we're not rendering the other planes, so maybe it's like they're still ever so slightly there. Like you can see them like while we're axes aligned. Like there's like a fucking 2 pixels of them, and now they're really bad. But like, the fuck. But like, I'm actually okay with that as long as like, because it's literally only like, or maybe it's because we're only doing so many chunks, but like it's one plane, and it's the plane that like we're directly in line with. And it's like to do with us not being in line with it. It's like it's a camera rounding error. Like I don't think we can get rid of that. Well, maybe we can. I don't know. I think maybe we need to bow it like spherical at the moment, because at the moment we're only bowing it in the Z axis. Like we're like no.
Yeah, exactly. So that's why we need both versions of the offset in different times.
Okay. So like, the question is, do we work on fixing that or
offset? So capital offset, right? So as we're going through Z, that needs to be like on the perpendicular corners. That's when we need capital offset. And then this offset is as we progress.
Okay. So
through Z.
What you're saying is that we need to be offset on 0, capital offset on capital size, and then on the inverse negative, instead of being positive, negative, positive, negative. Like, so it should be like, this one should be capital.
Because basically, right, like
offset,
when the problem we're having, right, is that like right now we're kind of we're taking a single slice and we're curving that square, but we need to curve along the axis so that it curves the rest of the cube in the other direction.
Well, the thing is we only have access to the 4 points. So it's about like, are we bringing it in more as we get to the ends, which is going to make it like a tube with pinched ends, which is what we're doing now. But you're saying that there's something about when we're directly in line with the chunk, we need to do something which is like the top of the bottom needs to be offset somehow.
Like,
Or we just need to offset it by more.
yeah, so like, okay, here, I have a laptop in front of me, so that's like how I'm visualizing it right now, right?
Yeah.
Okay. So what we were doing originally, right, is like the screen, like sitting up, right? That's a single plane of what we're doing, right? So the corners of that plane, those we were slightly bowing, so that specific plane was pointing towards the inside. But the problem is in the other axis of like going forwards, like into the screen, right?
Okay,
That direction was not being bowed as we progress through slices.
Okay, so that is what's happening. So at the moment, so if you're picturing a screen, right? At the moment, what we're doing is we're saying that the first screen has its corners squished in more than the next screen, and in the middle, we're not squishing the corners much at all. And then we start, wait a second, we're not squishing the corners at all in the middle. That's interesting. I wonder if that's helped that or not. We actually should probably be saying something like plus offset.
So like we're kind of like making it into like a tube rather than a sphere by using just one offset. So that's why we need to mix both. Now the question is, where do we put which one? I am not.
But I don't think we can make it into a sphere because we don't actually have access to. No, we are making it a sphere. We're making it a tube, but we're making it a sphere, but we're making it like a rhomboidal. Fucking, we've got a blender. And we go. What we're doing is we're doing. Actually, this is what we're doing. But the other way, I think.
That's what we're trying to do. But right now, like say like along that, like forwards, like right now visually, then like we're only curving to the left and right. That's what we were doing originally, which was the problem.
How do I get it to not delete? Oh, it's a faces only? Faces only? Only. Keep pressing the wrong button. Only faces. And then we're going to go, we need to go like edge selection mode and go delete these edges only. Only edges and faces. And then only edges and faces. So this is what we're currently doing. But I think we actually, So just imagine that this is all like that. So we're doing this, but like 32 times. Is we're doing that. But I don't think we can do this plane because you'll notice that there's nothing here. We can't like bow the middle out. It also doesn't matter because these ones are only in this plane. So technically, this is an inverted sphere, but like it is technically spherical because if we did the if we can grab this and go here, like this is a sphere, but it's a square sphere. Like it's still a sphere in that, like geometrically speaking, it gets closer to the centers. I don't think we can make the middle bow out.
Like if you look straight on to the
you need to give axes. Right? X. Like this?
Yeah, so like that. So what we were doing originally is that we're taking those like corners. So like the top left one was being, the normal left along the top was being bowed outside so that it like, it goes more 45, but not quite. The problem is like the next slice over was getting the exact same thing.
Yeah, and that's what our tweak has done is we've said take the position in the array and then bow the ones outside more than the inside ones. But changing this made it worse. Doing offset, like swapping between the offsets is, I think it needs to be keeping the negative positive, and we need to keep the magnitude so that basically we're shrinking them all by the same amount. The issue seems to be more like it's somewhere else. I don't think it's doing like what you think it's doing, because I think like you're saying about it not making it spherical, but I'm saying like, I think this code here is making it not a sphere because obviously spherical, but it's not a perfect thing. So I think what you're saying is that we need to tweak these values by like this one needs to be like 0.1 bigger and this one needs to be 0.1 smaller, so that we start, because at the moment we're only expanding them left and right, but we actually want to be saying like also grab this corner
forwards and back.
like this.
a little bit forward and back, but we need to figure out like.
But we would need more
which
vertices
one
because we would
of
also need
those.
to we would need to subdivide. We would need a center point. Otherwise, when we push all of them forward, then they're all forward. So what we need is to say, how.
Yeah, so that's the thing with like normal interpolation. So like when you do, yeah, okay, so that's the weird part, right? So like Blender, right, has the normals like on the corners pointing like say 45 degrees, right? But then when it does the fragment for the center of that edge, that one is actually pointing straight up because it
Weird.
was interpolated between those.
Yes, that's what I'm saying. So we need to tell it to do this, not do that. And I feel like the issue
Yeah,
that we're
but we
having is that when
shouldn't need more edges because we're using the normal to do this.
but we
going.
need that center point to stay the same, because otherwise if we push all of these back, when we interpolate, the interpolation doesn't come back out because we don't have this central point to say, like, to pull the interpolation out, which means if we just interpolate, because I can actually do that with this, if I go, not yet. If I select these four corners and then go, well, space, that's its interpolation, and its interpolation is just flat because they don't. So they need this central point so that they interpolate back to flat. Otherwise, they'll continue being bowed the entire time. We need like an additional vertex to pull them back straight.
Well, because it's gonna like that's what I mean, right? So it's because it interpolates between the three of them.
Yeah. Okay. So even if I do the three though, like, because I can just subdivide that.
When the three corners average out in the center, they're gonna go back to straight.
But then that's what I'm saying is we need to. So I guess what you're saying is we need to pull this corner forward so that the interpolation, and then this corner forward, so that when we interpolate the two corners, I think I've drawn it between the wrong set of fucking triangles. It's getting very confusing. Like it's base. So,
Yeah, it's very hard to visualize with like actual surfaces because normals work slightly weirdly, but
well, my thinking with
yes.
it is that, like, okay, so I should probably just like I'm gonna delete this one because this one's broken now. We're gonna say, like, so what we need is to first off select the same triangle, do face and do face. We need to pull this corner. I'm going to delete the other two triangles because two squares, because they're just making things hard. So we need to pull this square far enough forward and this square far enough forward, because then the zero is still zeroed. And then when we push this one back, see how like it's still moving that central point though. So we can't move all of the corners. We can only move two of the four corners, because as soon as we move the other two off of the axes, we start moving the central point, the average. Because
yeah, so here's the weird thing that like I like it's because we're not moving the points in space themselves. We're just changing the normal.
Yeah,
so
but from what I understand, it's like when we smooth across the normal, it's just interpolating. So this normal is interpolated that normal, and then that normal is interpolated that normal. So if we just pretend that this is the like these are the vectors, like the positions of these in the space are the vectors of the normal, then this face actually represents what the value of the normal is doing, because it's being interpolated. So I'm saying if we move this corner, we actually end up changing where the middle of interpolating these three becomes. So that the blue normal here is actually what you would get if you took a perfect interpolation of these three. That blue is that perfect interpolation. Like, we're not saying this face would have these normals. I'm saying if these points represent the vector that is our normal, their position in space is the vector that our normal points in, when we interpolate them, we would draw this face as a, like, if we like drew the vector as a three-dimensional point, it would fill in this face. And so we can't move all four of them, because moving all four of them actually just moves where the average is. We can only move two of them. But this is a good visualization because it actually does say that we can move two of them. We just have to move the right two to pull the average forward.
So actually, because of the way the interpolation works, you basically get a point in the center that is the same as long as you move the opposing edges the same amount outside
I think that only
or inside.
that only works if we are, because we're doing a triangle and not a quad, so that we can't have a point like that doesn't move if we move all three triangles. If we only move two of the
So that's the
points,
thing.
then
We're
it
not
works.
moving the triangles. It's just
Okay,
the normals that are interpolating. So, like,
yeah.
say, like on the left you have like -3, and then on the right you have +3. Right? As you interpolate between those, in the center it goes back to 0.
Yeah. So
that's
what
why,
I'm
like,
saying is this
virtually have a
isn't
point
the
in the center.
this isn't an actual face that I'm trying to represent. This is the value of the interpolated values. As we interpolate from this point to this point, we move along this line. As we interpolate from this point to this point, we move along this line. And if we interpolate between all 3 points evenly, we end up here, like in the center of this triangle. And what I'm saying is we can't move, we can move any two of these triangles and like correct the third one so that the center doesn't move, but we can't move any, like once we start moving all 3 triangles, the center starts moving. So we can, like, we have to offset 2 forward and 2 backwards so that the interpolation between these two averages out, and the interpolation between all 4 would average out. But the issue we run into is that the shader never interpolates between all 4. So if we move all 4, we just move where the center is. We don't actually get that. There's no way that the shader knows that the to make the center what we would want it to be. We would need a point in the center to be what we're interpolating to. Like I can't see how it's like we're not touching the vertices. I'm saying like when you interpolate the normals, changing any of the normals would change where the average center point is.
Yeah, so because of the way that interpolation works, basically when you're at the in the middle of that, like if you go back to Blender, when you're in the middle of the triangle, right? Like in that center point, like of the face itself, it doesn't actually touch the other one that's not directly along that line because of the way that the math works out. So it only uses those 2 opposing corners.
I thought it was interpolating between the 3 points. It's just that this one has, the math cancels it out.
It's interpolating between the 3, but essentially you have to kind of half imagine it as like,
So
it's only touching the 3rd one when it's off that center.
Yeah, when it's somewhere in here. And this one, what I'm saying is like, when we rotate like this, the issue is, this is what's causing our issue, is that this 3-dimensional kink happens. Because looking at it, the math says it looks like this. But like what we're seeing is this view, where this is our line that's causing our issue, is that, well, actually, technically, it's this way. We want something like this so that this looks flat. But if we pull all of them back, which is what we're doing, we're shifting them all inward but not outward. Maybe that's because this would be the moving the 3rd dimension. So what you're saying is we shouldn't be -1, +1. We should be like -0.9, +0.9, and like or 9.1. I guess I don't know. It doesn't make sense in my head. I guess I'm missing something because it's so close because it's only very few pixels that are causing the rendering issue. But I don't think it's a constant offset, not constant offset, unless that offset's being applied to the Z itself. Which actually, ironically, would be a thing that we could do.
The thing I think that we're running into is that like the different slices need to have a slight variation between them. Not every slice can be the same way because some of them need to be shifted forward a little bit and others backwards a little bit.
Okay, I got you. Yeah, so they can't be spaced exactly one apart.
So like right now they're all the slices are one apart, but like the way that we're offsetting the normal is like we're doing towards the outside in a per slice basis. Yeah,
so that's actually this axis is what we would need to tweak. So it's this is correct. This is basically saying if we go back to Blender, this is saying if we just I'm going to go back to being like a regular square plane, please. Can delete this and then we go Shift A. So at the moment, we are doing this on every single one, and like the ones in the center are being like, I keep changing my cursor type by like, I don't know what hotkey that is. All right, so we're doing this as we go through the slice, and you're saying that we also need to do, can we go to fucking single? We also need to do this as we go through, like, or like, I guess technically this, but like more or less as we go through. So that one is actually this. It's not that we need a positive and negative, the capital lowercase offset. It's that we need the 1 to be offset as well.
Well, Yeah, the constant one is the facing direction of the face.
Yeah,
so that one is correct.
so when we go to
It's
Blender, the 1 is this way. So as we go through the square, we are scaling it like this, and we need to also
Yes, so that one's
offset it ever so slightly, like probably way less than we're doing for the edges. We just need it to make sure that the ones that are at the edge are pulled in slightly, and the ones in the center are actually on center. Is that like these ones that are right at the end, they're actually poking out a little bit, so they need to just be pulled ever so slightly inside of it. So it's that, like, basically we need to offset the plus and the minus by also the offset. Like, I think if we just add the offset to the negative, so that we're not, because this is what I'm saying about not renormalizing them, is that if we then called normalize on these as vectors, that's what this would do, is it would make the -1 no longer -1, but I think we're still passing in -1. I think that's what's happening, which is kind of funny if this actually fixes it. Because I see what you're saying.
It might be worth forcefully renormalizing them just to make sure that that's not what's fucking us as well.
Yeah, so that's what adding this would be doing, is actually renormalizing them, is that the positive ones are pulled slightly more positive and the negative ones are pulled slightly more negative. And it definitely seems like it's not as, I don't know, maybe it is more line.
No, they're still shimmering.
Yeah, I know, but they're, like, when I stand in a certain spot and I can get it to shimmer, it's only shimmering 1 dot. Before it was shimmering 2 dots, which makes me think, like, some of the lines are really bad, but makes me think that this is the right thing, but maybe we should actually just call normalize. Like, maybe we should be calling normalize and not.
Yeah, let's try that.
But how do I do that though?
If they're the right type, there should normally be like a
yeah, I know, but that's the issue, is that it's actually an array of floats that I then need to turn into a vector, normalize, and then turn back into a. I think I can do this. I can say let n equal this dot map, and then we say v, and then vec.
So if you have a vec3, you can normalize.
Yeah, I know, but that's what I'm saying. I've got to turn them into vec3s.
Yeah,
from,
that's kind of annoying.
So vec3 from array. I think I can do it this way, which will do it at const time, because it'll like. So we do this to v, and then we say map, and we say v dot normalize all 0, and then we say dot map. Actually, I think I can combine those maps. I might be even better if I can combine all these maps, and we say to array, and then we just extend by n. I can probably actually wrap that and say, why are you saying that? We can reduce closure. We can say like map is vec3 from v dot normalize or 0 dot to array, and then we pass an n, and then that. I feel like I want to leave these as ones, if we can do that. My only concern with this is I feel like the ones closer to the center should. Oh no, it does cancel out to 0. Fine. I was gonna say I don't want the ones in the middle to be normalized, like to be offset at all, but it's like they shouldn't be, because at that point it's 0, 0, -1, which means that it's not being offset at all. It's still there, but it definitely feels less because it's only like occasionally, but now it's a camera angle thing as well. So this definitely reduced it, which maybe just means our offset needs to be bigger or smaller. Maybe we're offsetting with
So good
Z.
to know. It doesn't renormalize.
Oh wait, I'm also adding offset, and maybe that's what's fucking adding it back in. It'd be really funny if that's what was happening, because I was basically forcing the ones at 0 to not be right, because I was offsetting them by like the tiniest amount extra. Well, it's even better again.
That seems pretty good. Yeah. Okay.
Yeah, it's you can only just sort of see it right at the bottom there, which means that like it's only like
so
the
go
slightest.
Back to the math.
Interesting.
I think you changed up.
Wait, as I get closer to them, they get worse. What I'm wondering is if we change this times, is it times by a half? What if we, because this is probably the most likely place, is if we make this like times by 0.4, it makes the effect bigger?
So right now, like the thing is like, this is just to get like the correct,
Yeah,
like
this is
positive and negative, right? We need Yeah, so it needs to be.
No, so this is correct because that's the wrong. It's this one needs to be times like 2. So or divide times by 0.
Try rechanging that like plus chunk size as minus chunk size. Because then we're going to get positive and negative as we scale through. So the center is at 0. The first ones are negative. The first ones are positive. So it evens back out.
Okay, so that's making it worse. Okay. So you're saying we need to make this negative chunk size.
Yeah, so that way like the offset at like the first slice at 0 actually becomes minus. And then the one at the end is actually positive.
Yeah,
but then in the middle it's at 0.
But now we've done the opposite of that because we started with negative. So we were doing negative z minus. So we've done both. So this would now be, because we were doing negative z minus, or like whatever.
Exactly.
So I think was it times by 2 maybe? I times it by half and it got worse than that, so I'm going to times it by 2. What I'm wondering is if we just make the offset bigger, because now we're renormalizing, we can actually kind of make the offset quite big.
Yeah.
Because we don't have to worry about like the fact that as we push further and further in, our normalization becomes worse and worse. Okay, that's terrible. So maybe don't times that by 2. That or my number was very correct. Interesting.
Okay,
I'm not going crazy that negative positive would be positive, it was negative, and now we've not negative positive, and it should be no. Okay, something has changed between. Okay. Wait. So why the fuck why does negative?
Okay, so
positive?
Here.
Why does that make a difference? Why the fuck we're inverting an inversion?
That makes 0 sense to me, because like
order of operations means that we're.
Because like the 0, right? Like let's just think about like the 2 edges, right? Like the.
But that's a okay. That might be a compiler issue. So negative z plus this should be inverting this value, but for some reason, leaving this value positive and inverting this value, which means we should be subtract, doesn't work. So I don't know why we need to invert after the fact. Anyway, I'm going to times this by 2. And I want to see if this makes it better or worse.
Because like when 0 is 0, then we add half chunk size, so like 16. Then
we invert that. So now it's negative 16.
Then we get 16. Then we invert that negative 16 divided by chunk size, and we get negative half. Okay, which is vaguely correct. But then when you get to the end, why does that work?
That's what I'm saying. Why? No, it's not. Why does that work? Because why does that work make sense? It's why does inverting the order of operations not work?
Yeah, because like, we need to take.
It means that it must be doing the division before it's doing the inversion, or something. Because inverting the inversion and then subtracting instead of adding should just give us the same number, because we're inverting the order at which we're operating and then inverting the operating. Okay. Yeah. I'm going to turn the rest of the stuff on. Also, it's going to be really funny if I turn on the back faces and they're all really busted. But what's even more confusing is I've tried doubling and also halving this impact, and it doesn't seem like 1 times is basically the best I can get, because if I double it or if I halve it, it doesn't get any better. Well, actually, it gets worse. But that might also be that it might be that the closer we are, because like the closer I get to a chunk, the worse it becomes, which is actually probably kind of good, because it means if we can fix it, it's actually fixed. Whereas the other ones, when we've done it, the further away you get from the chunk, the worse it becomes. Yeah, it's still kind of getting kind of bad. Yeah, okay.
I'm seeing it more on my end.
Yeah, well, it's getting worse the further away I am from a chunk. But like when I'm too close to a chunk, it disappears. But if I go too far away, like when we're rendering the entire world, it's going to be really obvious in the far chunks, which means that this needs to somehow be like, I don't know how we're going to fix it though. That's the issue. So we need to copy that. We need to go to this and then like paste it there. Okay, and I also find it so bizarre that part of the way to fix it was to actually just fucking normalize it. I wonder if there's some kind of tweak we have to do because we're normalizing it now. It may be that we need to actually tweak the X and the Y differently. Because at the moment we're just tweaking them by the same amount.
I really hate that Bevy doesn't renormalize for you. That is like
Well,
such a flip.
it might if you did it properly. We are in fact sticking data directly into the mesh that then Bevy is sticking directly into the shader. Like it may very well be that Bevy's not doing this so that we are allowed to do.
We can definitely see the axes we haven't touched.
Yeah, but what's even more confusing is I did apply their tweak. Also, I like that these ones are in like a fucking diagonal. It means that it's not quite right.
Did you?
Yeah, no, I just copied whatever the buffer was. I just stuck the renormalization on the end of them instead of doing it outside of them. But it does mean that the offset calculation... Oh, that's what's wrong. For some reason, we have to fucking minus plus instead of plus minus, which is... What the fuck? Why does this make a difference?
Well, like it makes sense that it it makes a difference. But
not to me, because its order of operation says if I negate a number and then add a number to it, it's the same thing as if I don't negate the number and then subtract the number I added to it. Isn't it the same thing?
It's because like say like at index 0, it's like plus 16, and then you negate that, so you're at negative 16. But like with the negation, you're at
okay, yeah, I guess kind of does make sense.
Then at the top end, like at the 32nd index, then you end up with like 32 plus 16, so 48, and then you can negate.
So curiously,
that's why it doesn't make sense to me that this is.
There's something going on with just the that one, whatever that one is. I think that's that must be X. So Y seems to be working. In as much as like it's only a really tiny wireframe, and Z is working, and it's oh actually no, we've got this really big gap again. Look at this.
Yeah, like okay, but like okay, mathematically it has to be the index minus half chunk.
Yeah, we're one of these is backwards. Like one of these is going up. Actually, it's probably the Y. The Y is probably what's causing a lot of this, because when you can see really big ones like these, it implies that the Y is doing it. Oh, you know what? The Y might just need to be in a different orientation because the Y is different. I was copying the same thing, but it might just be that Y is different. Wait, no, it's not Y. Y is not doing it. It's X. X is doing it. Why is X different to Z? Because the axis is in the other order? Maybe. All right, let's turn off Z. So now what we've discovered is we kind of know what we're doing, but we just need to actually make sure that we tweak each axis to have its own custom correction amount, I guess, because it is the same thing.
It really shouldn't, but
well, it kind of makes sense in that like X and Z should be the same, except X and Z are actually in fact opposite to each other, and also Y kind of makes sense because Y is just a completely different axes, but Y and X should be the same but just rotated, whereas Z makes sense because Z's actually just one's positive, one's negative, so this piece here should probably be inverted the other way with Z. Like that makes sense in my head, or at least that like Z is special like that. Just add more triangles, that'll fix it. This is such a bizarre like thing to have going on. All right, so we're only rendering the front face, and for some reason the top, but like also not to the. Wait, what?
It's only in one direction.
It's only on one end of the chunk. It is getting smaller, which means that whatever code we're doing here isn't working properly because we're somehow ending up at the edge of the chunk and going across.
Okay, so logically, from first principles, right? It's supposed to be like X minus half chunk divided by chunk size. That gets you the normalized value from like the negative to the positive. Like that's the only logical one, because or else like the math gets really weird because it's different on both ends.
Well, okay, so what's confusing me, right, is that this end is clearly correct in that it's disappearing, and this end is clearly way too exaggerated, which implies that we are somehow at the, and I'm pretty sure this is the high end, this is a positive end. So as we get closer and closer to 16, we are getting closer and closer to disappearing the right amount. So at 0, but like we should be a big bulge in the middle or no bulge in the middle. So how the fuck is this math working out that it's, maybe it's because I'm
exactly, that's what I'm saying. It's the X plus that makes it not a bulge. It makes it just a like bigger value over time.
But that's what I'm saying is we are doing X. Oh, is it? No, because we're starting at negative X.
Minus. No, we're not.
Right. Yeah, I got you.
Outside. Yeah. So like it's supposed to be index minus half. That's the only way the math will work out as a bulge. So that's the part that doesn't fucking make sense.
I feel like maybe the compiler is doing something funky here and is confusing something.
Yeah, because now.
Yeah, I
right?
see what you're saying. It doesn't make sense that why we're not ranging through the middle. We're just inverting, which means that it's actually as we go to one side. But maybe that's an XZ thing. Maybe that's what I'm saying, because Z's negative, it actually fucking works for some reason, because we're inverting the negative value of the negative Z. But that doesn't really make any sense, because I don't actually know why they would be different. But like I see what you're saying about how this doesn't seem to have done anything. Oh no, don't tell me we've got this issue. Look, this one's almost done. Why did this one fucking work? I think I just worked out where we might have to note something. No, it doesn't make sense that this would make any difference, because it should be on a per chunk level, which means it should be local. But there's a chance that because Z isn't from -1 to 1, whereas X is from 0 to 1, means that it only works in chunks that are in a particular world space coordinate. That doesn't make any sense, like, mathematically. Like, why would it care? But like, that's the only thing I can think, is that like the negative, like why do half of these chunks work? What changes?
Yeah.
Also, why is it every alternating chunk that fucking works? What? Hey, look at this one. This one's right. This one's also...
What?
Look, they also get smaller as they get to this corner. Wait a second.
And it's also reaching back to the other side. So like, yeah, we can definitely...
Yeah.
What?
Oh, wait. This is the 16th. This is one chunk. That's what's confusing. I was going, why is it alternating?
Oh,
it's not
32 by
alternating.
32.
It's one chunk, but it's erroring at 16. So at 16... Wait a second. So our issue is... Right? I'm trying to get somewhere you can see it without my fucking... Oops, I closed it. The issue is that 2 of our 4 corners are wrong. Yeah? So this chunk is right in the middle. It's right at this end, right at that end. But these 2 corners are too high. That's why it looks like it's alternating, but it's actually not. It's out by 16. Wait a second. What if it's supposed to be...
So we have a positive and a negative of those 2 corners that are wrong. Okay.
Which is what this is supposed to be doing. So I'm just going to tweak this and say that we want to start at negative chunk size as 32 times by a half plus X.
I think it's just the positive and negative is wrong on 2 of those corners, is what that means. Not that the offset itself is wrong, because it's correct
something
for 2 of those corners. So I think we found the right offset amount. It's just...
I'm trying to rewrite the code in a way that makes sense. So what you're saying is these are wrong. That's what's going on.
2 of those corners. Because
that's what correct. So 2 of the corners would be that these 2 are in the right spot and these 2 are in the right spot, but these 2 are inverted, which means that they're actually too high or too low, because the triangle that it's drawing on are sharing in the same thing. Anyway, so we're going to go here and we're going to go, okay, so it's doing the same thing. I've rewritten the code in a way that makes sense in my head, but actually like is giving us the same result, which means that the 0 corner is too high on the Y. The 0 corner is too high on the Y. Which one's the 0 corner? This is the 0 corner. It's too high on the Y. And the plus corner is too low on the... It's too high... Wait, also too high on the Y? Minus 0 plus plus 0 0 plus plus. Is it what? What? It doesn't make any sense.
Let's try
Okay.
hiding.
Wait, no. Wait. I got it. Okay. So I just flipped the wrong. So it was fucking, but not you. Is it you?
Yeah, so in theory, the first and second should be the same.
Yeah, but then the other one should be 10101. Right, that makes sense. Which actually, if this works, kind of. Okay, so what the fuck? Well, now they're all
Wait.
too high.
Okay, wait.
So
Is
minus,
it-
minus. So
Is
this
it because we've...
So
Yeah,
you
so we're
shouldn't
doing the
have-
back face. It needs to be the reverse of whatever
but
we're doing.
we're not
on the
rendering the
front
back face. The back face is not rendering at all. I'm not touching the back face because I'm doing the same approach we did on the other one, where I'm only doing one face until I get it working, and then
Yeah.
I can look at the logic and try and mirror it. And at the moment, it's so much of a we just need to force it to do what we want it to do.
Yep.
I've matched the negatives with the positions, and I'm going to see if that works, because I think one of what might be happening is that the X and the Y might be wrong, so we're literally pushing off into the wrong. So negative, negative, positive, positive, which is the same as 0 0 plus plus. So I think I may have completely flipped it. Let's just make them disappear. I may have completely flipped it. So now the front ones are too high and the back ones are too low, are the right ones. These front ones are too high. So if the front ones are too high, well, maybe I've got the wrong corner, but like I'm pretty sure I've added that extra thing. Wait, maybe it's this way. Maybe that's why it's so hard to keep track of which one's the positive, is that it's actually... Okay. So if I make U negative, let's see what happens. Because it's really obvious, like it's Y. Y is wrong, so it's negative. So if I flip this one, does it make it better? Does it make it worse? We'll find out. The other
It
issue
feels so bad to just take pot shots at this until it works.
Wait, what?
But at this fucking point.
What the fuck?
Wait. What?
How does that work? I flipped it and it changed 2 corners. Wait a second, do we have to like rotate it? Oh no. What the actual fuck? What happens if I flip this one? What? Why does it rotate? It's got to be the interpolation. This is what I was talking about, how like, because we're tweaking 2 of the points, we're actually changing what the middle value is, and then other values are moving in. So we can't just move the Y until it's right. Now I've fucking flipped it 180. Okay, so we're doing like rotations. Right, this is that blender bit that I was talking about. We're doing this. This is what we're seeing, is we're seeing this like bulge in the middle. So I'm gonna like triangulate. Wait, why did it put it at vertex in the middle? Okay. So we're seeing this, right? Is it this V shape is what we're seeing, and then when we move this one up, we're seeing this V shape, or something like somehow we're seeing a different V.
Yeah. What in the crap?
And that's why when we move one without moving the other, we rotate. This is going to be really hard to track down.
At this point, we'll just keep trying. And,
Yeah, but we need to
like,
like...
it feels so bad to do this, but
The issue is I need to write down what I've tried, because I feel like we're just going in circles because I can't visualize how it's fucking rotating.
what is? Oh my god!
Oh, someone else has joined. Maybe they've got an idea.
Oh, hello.
Please, save us. Their microphone's muted. I don't know if they know that. Hello? Oh, no, they're gone.
Nope. They're gone. I guess they realized that
Yeah, maybe
streaming.
that, or they'll come back and they'll be like, oh, my microphone wasn't working.
Maybe.
Who knows? Okay, so I think this little green... Also, wait, did it just flip again? No. Wait, what? What?
Yes.
So something tells me, and I don't know how, is we have to somehow match this and this, but like apparently 0
Yeah.
0 So if 0 is a negative, then we are matching that right now. But it's not working. But it is front back not working. Like it's actually like smooth not working. That we're just too high at one point. Oh, they're back again. Hello, friend. Are you aware that your microphone is muted? Oh.
Like
Also,
so because
yeah.
now they're doing front to back shit, I think this is where the thing I was saying of like that's what we need 2 different offsets for some of these.
The other one was doing this too.
So
Like,
that
the other one,
we recurve along front and back.
but the other one did exactly the same thing where it was doing like those diagonals, and I tweaked one of the values and it just worked. Right? Like what's confusing me is why, because I'm looking at it going, oh yeah, it's this corner and this corner is too high. But if I move either of those corners up, it rotates. It doesn't just.
Yeah.
So what we're missing is that something isn't right with the normals. Maybe like maybe this will make it really obvious if I just fucking go like, hey, what the fuck's going on with the normals of this triangle? Look. So what's happening is we want blue, green. So this is black. The black is wrong and the blue is wrong. We need more green. We need to somehow get the green into grids because at the moment I think the green is correct. Right, yeah, the green is correct. So we somehow need to get that green color back. Green is Y, so we need more Y in these front 2, somehow.
Yeah.
But how do we get more green in this?
Well, like specifically that blue corner.
Well, I think what's happening with that blue corner, what's happening with that blue corner is if we turn the colors back on, you actually see that like a pixel is leaking through left to right as well. So you have this single, I think that's why that corner is super blue. It's because that one pixel's leaking through. So for one, we need to fix that. But how do we fix that is we need to step that in the... We need to go literally 1 pixel. Are we going the wrong way, maybe?
Possible.
Well, like I feel like we're expanding out, and that's why we're having this weird flipping behavior. We're actually pushing outward. Maybe this is backwards. Wait a second.
My offset is chunk size as plus what? I can't read it in 480p.
Chunk size. What are we doing? Offset. Offset is negative chunk size times a half plus x divided by chunk size. It'd be really funny if this works because I just thought about it and went, wait a second. What if it's because x is actually z is actually negative in Bevy?
Is it just because your negative is outside where you think it is? Because you said negative chunk size, but
wait. Look.
Minus is at the outside.
Look. I fixed that 1 pixel being leaked through because I flipped the x. I flipped all the z, but I didn't flip the x and the z. I just flipped all the z. So I've now I'm just too high on the which is probably gonna. Okay, so we need to get the green into these 2 faces somehow. Right. So somehow I need to lower 2 of the faces, and I'm pretty sure they are the negative, like 2 faces. They're 2 adjacent faces. I'm pretty sure. I guess they have
I just want to make sure because you said negative chunk size for the offset calculator.
Yeah, so
here,
half,
your
negative
minus
half.
is on the outside of all of that.
No, I wrapped the chunk size as F32, so I cast it to an F32 and then negated it.
Yep.
And then I multiplied by half, and then I added the x, and then I divided by chunk size outside of the parentheses.
But where's your negative is what I'm not seeing right now.
The negative is here. Please. Negative.
Oh, wow. Okay. It is literally black pixels for me.
Oh, okay.
Because in 480p. That's why I was confused. Okay. That makes sense.
I think you can go to the actual stream, and the stream should still be higher resolution. Yeah, the stream's higher resolution. Discord's less desync, but the stream is higher resolution. So it's between the 2 of them. Okay. So what I think we need to do is two of them are too high. So is it that it's minus? It'd be really funny if it is minus, but I don't think so. But I got rid of that 1 pixel. that was leaking through, and that one pixel leaking through is really important because it could be why the whole thing's fucking spinning like it is that one pixel means we start wrapping a whole corner around.
Pixel back.
What the? Yeah, but it's back and it's flipped. Look, and there's a pixel on the other side. Why the fuck's the other side? We're too big now. This side here is expanding and grabbing a pixel from this side, and this side's... We're making it bigger.
What is this? Okay.
We're going the wrong way. We're going the wrong way. We're going the wrong way. Wait a sec, why are they all the same? If this works, it's really annoying. Okay. Well, that pixel's just non-exist. Wait a second.
Well, that fixed the pixel somehow.
Yeah, I know. So we're not expanding now. Well, actually, I don't. Did it fix them? Or is it just looking at the wrong chunk?
Oh, just the other one. Okay. Darn it.
But what's curious about that is that implies that, like, because it didn't just immediately do it. Do I flip those? Because that's what I did last time to fix that pixel, and then I added 2 more negatives, which then flipped what side that was. What are we doing? Oh wait, are we being? Is that? Maybe that's what we're doing wrong. Is we're fucking with both sets of. Okay, which way do the planes run? Right. So I forgot we have a second set of planes here that's causing an issue as well. So what it could be is that we're actually like doing, we're like literally fighting ourselves in that. Wait.
I don't know why, but I want to try all negative.
Wait. I already did all negative and all positive. What did we have before?
Okay.
Because there was something about that. So X has F32. Wait, X is already in F32, so I don't know. X. Plus. Wait, are we? Just make sure that we're not actually fucking modifying X anyway. Okay, good. Like, we're really dumb if that's why the 2 didn't work, is because we modified X, but in one we didn't modify X in the other. Okay, so plus chunk size.
Minus chunk size.
Okay, I'm doing this in version 1 here because I think what's actually might be happening is that we've flipped our orientation, and therefore we're actually tweaking the wrong value. Because you'll notice it's actually it's leaking through in 2 places. We keep looking at the top, right, which is now fixed, by the way. I don't ask me how.
My problem is, like,
don't ask me how, but that
mathematically,
fixed the top, by the way. Doing that.
What? For fuck's sake.
But
Like
it made the left right
is...
really fucking bad. But I think what our issue is that we keep forgetting that we're actually looking at planes this way, and we're trying to tweak the top. So it's actually that the left edge is too far out of the negative. So the left edge, which is the X... What? Fuck? What? Okay, the left edge. Okay, so the edge. So the zero edge. This edge. This edge is extending too far in this direction. So these need to be positive, because this edge is extending too far in this direction. We're subtracting on the 0 side, which is pushing us into the cube, out of the cube. That should fix it. I have no idea why the fucking X minus X thing works, but there's also something still wrong. But did that make it worse or better, or like
It's
the
really
top
not
still?
supposed to work. That's what's getting to me.
It's not supposed to work, but that's
Like, mathematically makes 0 sense right now, you know?
yeah. And it isn't telling me it makes 0 fucking sense.
Because, like, I swear to God, it's supposed to be minus half, and then you divide that by the full thing, and then you get a range from minus half to plus half.
Yep, that's how it's supposed to be. Maybe the Z's also broken, and we didn't realize that the Z's broken on 2 axes as well, and the other axis is still broken on the Z, and we're just doing something completely wrong.
It 100% was. Like, okay. But...
Okay, so just out of curiosity, looking at this though, like mentally, looking at this is the face. So if we go to our shader and fucking Yeah. So what we need to do is say, wait, someone said the bottom looks okay. No, this goes all the way to the bottom. Is if I turn it to mode so we can actually just see the square that's broken. What we need to do is say that this blue side, whatever side this is, needs to not stick out so much. This is getting a negative number when it shouldn't be, or it's getting a positive number when it shouldn't be. And it's not the Y that's wrong. So if we look at the chunk generation, it's not it's two numbers have to be the same in the same axes, and it's not the Y axis. Oh, never mind. Okay, so this is the X axis.
The problem is the Y.
So no, it's this one and this one.
Wait.
I changed the wrong ones. So it's not you. It's you. Wait, you and you, and then you and you. So is that gonna work? I don't. Oh, God, this is so fucking. Wait, why am I? Wait, no, I'm fucking with the wrong one. Oh God, please don't tell me I broke it again. I'm fucking with the wrong one. I need to turn the shader back on. I need to make sure I didn't break it so I can like Control Z before I keep changing the Y. And okay, I broke it again.
Okay, wait. So go back to what fixed the top.
Well, my concern is not knowing what fixed the top. I think it was all negatives fixed the top. No, all negatives apparently did not fix the top. That or my computer's running a bit slow.
I don't think that was all negatives.
Yeah, that was all negative. Should have been. Yeah, that was all negatives.
Oh, okay.
Maybe this. Oops. Oh, now it's not even. What the fuck? Annoyingly, we don't have the working one anymore, and I didn't make a git commit when it fucking worked. Okay. So the top six. Okay. So what the issue is, as I keep tweaking the fucking X, so it's that the sides that have 0x are wrong because they are subtracting too far and going into the wrong X, which is this side and this side.
No, okay. They're not going to get to the X because this is the X plane.
Yeah, but that's insane. So they're being offset.
So it's Y that's being. Wait. No, Z.
No, Z. I'm saying it's they're extending out to the side, and I'm subtracting this side thing, and oh my god,
Wait, what?
it's still got a fucking hole in it, but oh my god. Okay, so that means which two did I just change? Which two did I change? That one. So you and you need to be minus because then they will, because that's the idea is that they're symmetrical. So if they're sticking out, they have to stick in, and also definitely one of the Y's is still wrong. So the zeros need to be positive and the max sizes need to be negative. Maybe I'm just the idiot, like I kept moving the wrong one. So I think the Y is still broken. Yeah, but Y is still broken. Y is still broken because there shouldn't be 3 of these. Y is just broken in the other plane. It's just like we can't see it because Y is fixed at the top, but it's broken at the bottom. So which of these is the one that needs to be flipped? So negative Y, 0.
First one, 0.
So it should be either 0, 0, like no, it should be either the plus, plus, minus, minus, or it should be minus, minus, plus, plus. So if we do this and it breaks, then that means it's the other one. This is so fucking dodgy. We don't know what's going on. I think that half the problem is they keep tweaking the wrong value. Like I keep modifying the Y, trying to fix it in the X plane, like in the X direction. Okay, it didn't break it again. It looks dodgy, but that's because it's missing something. But like it didn't break it, and that implies that it must be fixed.
I mean, it looks very pretty.
It does look very pretty, and it's going to look so much more pretty when we can turn on the entire map without all those lines appearing. All right, so then we're going to go that apparently the patterning. Interestingly,
for the record, I am calling it now that this project is now communist, and this is our project now.
Okay, you've communized the project. Well, it's open source anyway, so fucking you can steal a project.
Sure, there we go. Exactly. I have communized.
No, it's not communized. It's socialism is what this is. It was socialized.
Yeah, that's fair.
Because like, technically, communism is actually the right term for it because it's a communal, like it's communal, like that's what. But like everyone thinks communism's bad, so it's socialist because at least socialism
Yeah,
can like
fair.
somewhat survive. Communism is you'll have I forgot what the US president was that joke's from, but it's funny. Trust me, the joke would have been funny.
Yes, I know that. I don't remember the joke, but I know the joke. So
It's a
I know I should
salmonella
laugh at the
joke where
joke.
it's he's going like, oh, we need this thing, and he goes, oh no, we don't. I hear they're communist. Communist, and then he fucking rees out the fucking White House and then like starts fucking fighting on the front line, and it's like, oh yeah, I think it's out. I need to look up the US presidents because I'm not going to forget this joke now. List of US presidents, because it's like I don't remember his name. It's Ford. Jimmy Carter maybe was the one that was like, if you said communist, one of them. It's not Kennedy.
That makes sense.
It might be this guy.
Eisenhower.
Eisenhower. I think Eisenhower tells me that it's probably Eisenhower. I don't know if they're from there either, but it was a really funny joke from Salmonella where he's like communist, and he's communist, and he's fucking out the way. You go to YouTube and we go
Like, it is
Salmonella.
still very hilarious that like an Australian is making a joke towards a Canadian about a fucking US president.
Yeah, have you seen the president at the moment? It's nothing but a joke.
Yeah.
It's a scary joke because, like, I remember when he got in and he started revoking all those like climate things, and my dad was like, "Yeah, but what's it matter? Like, the rest of the world, it doesn't affect it." And I'm like, "Yeah, but it will, because it emboldened the rest of the world to do the same thing because Trump did it and got away with it." We're gonna go.
I mean, right off the bat, they were the only country to not actually meet their Paris Accords, and then
instead of
okay, let's just leave then.
Instead of like admitting that they didn't meet their accords, they just left the treaty.
Yep.
I want to say maybe U.S. presidents.
Okay, we need to figure this out. So this thing, okay, right now it's working.
Oh, no,
so now we need to check the back face.
I would check the backface. Backface works. I can't tell you why, but it works. I did the backface while you weren't looking. Now, confusingly, the Y is going to be the one that I'm like, I think mentally I've worked it out. I think mentally I've mapped it out enough that I can actually mathematically guess what the Y is going to be. And it boils down to, I'm a fucking idiot when I wrote these offsets. So what we need to do is we need to say that when the Y is 0, we add. And when the Y is at maximum, we subtract. So it's add, subtract, add. And then the other one is add, subtract. So the Y should have never been broken, but okay, so that's scary because the Y should have never been broken. The Y is correct. But maybe it wasn't ever broken.
Pretty correct in one axis, so maybe.
Okay. Well, the answer is that the fucking Y was just always right, so.
Yep.
Okay.
But like we're always seeing it plain wise, so that makes sense actually. That
the Y, like it's doing it really bad. Like when I'm standing inside, like when the camera is inside of one of the planes, I think the shader is actually what's bugging out. When the camera is actually like, if I could ever get my camera to perfectly align with the plane, you can see it because we are inside the plane. But that seems like you can never fix that bug outside of maybe just not rendering the plane that the player is standing inside of. Like if because it's not even like if I'm in, if the camera's touching a plane, it's if the camera is looking directly along a plane.
Yeah.
The fuck, Google? I was watching Salmonella videos on my other monitor to try and work out if it's the right one.
Salmonella video?
It's a YouTuber that made like stick figure drawing animations. That like
Okay, that makes a lot more sense than like videos about, I don't know, watching salmonella try in a petri dish or something.
no, it'd be people vomiting everywhere because they
Right?
Salmonella. Maybe like, we can just try the US presidents because I'm assuming there's a short somewhere. But it's just a really funny thing of being like, I hear they're communists. It's just so good. I typed in US presidents and it said Donald Trump.
It's so annoying though that it's still gonna have that problem, but
I feel like maybe that's like one of those, we can fix that with we just need to work out where exactly we need to round it.
Oh, Eisenhower. Yeah, what's up? This Jacobo guy, he's making us pay minimum wages. Well, that doesn't sound very good for business.
I'm
That's
not
not all,
getting
though.
this
He's
sound.
also taking our unused
I'm doing
land
it on
and giving it
stream,
back
so
to the
they should
people.
be getting this.
Does that sound familiar? Oh dear. You don't
Yeah,
think. By the way it's looking, Dwight, I'd say he's a dirty... Oh god. Collectivizing? No. Commie. Commie!
Flip 'em.
Commie!
Yeah.
Yeah, go get him, Dwight.
Alright, that was loud, but that's the joke. Don't call it communist or they'll send him after you. She's pretty good because he's like, that doesn't sound very good for business. And he goes, yeah, they're communists. Communists! Take them out. Take out the commies. And then we go.
Absolutely beautiful.
Lovely. Oh, it's so good. Well, actually, no,
Hooray
that's
for
not very
a
good.
minute behind.
That's not
So
very good.
it gave me time to flip over. Wait, what? But it was so beautiful 2 seconds ago.
Well, it is. It's just that something's not quite.
Okay, so that means like the offsets are way too big.
Or I think that possibly the issue comes from being in like inside a negative chunk. Maybe that's why it works on every plane, but not on planes. Is that because the other thing is like it doesn't look like it exists. Like as long as there's the rest of the block behind it, it's only a problem. Like when you can see the void, when there's a block behind it, like when it's actually rendering the correct block. It's that this plane is being skipped. This plane's being skipped, but then when it gets to the plane behind it, that plane behind it steps back and actually draws the correct block, so you can't see through blocks because the correct plane is behind. Oh no, this one's fucking wrong. Very wrong. There's a hole in that one. But you're right, yeah, the offsets are way too much. But that's scary because if the offset's way too much, but like. Oh, also, it's worse at the edge of chunks. I just realized that. Yeah, that's...
Yeah, so we need to like reduce how much offset is being applied. Yeah.
Fuck, it's gonna do that
That'll
thing
only
where...
do it for
Yeah,
like,
I just realized that. We probably should make this a constant then. Const correction. Let's go. Also, you communizing the project is kind of like half the reason for doing it on stream is that it means that like sometimes someone else will be like, hey, I can fix that. Whereas like when it's my project, it's like, fuck, I have to fix that. And then like I don't do the project because I'm like, I really don't want to fix that.
yeah. How long were you fucked around yesterday?
Oh my god, yeah. Like also someone's like, oh yeah, debug the thing, and I'm like, oh, that seems really hard. And it's like, but if you help, that's fine. And they're like, oh yeah, no, I'll talk you through how to install it. And outside of the fact that it took down the stream without me noticing because it crashed OBS without crashing OBS, like it just crashed OBS's ability to record video, so I had to reboot OBS, and I didn't notice for like 20 minutes that I was talking to myself.
Oops.
Yeah, because it's like I went, oh, I wonder what's going on, and I clicked on OBS, and it's just like, oh yeah, we had an error accessing the graphics card. I'm gonna stop streaming on Discord because of the I think it's killing this actual stream's bitrate, so yeah.
Sure.
And we don't need you to be perfectly
that tells you
sympathetic.
you're a true professional streamer.
Yeah,
You don't
it's-
watch chat enough.
Well, no, someone said chat said stream lag, but nobody said the stream stopped entirely. I just like I wasn't watching
Oh, hey,
the stream.
there's someone in chat speaking of.
Oh, is it? I don't know. Actually, I haven't had chat open for ages.
Is the bottom looking okay? Are they the face normals for you?
It's a little bit fucked, but
Team communists. Yeah, so the normals are having a weird issue that
we
they
are
were
okay. Here's an interesting
rounding
one.
off
Here's
at
an,
zero.
here's an interesting one. We are stepping way too far in one axis, but not nearly as far in another axis. So why the hell is one of the planes like? Look how much one plane is stepping versus the other plane. Like just here. Like we go way further with this one than we do with this one. But why? I also have no idea how far the fucking streamline is. Like, did I miss one? Is that what happened? Like, we did Y, we did X, we did Z. So why the fuck is one bigger than the rest? Why? Oh, I know what it'll be. Yeah, that'll be what it'll be. We probably don't actually need to be offsetting by more and more as we get closer to the center of the cube, maybe? That's what's happening, is we're at a different place. Like, as we get closer to the center of the cube, we offset one less than the other. So, I guess the trick is if we just, like, tweak correction scale to being, let's say like 10 times smaller. Also, like, because we're making it smaller, multiplying it up makes it smaller. I feel like we're getting into the territory of... We're getting the territory of needing to take into consideration that floating point numbers work in powers of 2, and therefore we should probably not be doing 10, but instead, like, a power of 2. Like, we should be doing 16. Because that's more likely to result in the floating point numbers staying friendly.
That's actually a really good point.
It's the same as theoretically, if the floating point numbers are having an issue because our chunks are too large, we can just make the chunk smaller and zoom the camera closer, because that will keep us more likely to be within 0 to 1. I'm also very confused about why looking at it from one direction is different to the other direction. Wait a second. Oh no. I'm going to be doing this to me again. That's even more confusing, actually. I have the impression that it might be one of those, the back faces aren't quite lined up correctly kind of things. Because, like, one angle, it looks like shit, but every other angle I look at it, it's like, oh, it's perfect. Except that one angle.
What the hell is left to tweak?
I'm also wondering if maybe we just don't tweak by a different amount. Like, it might just be that we actually set these out, the offset right, and if we just have the right offset, it's fine. Like, maybe it doesn't.
Yeah. What if you make offset just a flat 1 over correction scale again? Oh, that's gonna be a lot.
Well, it looks real good from here. Just notice that I'm looking at it going, yeah, it looks right, except every voxel is offset down like a third of a block.
Yeah.
It's offset
right now,
by
like,
a third of a block. That's great.
Because right now, like, the normals at the edges are like 16 by 1.
Yeah, but we normalize
they're,
them,
like,
so it's
practically sideways.
Fine,
Yes,
fine.
but like, so like, fine, they're normalized to like 0.8 and like 0.12 or something.
actually, good point. I forgot that we're still doing that. I was just removing the entire correction factor. Also, I only did it on one axis. I should make the correction factor 0. My curiosity is what happens if we I'm trying. Because the offset's specific to each layer. I wanted to just make the offset, because correcting by a different amount might be what's causing it. So I want to know, like, if I just make the offset, like, I could set offset equals offset.
I mean, that is going to return to what we had before.
But we've modified the order in which we're offsetting things, so there's a chance that we were offsetting something in the wrong axis that was causing it.
That's fair. We did check all of our work.
I forgot what I called. Apparently I got rid of the other one. I'm just going to call you compensation scaling because I'm lazy and don't want to make another constant.
I had never realized just how much back and forth there is in watching numbers for live streams. Like, when I jumped on the call earlier, I was the only person there. And now we are 7 of us.
Yeah, there's 7. Well, so I don't think you were the only person in that. Like, according to my analytics, outside of when an ad plays, there is at least 2. There's been at least 2 people the entire time.
Oh, then YouTube was lying to me. 'Cause it said there was only one person.
YouTube does do that. I like it. I was talking to someone once, like when I was live streaming. It's like my most successful stream ever, I think, because I had like a whole like 12 people watching me. And I was talking about how I can tell how many of them have premium, because if I run an ad, then YouTube will suddenly drop my concurrent user views down to just the people that had premium and therefore didn't get an ad.
Premium or ad block.
Yeah, well, or ad block, because I was talking to someone that was this is I think during the adpocalypse thing, but I was going like, I can tell how many of you have ad block on, because like I can. Whoops. Probably should set that value to something good, but like, yeah, because it tells me, like, because I used to like when I go to start a stream, it's like, oh yeah, there's so many people waiting to watch, and then whenever I started a stream, they all disappeared, and I went, oh, like it said there was like 10 people waiting, and it's like, oh right, because they got an ad, which means they're not watching nor are they waiting. As soon as they started the stream, they got an ad.
Like it should count as your view count, but all right. Sure, YouTube, sure.
Well, because I think it's one of those. You probably also find that it's actually technically the people that would have got an ad but had ad blocker are the people that are disappearing, because there was that adpocalypse that happened where all the YouTubers were going, oh, but we're getting like a third less views, but like we're not getting any less revenue, because it just wasn't counting ad blocked views.
Yeah.
So it could have been that, is that like if the ad blocker blocked the ad, then YouTube didn't count you as a viewer anymore, but did because it didn't get your viewer.
Yeah, that makes sense, but also
it doesn't really make sense, because it feels like that would have to be intentional, and why would YouTube? But I'm going like, that could be something as like some kind of weird math thing where it's like it expected you to be subtracted because you stopped watching, but added back because you started watching an ad, but you never got added back because the ad blocker blocked the ad.
Well, like from their point of view, like what we were talking about earlier, of like, as a corporation, they want to maximize their profit and they don't care about the end user, really. So like for them being like, oh, but we only have X amount of like viewers because the rest are all
they know how many viewers that are actually watching the ads. That's why they represent ads, and like they actually count them separately. Like I can get a rough idea of how many of my viewers have ad blocker by how much ad revenue I make from 1,000 views, because YouTube goes, hey, this is how much we're going to pay you, because it's actually how many ads got watched. And YouTube does it that way instead of just going viewers to ads exactly, is because like it does auctioning, which means that if you're a shit person that never buys anything from ads, it just stops showing you ads.
Yeah, like did you see the recent controversy, like in the past couple of weeks, of the YouTuber that was buying ads and playing a full video as an ad?
I did see some of those kinds of things.
Yeah, so then his views would skyrocket because he was, and then he had an ad placement in it based on the amount of views.
Oh, okay, that is a bit shady. I watched the Spiffing Brit do it, where he took his most profitable per 1,000 views video and then started putting that as advertising. So technically YouTube was paying him to advertise himself, but like he's saying that didn't last very long, because very quickly did that video drop below the return rate of the ad value.
Yeah, like that's the thing. So he was doing it like as a
spiffing Brit joke thing
of like haha. But this other guy, he's in the board game genre, and like because board game players are very, very, very willing to part with their money. The placed ad was like, looked like it was making sense to do that, but at the same time, no. Like nobody can figure out how.
Yeah, it's because it was also outside of YouTube. Like a lot of it was he probably had you had to hit a certain number of views, and because apparently like when it gets like Mr. Beast level, they actually want to like look at and go like, yep, you actually are in fact doing like getting the views that you claim you're getting. But like there was a whole bunch of things that it was like where it's like they look at like not just the number of views on the video, but also like the watch time retention, and they're going like, hey, everyone's skipping the ad, so we're just gonna not pay you. And then I think that's why Mr. Beast does that thing where his ad like slider thing that tells you how long's left in the ad is actually lying to you. It's not moving at a constant speed. because it means if you try and skip ahead, you still land inside the ad, which means that YouTube still has a big spike in the viewer retention during the ad, so that they don't have to be like, well, everyone skipped the ad, even though we gave you the ability to skip like to exactly the end of the ad. It's also, I think, why YouTube has given that like premium option that you can double tap and then it's like, oh, everyone skips here, so just click this button to skip to the end of where everyone else skips to. I'm pretty sure that's YouTube basically saying to the advertisers, like, advertise through us, because at least then we won't let them skip your ads. So
I didn't actually know that was a feature that...
Because you're going to have premium to have it. They don't tell you about any of the features that premium has, like the fact that you can make a queue in premium, and it's only occasionally that when the queue closes, it goes, hey, yeah, this was a premium queue. And I went, what do you fucking mean a premium queue? Premium can also...
The only feature I heard about was YouTube Red, when that was a thing.
Oh, yeah, it was technically still a thing. There's a bunch of YouTube originals that only premium users can watch.
Wait, it's still around?
Well, I don't know if it's still run. First off, it's called Red, and then they're called Originals for YouTube TV now. But like whether they're making new ones, I don't know. But there are in fact videos on YouTube that you need to be a premium member to watch.
Oh, I thought they had walked that back. Is it like that's how bad their marketing is?
No, they walked back the fact that channels can also have videos that you have to be a member of the channel to watch, so to pay the channel to watch it. And YouTube started aggressively pushing those videos to people that were not even subscribed to the channel. And they walked that back, where it was like, they were basically saying, hey, here's a channel that you've never watched before. Pay them money to watch this video. And everyone went, what? And a bunch of YouTubers went, oh, we didn't realize YouTube was doing that. We thought it only like did it on like you have to actually go and look at our channel to see them. We didn't realize it was fucking showing them to people and being like, haha, you can't watch this video. So a lot of channels stopped doing those videos. I feel like we're going the wrong way with this cube, and it's very confusing. Right. The conclusion was I should have committed this because I've made it worse.
Oh god, not again.
Nah, I know what I did because I commented out the line that was working, so I can just uncomment that line back out. But it's like I'm trying to tweak the value to try and work out like how to make it. We definitely need it to bow like we're doing. We can't just not do that. But I am wondering if maybe we can get away with only doing it on like the outermost one or something, like, and that we can just do a much smaller amount. Because like it definitely appears to need that, like, as we get further and further to the edges, we need to do it more and more, but we don't want to do it everywhere because otherwise it's really obvious that we're doing it.
It might be worth trying squaring that, like, precise thing, like the offset.
Okay, yeah. So
just to try to like make the curve just a little bit tighter as we go around.
Yeah, I get what you're saying. Is if we take the offset, which should be a value like that's fairly small, and then we square the offset, so like let offset.
Yeah, because right now, like the smallest value is going to be minus 0.5, and the biggest is going to be 0.5. So then, like, we're just crunching that down.
Well, yeah, it's also that's kind of like what I'm thinking is that technically that's going to mean that we crush the center ones less because they were already smaller, and therefore we're making them even, like, we're making them like crushed less. Whereas the outside ones, like, we're crushing like 0.5, now we're 0.25, which means that we can like scale it up and we can divide by less to keep them high, but like it drops off faster, I guess. Is the way of... This feels like something where we're fixing it with the normals, but really I think we have to, like, at some point write a vertex shader to fix this, because this feels like something that can be really easily fixed in the vertex shader when we're already outside of the math. The issue is that now we're trying to play with floating point numbers that are touching floating point numbers, and that, ooh, well, that was really bad. Okay. Is that because I squared it, or is that because I didn't put the fucking things back in the right place? If we can get it fixed, we should really commit this, because keep breaking it. Okay, was it squaring it that was the issue? I think squaring it may have been the issue. The other option is that I fucked up the correction factor.
Might have been a bit much.
Well, the correction factor is back just to the trunk size, but okay. So squaring it seems to be the problem. Which, wait, doesn't that mean that if squaring it's the problem, it either means the correct, okay, let's just say offset equals 0. Wait a second. What the?
Because you're doing the plus again.
I'm doing the plus again.
In that, like a Z plus chunk size right there.
Yeah, but like, so it works without it. But like, if I set it to 0, it's really thin lines. So why would squaring 0, right? That implies that the offset that we're giving is greater than 1.
Yeah, because of what I was saying earlier, that like mathematically it needs to be index minus half chunk size, not plus. Because else it doesn't do what we think it should.
Yeah, but we don't understand why when we do that it doesn't work. So
yeah, but like that's the thing that doesn't make any.
okay, so you're saying it needs to be negative Z plus half of the chunk size, and now it's telling me I'm not allowed to do that because I can't make.
So it needs to be like Z minus half.
Negative?
Yeah.
No. Z.
Oh, yeah, same thing.
Z as F32. So then it's negative Z plus chunk size estimate divided by scaling factor. It's telling me that apparently negative Z is not a real number. I need to restart my VS Code. It's getting so slow again. I need to work out what the fuck is causing that, because I think it's got to do something with the AI. It must have, like, because there's like a .md file or something. It's fucking doing something. Imgu.inu? The fuck?
But that's why your friendly little pop-up is still there, reminding you to close it.
Yeah, exactly. It's not because I completely forgot to fucking restart my computer before the stream.
Of course not.
See, but when I...
But like mathematically, it's the only way that makes sense.
Okay, wait. What if we go back? What if we go back and we fix the offset orientation with the corrected offset? Because like before, we kept just like sort of poking around in the dark, and we just happened to be like, hey, if we flip this around, it works.
Yeah.
So what if we go back to like fucking do this one at a time? This is so slow, so fucking stupid and so slow. And okay, but in theory, I should be able to work this out because I can look at it and be like, okay, now I know how to tweak it. So we have that the negative Z plus the chunk size times plus half the chunk size. I also feel like maybe I should correct the shape of this so that it's a little bit easier to read. But anyway, divided by the correction function, which is just the chunk size for right now, just so that we can scale it down. And then we kind of want to square it, but we can do that later. Now maybe I should just get it to print out what these fucking numbers are. Because it'd be really funny if we printed it out and it was just like doing something completely different to what we thought.
You know what? Yeah, that might be a good idea. Just
I'm going to get
doing
it
once.
So, you know, like print
Check.
offset.
Like every time we restart down this path, we're just checking one little step more cleanly.
Yeah, no, but doing a random print line is not really what I'd call clean. It's just like, it's confusing. So it is giving us numbers that are, in fact, wait, what? Oh yeah, because we're dividing by chunk size. They are between 0 and 1, but they are very big numbers. Like they're like 0.4, which is very big of a number.
Like it should go from 0.5 to 0 back to 0.5.
The answer is that it goes from 0.5 to like 0.3 and back up to 0.5. The smallest I've seen is 0.2, 0.2, Why is it doing so many also? It should only do this once. What?
Because you're doing multiple chunks, so it's calling it.
Yeah, but it shouldn't. No. It generates the chunk once. There's one mesh in the entire world.
Oh fuck, that's true.
If it's doing it more than once, it means that it's doing something wrong.
There should be 32, because we're doing a chunk size of 32.
Oh yeah, okay. It feels like there's a lot more than 32, but maybe you're right. Maybe there's only there's definitely more than 32. You know what that tells me is that this is just wrong. Something's going terribly wrong somewhere, and we're just doing something very wrong. Oh, no,
Okay,
wait,
so,
there's more than 32. No, wait, what? No, yeah, you should
print
go
out
from
the index when you print it out. we'll know for sure. And yeah, it should be Z minus.
What the fuck? Oh, no, we're printing out something else, apparently. We're printing out V somewhere. That's why we're printing a whole bunch of other stuff, is it's printing V somewhere. Oh, we did in the fucking noise generation. I'm printing out the fucking... that chunk's worth of noise. This is where this started, if you remember. I was doing fucking...
Right, we're doing terrains.
We're doing terrain, and then, like, I was trying to work out why the terrain wasn't rendering properly, and then we got distracted trying to work out why everything else wasn't rendering. Okay, so it says...
You started talking about noise, about
yeah,
light.
we got very distracted talking about light with that. Yes, that is true. All right.
It was super interesting, but...
So 10, 11, 12, 13, 14, 15, 16, 17, 19. Okay, so apparently this is happening asynchronously because we're printing out the fucking numbers in a weird, like fucking, we're printing 18, then we print 19, we print 32, we print 0, 1, 2, 3, 4, 5, 6, 8, 7, 8, no, so it's going in order, 9, 10, and then we go to 26, 27, 28, 29, 31, 32, and then it does it again, but it only goes up to 19 this time, and then it continues on, and it goes to... So okay, there must be something's there's two things are generating chunks is what's happening. So there's two chunks being generated somewhere in the world, and they're both being generated asynchronously, so they're cutting each other off. Oh yeah, the LED also caused this chunk, doesn't it? Yeah, okay.
Okay, so that makes sense. That makes sense.
Okay. Technically, this code should be modified to take in LED. But anyway, is it
0.5 goes up to...
So it goes from 0.5 and then it goes down to 0 at 16, and then that's interesting. Why is it only 16? Shouldn't there be 2 because it's even? There's 32 chunks, which means 16 and 17 should both be 0, or like 15 and 16 should be 0. Yeah, 15 and 16 should be 0.
Yeah, so because the center will be at 16.5. I guess is
which could be causing some of our that might be what that final flicker is that we're actually like the middle one's wrong. Maybe I don't know, because it's the middle voxel. All right. Anyway, we're just gonna ignore that now. So we know that it's outputting from 0 to from 0.5 to 0. Okay, it is actually doing that. This is actually putting out the number we think it's doing.
Yeah, so positive all the way to negative.
Though, admittedly, 0.5 is way too big. Isn't it like 0.1 is what we actually want it to output? Like, well, we got to use it? 0.5.
Well, yeah, like this is just to get it into like a normalized format, right? So then after that, that's why like the correction scale was a thing.
Yeah.
So like that's why when you were like multiplying by, I think it was like 10 or whatever, then it got down to like 0.05. So then that made sense.
Okay, so this is our ridiculous like offset, which is saying that it's like the back half of a chunk is not working, I think. Well, no, it's the front half. The front half of the chunk is too high. Right. So that, well, actually, technically it's both sides. Look, see, like how these ones are here. So it's saying that we have that the x is too high. We're adding the y is too much. So the y on the top. So the ones where it's set positive, which is the y where the y is set to 1. So it's these two. So this 2 needs to be minus offset plus offset. Wait, no, that's the wrong one. Their y needs to be even. Okay. I'm quite confused because they're already subtracting. We're already subtracting their offset.
Yeah.
Maybe we're subtracting way too much and we're actually rolling around into the next cell, and that's what's going wrong. Okay. So if I just set these to all to 0, and we just rerun that and go, hey, what the fuck does this look like? I think 0.5 is too much. It's too aggressive of a...
Yeah.
So
Yeah, for sure. Like when you
First thing,
found before
square.
with that.
I'm going to square it because then it makes it only 0.25. And also, and then we can like correct our correction factor later as well. Oh, okay. So, first off, that made it way, that almost fixed it, basically. Now, is that squaring it that almost fixed it? Because look, you see this side's still got a row of pixels. So this side, which is the x is wrong, and it's that we're subtracting somewhere. So I think it should be that these two should be minus x. So I think it should be all positives, all negatives.
It's definitely close, yeah. So yeah, the values are just too big, essentially. So
See, but that doesn't make... Why did this fix it, though? Because these values are definitely wrong. Ah, look, these are wrapping around. Wait a second. That's even more confusing. So it's fixed at the edge, but as we get closer to our 0.5, we get closer to 0. Look at it, you can see our curve where 0 is not enough.
Okay, so if 0 is not enough, then we can just always apply a tiny little amount. That might be enough to get it working.
So we need like our const offset.
Wait, okay, so now that okay, now I'm like wondering if now that we've fixed the base normals and stuff, if we make it just a constant, would it go back to just working?
Well, my thing is that what confuses me is that there's no way that this is correct in that 0, 0, so it's 0, 0 plus plus means that this one has to be positive, positive, negative, negative. Otherwise, we end up, what we're doing is we're going to negative, which is why it's wrapping around. But what I'm saying is when I actually make that change, it just breaks. Maybe it's wrapping diagonally down because I haven't actually got the y correct. I just feel like I've got it correct because it's also just 4 positive. But does that fix this side? I feel like it may have made this side worse. No, so this side still has all its pixels, but then this side has a whole row of pixels. But it's like the opposite. It's like where 0 is correct now, but like they go to worse. Because you're sampling too far. The X is sampling too far, which is that these shouldn't be negative. What the fuck?
Oh crap! It's already 4.
Yeah, no, I know, right? Oh, jeez.
I need to start going to bed.
Rainbow bullshit.
All right, so oh, yeah. So I need to start heading to bed. So I will wish you a good night. And
Okay.
yeah, I'll let you just play around with it. I guess we shall see next time you stream.
Okay.
If
I might
magically
make the I'm gonna make the chunks a little bit better. So instead of using the noise like we're using, I'm gonna make like the north, the plus Z and the minus Z chunks solid colors, so that I can see the axes that is wrong and the error that is being generated.
That's a good idea. Yeah.
Well, you have a good night. I should probably go eat. So I might actually I might end the stream and I'll work on this off stream and then come and do it. Like, so I'm not trying to talk the whole time. Stop and think and.
That's performance pressure.
Yeah. All right. I'll let you go to bed and I might stream tomorrow, hopefully. All right. Thank you for tuning into the stream. Yeah, I'm probably. I hope I'll stream again tomorrow because it's and it'll be Friday. And hopefully I can have this working by tomorrow, because it's really annoying that we're trying to fix this, and we're spending like all day trying to fix this instead of like working on fun things like World Gan and stuff like that. But thank you all for tuning in, and I will see you